I'm James Gosling, and this is a Star 7.
Hello everyone! Welcome to the second day of Devoxx Ukraine 2020. My name is Ira and I moderate the third stream of the conference. I hope you are doing well and you are ready for the amazing journey through our today's agenda. Before we'll start, I'll share some information about our navigation. So if you joined us first time, you can follow to the page devoxx.com.ua and find all the information here. Also, you can find the button Watch Devoxx online and find the next page with the streams. Now you are in the stream 3. Please stay here. I will do my best to create the great atmosphere. Under the stream, you can find a video and a chat. Here you can communicate to each other and write some questions to speakers. But under the chat, you'll see the link to Q&A room. Please don't go here right now. All our speakers are in streams. Visit Q&A rooms in Zoom after the speech. Under Q&A, you can download our mobile application via QR codes, and here you can vote for best speaker or best presentation to choose the best of Devoxx Ukraine 2020. Also on the page you can find our partners blog. Here you'll see all our partners who support Devoxx 2020, and also you can find all activities that they provide for you, giveaways, interesting quizzes, online activities, so feel free and don't miss something interesting. Okay, that's all about organizational details. Let's go to our first speaker. I'm happy to invite our first presenter. It will be Julian Simon. Hi, Julian. How are you today?
Hello. I'm good. How are you?
Have you already woke up?
Yeah, it's fine. It's I'm really happy to speak to all of you this morning. I wish I could be in Ukraine, and I've been there many times. It's a place that I really like. Unfortunately, we have to stick to online videos, but I really hope we can soon be in the same room and have a great conversation. The sooner the better.
Yes, I hope. Let's do it next year. Let's imagine. And what topic have you prepared for us today?
Well, this morning we're going to, I think, start the day in style. It's an introduction to machine learning, what machine learning is, how can you easily get started with your machine learning project, sharing some best practices, and then walking through and demoing some of the services that AWS has built for people who are just beginning with machine learning or people who already have a bit of experience. So yeah, lots of real life advice and of course lots of demos and code, right? Which is what we like.
The stage is yours. I'll come back after you'll finish.
All right, thank you very much. Okay, so let me share my screen, full screen, and we can get started. So Again, good morning, everybody. Thank you very much for joining me this morning. We have a long session. We have lots of stuff to cover. So my name is Julian. I'm a tech evangelist working with AWS. I've been working with them for about 5 years now, and my role is to help developers and customers understand how to build quickly and easily with AWS services. So, like I said, we're going to start with a primer on machine learning because I'm guessing most of you have never really practiced machine learning, so we've got to get our definitions right, understand what this bizarre thing is, and what are some of the technical issues and challenges that we need to focus on. Okay, so we'll start with that. Then we'll talk about starting your machine learning projects, figuring out which tools to use and how to organize the projects, which is, I think, a really important topic if you want to be successful. And then we'll start looking at services. Okay, so let's start with a few basic definitions. Okay. Whoops. All right. All right. Okay, so the first thing is we hear constantly about AI and machine learning. Is there a problem with the screen? Oh, you don't see the full screen. Okay, that's okay. Let me try screen sharing again then. Okay, so now you should see it. Yes. Um, oh, I see. Okay. Okay. All right. Yeah. Okay. All right. So, no, that's okay. Um, looks like I just not sure which screen it's sharing. Okay, it's kind of weird because I'm sharing the right one, but okay, anyway. All right, we'll figure it out. No worries. Okay, here we are. Okay, so here we are now. Fine. So the first thing we need to get clear, to get out of the way, is AI versus machine learning versus deep learning. You hear those words thrown around constantly, and not everybody's super clear on what they mean. So really quickly, just to set the scene, AI is the high level domain, right? AI is a 60-plus-year-old domain, and it's focusing on designing and building software applications which exhibit human-like behavior, right? So building apps that can use and understand speech and recognize images or videos, use natural language, and show some kind of reasoning, intuition, the ability to solve complex problems. So, of course, inside of AI, you have tons of different domains over time. And again, expert systems and computer vision and speech synthesis. You have lots of different things in there. But as it turns out, one of those domains, which obviously is machine learning, got very successful because it just proved to be very effective at solving hard problems, pretty much. And so machine learning is a capability for machines to learn from data sets using statistical algorithms, okay, without being explicitly programmed. And what I mean here is, of course, when you write, let's say, business rules in your business applications, you explicitly state what you want to achieve, right? You want to, you manipulate data, you process it, and you get some kind of output, and that's your answer. So it's really your code explicitly doing whatever needs to be done on the data. Machine learning is completely different. Machine learning starts from data sets where features, so let's say columns, right, variables, are clearly visible. Imagine, something like looks like an Excel sheet, or a CSV file. It's pretty clear what those columns are and where they come from. And then you use probably off-the-shelf algorithms to learn how to predict a certain value in this data set. Okay, so that's the main difference. Instead of writing your application code, you use existing algorithms to extract patterns and insights from data sets. And deep learning is a subset of machine learning. It does the exact same thing, except it's focusing on a single technology, and that's obviously neural networks. Okay, it uses neural networks, all kinds of different architectures, to extract information from complex data sets where features cannot usually be easily expressed, right? Think about, again, images, videos, speech. It's not easy, you can't put that stuff in an Excel sheet. That's what I mean, right? What are the features in a picture? What are the features in a music clip? It's not obvious. So neural networks are great at figuring out automatically what the patterns, what the useful information is inside those data sets, right? And they're very mysterious and complex, but they're great at this. Okay, so artificial intelligence, high level topic. Inside of that, machine learning. Inside of machine learning, deep learning. Okay, so now that we're clear, let's talk about the main two ways you can do machine learning. So the most common way, I would say, is supervised learning. So it's exactly what the name says. You will show the algo what the correct answer is on your data set, and the algo will learn how to correctly predict this answer. And if the model is built correctly, it's going to be able to generalize to other data, right? To data that obviously the model has never seen before. Okay, so the key thing here is, of course, you need to label the data set. So for example, if you're building, let's say, a fraud detection model for credit card transactions, you're going to say, okay, this transaction is legitimate, this one is legitimate, this one is fraudulent. And the model will learn how to correctly predict the right answer. Okay, and as you can imagine, building the data set, labeling the data set is a lot of work, right? It's very time consuming, and we'll get back to that. So classification is a very popular use case for supervised learning. So it could be binary classification, yes or no, true or false, legitimate or fraudulent, those problems. You can have multi-class classifications where you try to classify, let's say, images in 50 different categories. And you can have also regression, which is basically a complex word to say, I want to predict a numerical value. I want to predict the price of a house. I want to predict the number of traffic jam kilometers in Paris tomorrow, etc., right? So that's supervised learning. And then you have unsupervised learning. And unsupervised learning, as you can guess, doesn't require a labeled data set. You start from the data set, the raw data set, and that's it. Okay? And the model will, without any information, the model will find some patterns and organize samples. So a good example of that is clustering. Okay, grouping your samples according to their statistical properties. Okay, so trying to say, I think let's say I have a customer database, and so I build a data set from the customer attributes, and I want to see how I could group customers in 3 groups, right? Because maybe I'm thinking, hey, I have, bronze and silver and gold customers, whatever that means. Let's see if a model can pick that up. Okay, topic modeling is a similar technique to group lookalike text documents that are based on the same words, right? So both techniques are really useful. So when would you use those? So this is really, I mean, this is not as clear cut as, as this, but I would say in general, supervised learning lets you build very sophisticated models, very advanced models. So all the crazy computer vision and natural language processing that you see out there is based on complex supervised learning use cases. Okay, so that's the y-axis. And the difficulty here is usually those models require lots of data and lots of labeled data. So building the data set is going to be lots of work. Okay. Unsupervised learning lets you achieve less sophisticated tasks, like I said, grouping or simplifying the data set. But it doesn't require any labeling, and it usually doesn't require as much data, right? Because you're working with just the statistical properties, and it's enough to get the job done. You don't need a million samples to figure that out. There's another technique which I'm not going to discuss at all today, which is called reinforcement learning, which can work even in the absence of data. Reinforcement learning is based on letting an algo explore some sort of simulated reality and figure out by itself how to do the right thing. Okay, so things like playing video games, which is of course the popular thing, but the silly thing you can do with reinforcement learning. Reinforcement learning is heavily used in robotics, in the stock market, in energy management, all those very dynamic, very chaotic problems where building a data set is really just not an option, and so you have to do something different. Okay, but I won't discuss that today. So just to give you a sense of what those algos are, this is the list of algos, or some of the algos that are available in a popular machine learning library called scikit-learn, which I'm sure you've heard about. And so we can see the different topics here, right? Classification, regression, so predicting numerical values, clustering, so grouping things that are similar, and dimensionality reduction, which is a way to take, in a nutshell, data sets with a huge number of columns and reduce the number of columns to a smaller number, which simplifies training and removes correlation between all those columns, etc. So this is a really cool map, I think, because it shows that there are so many algos you can pick, and depending on what you're trying to do, you can go left or right, and even then, try potentially different algos for the same problem. So that's the kind of thing we have in mind when we say machine learning. Okay, start from data, figure out the problem we're trying to solve, and then go and experiment with different algos, build some models, see if they're accurate, and repeat. Okay, so just a quick example. Decision trees are a really popular family of algorithms. So it's a supervised learning algo. And the purpose is we want to build a decision tree that lets us go left or right based on certain feature values, and hopefully getting all the way down to the tree and getting the right answer, right? So we're used to working with decision trees and flowcharts, and this is pretty much the same thing, right? So we start from a data set which has a number of features, a target attribute. So maybe it's the identifier for the class we want to predict. This is a fraudulent transaction, or this is a legitimate transaction. And so we look at features, we look at certain value thresholds. So if this feature is lower than this, then go left. If it's higher than this, go right, and repeat until we get to the bottom of the tree and we have our answer. Okay, so that's what we do here. And they're popular because they're pretty easy to understand. It's pretty easy to understand how those models predict, the whole explainability issue, right? And there are lots of variants. I'm sure you've heard about XGBoost, which is a very, very popular algo out there. Okay, so this, when we say machine learning algo, this is what we mean. And the whole the name of the game is to figure out all those parameters automatically. Okay, which features do we use to split? Which thresholds do we use to split left or right? So that's the purpose of the training process, getting to those parameters. Okay? So if we step back a little bit, then the machine learning cycle looks something like this. Okay? We start with the business problem. Okay, and that sounds obvious, but trust me, some people want to jump to neural networks within 5 minutes because they think it's the answer. But I always advise you to step back, have a cup of coffee and think about what is it you're really trying to solve. Okay, so maybe you're trying to classify images, maybe you're trying to classify fraudulent transactions, maybe you're trying to translate French to Ukrainian, etc., etc. Okay, and then you can start framing the problem, which really means understanding how this could be a machine learning problem. What kind of data would you need? What kind of algo maybe would work? How much accuracy could you probably expect from that? Okay, and not all problems are machine learning problems. Sometimes you'll figure out, well, no, data cannot really help me, so I need to find something else. So assuming it is a machine learning problem, then there's a whole bunch of tasks related to collecting data, cleaning, preparing data, putting everything in the same place so that your data scientists and machine learning engineers can start experimenting with it. And this step, if you talk to data scientists, they'll tell you this is anywhere between 50 to 80% of their time. It is the dominant task in machine learning. Then you can start experimenting, visualizing, computing some statistics, maybe building some features, some extra features in your data set to make it more expressive. And then you can move on to training and tuning the models and measuring accuracy. You will usually iterate quite a few times until you get to where you want to be. And then at some point you have a model that you like and you can go and deploy it and use it for predictions. And probably that's where the real problems start, because you're in production land now. You're not in your machine learning sandbox. So if you deploy models that are used 24/7 by business apps, then monitoring, scaling, debugging, logging, all those good things become really important. And at some point you will have to retrain to account for new IDs, new data, etc. So that's the machine learning cycle. And you can see, obviously, you're going to iterate constantly here, right? And you're going to need all kinds of tools and all kinds of infrastructure to do that. Okay, so that's what we're talking about when we say, hey, I'm working with machine learning, not just neural networks, not just algos. There's a whole bunch of other things to be dealt with, especially data collection, data preparation, and all the operations related to machine learning in production. Okay, so this is probably more complex than you thought, right? This is probably not as simple as, oh, I can just click and train a model. So let's move on to how you can actually get started with this. Okay, how can you actually start entering that machine learning cycle, right? So the first thing is you need to set expectations, right? People have all those crazy ideas about machine learning, and it's crucial that you know what the target is. So what's the business question you're trying to answer? Okay, and it should be simple. It should be one sentence on the whiteboard. It must be quantifiable. Okay, it must be very clear what you're trying to achieve. So for example, we want to detect fraudulent transactions with an accuracy higher than 99%. Okay, or we want to we want to forecast our monthly revenue within plus or minus 1% of error, etc., etc. Right? Something simple, something crisp, something you can quantify. Okay. Then the second thing is, do you actually have data to do this? Because by now machine learning needs data. So if you have zero data, well, that's something you need to think hard about. Okay. Do you have that data? Can you even collect it, right? Can you even find, buy, or partner or with someone who has that data? Okay. Then you need to involve a lot of people. It's not just data scientists, right? It's a business problem, so you need business people to make sure everybody understands the implications. You need IT people because they will be managing your models, and ops people as well. And of course, you need data engineers and maybe DBAs and of course data scientists. So it's a group effort. It's not just someone in a dungeon somewhere with a bunch of data sets who's going to come with a magic solution. That's not happening, right? It's everybody has a piece of the puzzle, so you need all those people around the table. So these are red flags that you should look for. So if somebody, your boss or a customer, anyone says, we want to see what this technology can do for us, this is not a business question that you're trying to answer. This is not quantifiable. Okay, so this is a red flag for me. This is another one, and by the way, these are all real life examples. I'm not making this up. Right? I still hear this on a regular basis. We have tons of relational data. Surely we can do something with it, right? And I can't see you, but I'm seeing some of you say, yeah, that's what I heard last week, right? I'm sure you hear that stuff. And my favorite, which is, I read this super cool article about Foobar ML. We've got to try it. You know, the hipster, hype-driven technology syndrome. That's awful. So no, that's not working. So all that stuff is a no-go. Just don't do that. Okay. Just don't do that. Find a real problem to solve. Okay? Yep. Nope. Hell no. Right? So you got to be strong and fight against this. The second thing is you want to define clear metrics. Okay? So what's the business metric showing success? Because at the end of the day, if you're trying to solve a business problem, it has to have some positive impact somewhere, right? So think about that. Do you have a baseline that you're comparing against? Maybe you're trying to automate a human workflow, or maybe you have a legacy IT system that's kind of doing the same thing and you want to replace it with machine learning. So what's the baseline here? What's a significant but reasonable improvement, right? Again, machine learning is iterative, so just define what would be considered successful, but be reasonable. Okay, and think about the improvements. So maybe you could say, all right, we want to reduce fraud detection errors by 5% every quarter or every semester, and then that's good, right? It's a long-term thing. So again, machine learning is full of jargon and mumbo jumbo. It's quite bad. And unfortunately, it's difficult sometimes for machine learning experts to express progress, right? So if a data scientist tells you, that person's super excited, they come to your desk and they say, the confusion matrix for a support ticket classifier has significantly improved. If you're not a machine learning person, you're going to go, what? And then that person's going to say, well, you understand, P90 time to resolution is now under 24 hours. I'm like, yeah, okay. Why do I care? So with a little more conversation, you're going to get to the impact is, misclassified emails. Let's say this is a support use case, right? A customer support use case. So misclassified emails have gone down 5.3% using the latest model. So, okay, that sounds like an improvement, okay? But at the end of the day, the business metric you want to see progress on is how happy are your customers, right? So if then you get to the latest survey shows that very happy customers are up 9.2%. Yeah, that's good, right? That's something you can go to the CTO or the CEO or whoever and say, see, this model really works. So that's the kind of thing you want to look for. That's the kind of metric you should have in mind. And of course, you need the technical metrics and you need the crazy ML metrics. They're important, but they need to be related to actual business metrics. The third thing is you need to assess what you really need and not what you want, right? And of course, with respect to your skills. So, can you build a data set that describes the problem, right? Is that something you can do? Can you clean, prepare, curate it over the long run? Do you have those tools? Do you have those skills? Can you write and tweak machine learning algorithms, or is that out of scope? Can you manage ML infrastructure, and is that really needed? So the point here is, as you will see in a few minutes when we start talking about services, there's a very large scope of services here, right? So from the fully managed, click and get the job done, to do everything yourself, there's really a very wide range of things here. So you need to figure out where you stand on that in that spectrum. What do you need? What's the shortest path to success? Then once you have, kind of an idea where you are, of course, you need to pick the best tool for the job. And well, there is no silver bullet. So if you have to pick between cost, time, and accuracy, you only get to pick two. Okay? Sorry, life is hard. So you can have a very inexpensive solution and bring it quickly to market, but it's going to be less accurate, right? And on the contrary, if you want a very accurate solution, and you want to, you're ready to spend, some money on that. Well, time to market will be longer, because you need to invest more and you need to just work harder at getting the extra accuracy. So you only get to pick two of those things, right? So pick the right ones. So again, the least expensive and the fastest option is probably not the most accurate. Still, it's enough to get started, maybe, and understand the problem. Yeah? Build maybe a POC, demonstrate some initial business value, and get some buy-in, get some sponsoring for your project to actually go deeper into ML and build a longer-term project. Okay. And yeah, improving accuracy will increasingly take more time and money, right? It's not too hard to get to 90%. It's hard to get to 95. It's crazy hard to get to 99. And it's unbelievably hard to get from 99 to 99.5, 99.6. And of course, the more you want, the harder it gets. So it's really diminishing returns. So you need to know when to stop. Right? At some point, it doesn't make any sense to go and chase extra digits because you've got good enough accuracy, and the cost versus benefit ratio is just not there. Okay. There's a lot of talk about state-of-the-art models, and it's very easy to get excited with all the crazy models that are out there. I would say you have to be pragmatic, you have to be reasonable. So anything that is actionable right now based on your skills and resources could be interesting, right? So techniques like transfer learning, AutoML, etc., they definitely need to be looked at. But be careful, if you read about this fantastic new model designed by, whoever, one of the technology leaders in the field, it might be extremely complicated to use, and it's not because it worked for them that it's going to work for you, right? So again, hype-driven machine learning is dangerous, and it will usually be disappointing. So stay pragmatic. And of course, you need to use best practices. Okay, so that's one thing I'm constantly fighting. No, things are not different this time. AI and machine learning is software engineering. It's not something else. Okay, we're still working with software tools. We're still working with data. We're still working with infrastructure. We're still trying to deploy stuff in production that works. So how is that different from everything we've been doing in the last 30 years or 50 years, right? So, using development tools, development environment, having QA, having documentation, using agile techniques, versioning, etc., etc. Everything that you use as a software developer still applies to machine learning. This is a very controversial opinion. This gets me into a lot of very heated discussions with data scientists and researchers. But okay, I'm happy to have the discussion again and again and again. Okay, you need best practices. Again, some person in a dungeon with 6 months and tools that no one understands and no one can replicate in production is not going to lead you anywhere, right? We need experts, but we need solid industrial processes that can yield quality models in production. Okay, so the truth is in prod, so I would recommend getting there fast, as often as needed. Sandbox is nice, prod is better. Okay, so if you think about CI/CD, automation, and DevOps for machine learning is what I mean here, then fine. Because otherwise, that's what you're looking for. That's experimenting in production. And if you saw that movie, then you know how it turned out. It didn't go too well for some of these people. So everything looks okay when you're in the harbor, and then you go out sea, and things are a little different. So go at sea as quickly and as often as needed, and figure out what works and what doesn't work. And last but not least, iterate, right? This is the most important thing. We saw this machine learning cycle, and by design, it is an iterative process. So start small, start with simple IDs, simple data sets, and simple algorithms, right? And learn and iterate, okay? So always try the simple things first. Don't go for the crazy deep learning architecture that supposedly solves everything. Why don't you try linear regression? Why don't you try decision trees? Why don't you try the basic algos that you can understand? Maybe they're certainly not going to be accurate enough at first, but they give you a baseline. They give you some reference accuracy that you can then use to see if the other things that you try actually help improve that. Okay, go to prod quickly, or at least to your production environment where you have production data. Run some tests, observe prediction errors, figure out why this thing is not predicted right, and then decide what to do, right? So is my data set wrong? Is it incomplete? Do I need more data, or should I tweak or experiment with another algo? And all these are possible options. Okay, and just repeat until accuracy gains become irrelevant to your business problem, right? And move on to the next project. Okay, so as you can see, machine learning, yes, can be complex and a bit mysterious, but there are proven effective ways to get started, provided that you focus on the business problem, you focus on your skills, and you focus on the objective you're trying to achieve, right? And then it becomes a little clearer which tools you should use. So talking about that, let's see how we can try and help you do this, okay? So as you probably know, machine learning is quite a thing at Amazon, and here are some examples over the years. Of course, I'm guessing everybody is familiar with the product recommendation and personalization on the Amazon websites. It's really it's a now mainstream feature on all the retail websites out there. And of course, all that stuff is based on machine learning. But there's also tons of machine learning running under the visible iceberg. So all the back end and all the back office tasks at Amazon are heavily run by machine learning. So from logistics to delivery to customer support. You've certainly seen those Amazon robots moving around in the fulfillment centers. So if you ask me what's the secret, At Amazon, well, the secret is customer obsession, of course, but the technical secret is probably machine learning, automating, making everything super efficient. And then, of course, we use machine learning to invent new product families like the Echo devices and the Kindle, etc. And all these, of course, use machine learning in one way or the other. And we have, more use cases like, the Amazon Go grocery stores in the US, where you just walk in and walk out without going to the cashier, because we automatically figure out which products you pick in the store. And drone delivery is being worked on as well. And again, all this stuff is based on ML. So we have some very, very cool stuff happening inside of Amazon. Now, of course, my job at AWS is to help you do the same, right? Is to help you use the services that we build, listening to your needs, and then show you how to use those services and get started. Okay, and it doesn't matter if you're brand new to this, if this is the first machine learning talk you ever attend, or if you're already doing it. We think we can help you deliver more interesting, smarter, more innovative applications and services to your own customers. So as it turns out, we see all kinds of customers. People often ask me, what's the typical customer for machine learning? And there's no answer to that question. It's literally everybody. We have tens of thousands of active customers who run AI and machine learning on AWS, large enterprise or startups and public sector and universities in all industry segments, right? People keep talking about financial services and retail, but it's also manufacturing and life sciences and education and sports, literally everything. So if you want to explore some of these references, you can go to this URL and you'll find customer use cases and quotes and lots of content showing you the extent of what AWS customers achieve using machine learning on AWS. So how do they do that? Well, it's time to start diving into the stack a little bit. And we have over time built quite a few services. When I joined AWS 5 years ago, you could fit all the AWS services on one slide. There were probably about 50 services when I joined, okay? And now we're getting to a point where it's difficult to fit the ML services on one slide, right? And it's certainly going to be even more difficult after AWS reInvent, our conference. I'll mention reInvent again at the end. So this is what we've built over the last 4 years. And as you can see, we've organized those services in 3 layers, okay? So today I'm going to focus on the top and the middle layer, and I'll say a few words at the end about the bottom layer, which is really more specialized and hardcore, right? So not exactly our topic today. So what are those 3 layers? So the top layer is called AI services. And what we mean by that is these are high-level services where for most of them, you don't need to do any training at all. Okay, you just call a cloud API, pass your data, get an answer. Okay, and I'll show you some, of course, we're going to do some fun demos in a few minutes. So things like analyzing images and videos, or analyzing speech, or analyzing text, etc., etc. Okay, so these are based on pre-trained models that we train and optimized on very large data sets so that you don't have to. Okay, call an API, get the job done. Now, in that layer, we have another group of services such as Amazon Personalized Forecast, Fraud Detector, where you can bring your own data, right? You can absolutely bring your own data set in a simple format. And by calling just a couple of simple APIs, you can train a model but without the need for any machine learning knowledge, because the machine learning knowledge is built in, right? And I'll show you quickly Amazon Personalize, which is a service that lets you build recommendation models. And then we have a few more things. We have a machine learning powered search engine called Kendra. We have a chatbot service called Lex. We have a new pretty cool service called Code Guru, which is which uses machine learning for code reviews. Okay, so based on the pull request workflow, you send pull requests and to your on a repo, and of course, and Code Guru is going to inspect the pull request, and it's going to suggest, detect potential problems and suggest fixes. Okay, so that's pretty nice. And you can also do application profiling with Code Guru, detecting performance problems, bottlenecks in production. So for strictly the development part of the software engineering process, this is a pretty cool service. Okay, so that's the thing. So if you're completely new to AI services, if you're completely new to machine learning, excuse me, AI services is probably where you want to go. Okay. Now ML services are one level down. Okay, and here the rationale for this set of capabilities, which are part of a very important service called Amazon SageMaker, the rationale is that we want to give you full control over the machine learning process. So you can bring your own data sets in whatever format. You can bring your own machine learning code based on whatever open source library you use, or maybe your own custom code, right? So full control, full flexibility, but without having to manage any infrastructure, as we will see, right? Infrastructure becomes completely transparent, so you don't have to spend a minute on it, and you can focus on the machine learning problem. And on top of that, we bring high value machine learning capabilities that help you solve and go quickly through that machine learning cycle, right? So training, debugging, data preparation, data labeling, pretty much all the boxes in that cycle are covered, right? And these are really very high productivity tools that help you go faster from experimentation to production. And frameworks and infrastructure is exactly what the name says. So of course you'll find all the Amazon EC2 instances, CPU, GPU, FPGA. We have a custom chip called Inferentia. So I'll say a few words about that. So all the infrastructure that you need to build your own ML platform inside of AWS, if that's your goal. And of course, we have software tools. We have prepackaged all the popular machine learning libraries inside Amazon Machine Images for virtual machines and inside containers, so that you can just go pick those tools and fire up whatever infrastructure you want to build. Again, saving you time, not having to install anything and getting to work quicker. Okay, so let's start exploring. Those services. Okay. So I'm gonna do some demos. So let me leave this. All right. Okay. Let me grab my browser here. All right. So we're not gonna go through all of them, but I've picked a few that I like and I think you should like, and we can go and try this. Okay, so let's maybe try recognition first. Okay, so recognition is about analyzing visual content, images, videos. So here I'm using the AWS console. If you've never used AWS before, maybe I should explain. So the AWS console is a web app that lets you very easily use AWS services. So it's great for experimentation and learning, and of course demos, right? And everything I'm doing here is based, of course, on APIs, right? So anytime you see me doing something here, I'm actually calling an API, which you could call as well, in your favorite SDK, right? Whatever language you want to use. So let's try let's try face detection. Okay. All right, Sam, let me pick an image. Okay, let's try this. Okay, so here what I'm doing is I'm uploading an image to the service. I could also pick an image that's hosted in Amazon S3 or storage service, and I'm calling an API in Rekognition, which is called detect faces. Okay, so we can actually see the request here, right? So we pass the image, and we get a JSON response where we see bounding boxes, right? So coordinates for the faces, and we see attributes, right? So like I said, every time I'm doing something here, I'm actually calling a service API, and which you could call in Python, Java, PHP, using any of our SDKs. Okay, so we can see, all the faces in there have been correctly detected. Okay, and we see some attributes, and right there are a few more. So this is clearly a machine learning powered solution, right? Based on deep learning models, etc., etc. So of course you could try and build this yourself, right? You could try and train a face detection model on a large image data set. But is that really needed, right? I mean, if this works for you, and this is really one line of code called the detect faces API, and read the answer, then job done, and you can move on, right? So this works pretty well. Now we can do another thing with this. We can try and do celebrity detection, right? So you'll know best. I'm afraid I'm not familiar with the names, but you'll know best. So again, here we're detecting faces, and we're trying to match them to known people, right? So sports players, artists, politicians, business people, movie stars, etc., etc. Right? So very simple. So you can see that's how Rekognition works, right? We have a different API. So this is the detect celebrities API, I think. And you can compare faces. You can detect text and images. Yeah, we could try that. See if it picks up that flag. Yep. So we can see. So it actually detects. Oh, that's interesting. It detects some of the numbers on the jerseys, and it does detect the text here, right? And of course, again, we would see this in the response, right? We get the coordinates and everything, right? So this is the detect text API. What else can I show you? Yes, image moderation is kind of fun. So we can detect explicit content or suggestive content, and we also added violent content detection. So let's give it a shot. Okay, so what does it tell us? It says violence and weapon violence, which is pretty much what this is about, right? Okay, and you can see you get your simple JSON answer with the labels. Okay, so super simple to use. You can start using those things in minutes, right? And we recently added personal protective equipment detection, which is of course a major concern for everybody now. If you want to have an automated solution to make sure workers and staff are properly protected, then you can do that, right? So we can go and select face cover, hand cover, head cover, etc., etc., right? And then we would know whether some people are correctly protected or not. That's a pretty cool feature. You can do the same on video. Pretty much all those features are available for video analysis as well. And another thing you can do with Rekognition is you can actually train your own model, but in a very simple way. You bring, it's called custom labels, and you can just bring your data you bring your data to Amazon S3, right? And in a simple format, and then you train your own image detection model in there without having to go into crazy deep learning, etc., etc. So it's a pretty interesting solution. Okay, so that's recognition. Let's try Polly now. So I'm going to close this. So Polly is text to speech. Okay, so let me switch to my speech so that you can actually hear this. All right, let's give it a try.
Hi, my name is Joanna. I will read any text you type here.
Okay, so that's pretty much what it is. So this is the synthesize text API. You just pass the text, you pass voices. So each voice has a name and of course corresponds to a certain language. And you can see the list of languages here. So if we want to try, let's try Norwegian, why not?
Hei, jeg heter Liv. Skriv inn noe her, så leser jeg det opp.
Okay, so you'd call the API, say, hey, I want to say this using Liv's voice, and that's it. And either you save that output to let's say an MP3 file and play it later, or you get a byte stream that you can play immediately. Okay, so this is super simple, and you can see it has quite a few voices, right? Yeah, lots of different things. So we actually have different engines. So initially there was the standard engine, and then we came up with the neural engine, and the neural engine actually generates the waveform. So the sound file that you hear is actually a generated waveform built by a deep learning model. So it sounds more natural, it sounds more precise. This might be a little difficult to hear on the loudspeaker and the mic, but okay, let's give it a shot.
Hi, my name is Amy. I will read any text you type here.
Right, so it sounds just more fluid and simple. So let's try maybe a longer piece of text. Okay, so here's the standard voice, and let's try maybe Emma.
Barcelona presidential hopeful Toni Frakes has admitted that club captain Lionel Messi will have to lower his current wage at the club in order to renew his contract. The Argentine superstar's contract expires at the end of the current campaign, and he will be free to negotiate terms with other clubs from January 1st, should he not renew his deal ahead of that point.
Okay, so that's the standard voice. Pretty good. Now let's try neural. It should sound, again, probably difficult to hear, but you can easily run your own tests.
Barcelona presidential hopeful Toni Frakes has admitted that club captain Lionel Messi will have to lower his current wage at the club in order to renew his contract. The Argentine superstar's contract expires at the end of the current campaign, and he will be free to negotiate terms with other clubs from January 1st, should he not renew his deal ahead of that point.
So just a little bit more fluid, a little bit more, human-like. And there's another cool feature. So here I'm passing plain text to Polly, but we can actually pass SSML. So SSML is a markup language that lets us specialize how the speech is actually spoken. So let's grab a piece of SSML. Okay, and let's give it a try. So basically just tags, and I can use this newscaster style, and you'll see the difference. You'll hear the difference. What am I doing wrong now? Do I have a typo in there? No. Okay, just probably using the wrong voice.
Barcelona presidential hopeful Toni Frakes has admitted that club captain Lionel Messi will have to lower his current wage at the club in order to renew his contract. The Argentine superstar's contract expires at the end of the current campaign, and he will be free to negotiate terms with other clubs from January 1st, should he not renew his deal ahead of that point.
So you can hear that, there's this news, news broadcast style. This is really the type of speech you would hear listening to the radio or the TV, compared to the more plain tone that is used if we don't set this newscaster style. So this is pretty cool. You can do all kinds of funny things with SSML. You can speed up, slow down, insert breathing pauses to make the voice even more lifelike. So if you need to generate sound or voice messages for your applications, Poly is just a very, very simple and quick way to do that, and with very good quality. All right, let's move on. So Poly is text to speech. Now we can look at speech to text, right? And this is a service called Transcribe. And Transcribe has this cool feature called real-time transcription. So we can run batch jobs, just put some sound files in S3 and get transcriptions, but we can do it real time. So I'm gonna try real time. And I'm gonna try, I don't speak Italian or Spanish, and my German is pretty bad, so I'll stick to English. We have more languages for batch transcription, right? You'll find many more languages. For real time, we're only supporting those 4 at the moment. Okay, so let's give it a try. Hey, good morning, everybody. My name is Julian. I'm very happy to talk to you this morning and introduce you to machine learning. I hope you learn a lot and that you can start your own projects very soon. This is pretty accurate, and I'm quite satisfied with this demo. All right, that worked pretty well. So again, from an API perspective, what we're doing here is we're streaming data to Transcribe, and we're using the natural language processing capabilities to do a live transcription. So I'm sure you can imagine the applications here. You can do live captioning, you can do live transcriptions for audio and video content. We have customers who use this to transcribe university classes almost in real time. So by the time the class is over, then there's a transcription available, and you can share it with other students, or just archive it. Many different options here. Customer conversations, meeting notes. You don't need those anymore, right? If you have Transcribe, you don't need meeting notes. You'll have the notes, so you can focus on the meeting itself, right? So Transcribe is pretty nice. There is a medical version of Transcript for medical content, which is specialized with medical vocabulary, etc., etc. Same idea. You can do batch or real time, but it's been specifically trained to understand medical jargon, right? Okay, let's move on. So translate is pretty obvious, I think. So it's translation, of course. And again, we can do batch translation and real-time translation. Okay, so translate will automatically detect the input language, and you can see we have quite a few, right? And let's give it a try. So I'm going to start typing stuff, and let's see if we translate this to Ukrainian correctly. Okay, so you read Ukrainian, I don't. So let's check what I said. And let's translate this to maybe English. All right, yeah, that's what I meant. So hopefully this makes sense, right? So again, super simple service, and real time or batch, quite a few languages, including some pretty rare languages. We have some languages that I honestly didn't know about when they came out, so I had to actually read about them and figure out what part of the world those were from, and it's very interesting. So yeah, you'll find, I would say, I don't want to say all European languages, because of course there's always going to be one that's missing, but it's pretty much all of Europe, and a lot of Asian languages, and the African languages are there as well. So there's really good coverage now, right? Good coverage. And we have some variants, as you can see. Canadian French is a little bit different from French, and Mexican Spanish is a little bit different from Spanish, etc., etc. Right? So very cool service. And of course, I'm sure you have this idea already. You can combine those services, right? You can transcribe with Amazon Transcribe and take that output and feed it into Translate. And again, this is a single API call each time. So now not only can you transcribe your meetings or your classes, you can almost instantly translate them into a large number of languages, right? So very easy to combine those things. All right, let's do one more. So this one is Textract. So Textract is pretty much an OCR service, right? Optical character recognition service. But with a twist, we think it's a little smarter, because it can extract, of course, the text in scanned documents and PDF files, but it can also extract forms and tables. So let me show you here. Maybe let's grab this. Okay. So again, uploading this document to the service, or using a document in S3, calling the appropriate API, and getting a JSON answer. Okay, so it's a bit of a large document, and I don't have the fastest connection here. So let's see. All right, Textract, come on. Here we are. Okay, so yeah, that's why you don't want to generally upload stuff. You want those files to be in S3, and call it from there, and then it's almost instant. Okay, so it's a research article, so the layout is is pretty straightforward, I would say. It has some illustrations, it has tables, right? Yeah, quite a few tables. So of course, we did detect the all the text correctly, right? So we can click on everything here and see, oh yeah, it's in there, right? But we want to see if we have tables, okay? Because of course, if you want to extract information from a document, if you just get the raw text in the table without any kind of structure, it's very difficult to use that information. There's a table here for good reason. So if you want to process this document, you want to keep the table structure, and this is correctly picked up by Textract. So if you look at the JSON answer for this API call, you will see this table structure defined inside the JSON answer. So then you can maybe convert this to, I don't know, HTML, or you can push it into a backend, but at least you keep this data structure here, right? So let's try maybe a form, a proper form. So I think this is an insurance form, and of course I'm sure your companies use forms, most of them. So this is an easy way to process them. So again, the text is correctly detected, but more importantly, we can see the forms, right? So we can see, that address 123 Paradise Road is detected and associated to the label for that box in the form, right? So now you can really understand that these things are related, and of course you can insert this in your database and do whatever you have to do with it, right? So that's pretty nice. Okay, and the table here is again is correctly detected. Okay, so this is a really nice service, and that's for sure. It's a problem that that a lot of people have, figuring out what's in their documents, and text tracts make it, I think, pretty easy to solve that. Okay, all right. Let me show you quickly personalize, and then we'll move on to machine learning services. So, and the philosophy of personalize and forecast and fraud detector are very similar. So if you understand one, you understand all three, I think. Okay. So the problem I'm trying to solve here is, where's my editor? Here it is. Okay, I have a data set that looks like this. It's actually, it's called the Movie Lens data set, and it's a popular data set for movie recommendation. So what does this data set tell me? It says, well, I've got movie recommendations for certain users. So user 298 has liked item 474, right? Imagine this coming from Netflix app, and thumbs up, thumbs down, and this is a timestamp. Okay, so I've got all this information here, and I've got tons of those, and I'd like to build a movie recommendation model. And recommendation is, I believe, one of the harder problems in machine learning. Models are really complex. Data processing is very complex. So very few companies have the expertise to do that. So what we've done is we've built a service called Amazon Personalize, where all you have to do is bring this data and upload it to S3, call some APIs to train a model, deploy it, and predict. And baked into the service are all the best practices that Amazon has learned over the years for data preparation and algorithm selection and algorithm tuning, etc., etc. So you really, even if you have no machine learning expertise, you can do this. So the steps are really those, right? Upload the data. So it could be historical data like what we have here. You can also stream data, right? So you could stream those likes directly from mobile apps or web apps. And then you create a solution, which is basically a recommendation model. You launch a campaign, which really is deploying the model, and then you can predict. Okay, so basically it's one API call for each of those things. So upload the data set, right, which is this file that you saw. It's called the user item interaction data set because it's exactly what this shows, interactions between items and users. We could also add item information. If we had metadata on items and metadata on users, we could add that to the mix for increased accuracy, but this is the only mandatory one. And then I train a solution, and let me show you how you do this. You give it a name, and then you select a recipe, which is really, okay, what am I trying to do here, right? Am I trying to do similarities? Am I trying to do personalization, right? Or you can just say, there's actually an AutoML element here as well, where you can just say, now go and figure out what I'm trying to do. And then once you've trained the model, you deploy it to a campaign. Okay, and so you get a prediction API, right, which you can invoke. But here I'm invoking it with the console, and I could say, hey, give me recommendations for user ID 123, and immediately I get recommendations for movies, and I get scores telling me, how high, we should, if we want to only take the top 5 or the top 10. Okay, these are the top 10 recommendations, right? And I'm going a little fast here, but this is really what it is. And then you can run that. You can run the tutorial, and you'll see that even without any machine learning expertise, you can get your model ready, and you have this prediction API that you can invoke and plug, connect to your website or your mobile app, and then generate recommendations, right? And using your own metadata, you would know, movie 137 is whatever movie, and display the image for the movie and the title, etc., etc. But the machine learning part is completely taken care of. Okay, and again, forecast works the same for forecasting time series data, and fraud detection works the same for building fraud detection models. Okay, so very, very cool way to quickly get your models in production. Okay, so we've taken a look at quite a few of those, and now let's take a quick look at machine learning services. Okay, so machine learning services really mean Amazon SageMaker, right? And SageMaker was launched at reInvent 3 years ago, and over time we've added tons of different capabilities. So I will stick to the simple capabilities today, because again, this is an introduction, and there's no need to go too deep on all those crazy things here. But I will share some resources if you want to know more. Okay. So remember that machine learning cycle that we saw early on. This is kind of another way to express it. We need to prepare data. We need to build data sets and build models. We need to train models. We need to debug them. We need to optimize their accuracy. And of course, over time, as we iterate, we end up training hundreds of different models. So how do we keep track of everything? How do we compare them? That's another problem. And of course, the deployment and ops part, which is all about quality of service, quality of predictions, making sure the model predicts the way it should, and then of course scaling and high availability and all those good things, right? So that's really what we're trying to solve with SageMaker. And like I said, over time we've added lots of different capabilities to do all of this. Okay, from data labeling to data preparation, to development environments, to training environments, and advanced capabilities for model debugging and model tuning and model tracking. And then, of course, deploying and scaling your models automatically, detecting prediction quality issues, etc., etc. Right? So we're trying to cover the full spectrum so that you can really use your one service and one SDK to go all the way from experimentation to production, right? Now, having said that, some customers, they don't need the end-to-end experience, right? They just have a particular problem. So let's say you want to train in the cloud because you want to leverage, the GPU instances that we have, but then you want to grab the model and deploy it on premise because you have this constraint. That's okay. You can absolutely do that, right? Some people do it the other way. Some people have an existing model that they train and it works and it's still relevant, and they want to deploy it in the cloud because they want to scale there. So you can import the model to SageMaker and work like that. So even though we're trying to build this end-to-end experience. The last thing that we want is to say, oh, you have to go from A to Z. This is how Amazon is doing machine learning, and if it works for us, it works for you, right? And that's really, really not what we're about, okay? So we build the end-to-end thing, but we also make sure you can use each of these modules independently and just cherry pick what you need for your own workflow, okay? This is really important to me. So let's just give you a quick overview of what modeling options are available. So the first option is not to train anything at all. We have a specific category in the AWS Marketplace for machine learning models. So these are algorithms and models that have been designed and trained by AWS partners and that we checked, of course. And so they're readily available for deployment. So you can just go to the AWS Marketplace for machine learning, find a model that you like, that kind of looks like what you're trying to do, deploy it in SageMaker in just a few clicks, experiment with it. And if it works, then fine, job done, right? And most models are free to test, so you don't take any risks. And then if you want to deploy them for good, then you pay whatever fee the partner has defined for that model. Okay, but it's just a great option. We have hundreds of models in there, and they may very well save you from having to build everything yourself. The second option is a capability called SageMaker Autopilot, and it's AutoML for SageMaker. So you can kind of similar to Forecast, but and personalized. All you have to do is bring your data to S3 and define the column in the data set, the target value that you want to predict. And this works for regression and classification problems. And then Autopilot will automatically build a model for you, right? And it's not an opaque model. You actually get auto-generated notebooks that show you exactly which candidates were evaluated and how data was processed, how the model was optimized, etc., etc. And of course, you can replay the notebooks if you want to replay the AutoML process manually. Okay, so that's a very cool feature there. Now, of course, a lot of people who use SageMaker will want to use different algos and have a wide selection. So the first option, when it comes to actually training and selecting the algorithms yourself, is to use built-in algos. So we have 17 algos today, which are hosted in the different regions that SageMaker is available in. And there's statistical machine learning algos and some deep learning algos covering typical problems. And the good thing about that is you don't need to write any machine learning code. You only need to select one of those algos and use it to train, right? So if you're not familiar, or if you want just to not familiar with ML, or if you want just to go quickly, then these do the trick. Okay. The second option is to bring your own code. So maybe you wrote code for TensorFlow, maybe you wrote code for PyTorch, and so on, or XGBoost, and you have existing code and you want to run it on SageMaker. And I'll show you a demo of that in a minute. And this is extremely easy to do, right? This is extremely easy to do. So you can bring your own code and use it to train and deploy models on AWS. So if you're curious how those frameworks work, well, they're hosted in containers, right? All training and deployment activity is container-based in SageMaker, and we open source all those framework containers. So you can inspect them, train them yourself on your local machine, customize them, push them again to AWS to use them on SageMaker. I mean, you have complete freedom here. And the last option is full customization. If you need, for example, other languages like R or C++, or maybe you have your custom, you have a full custom Python container with all your dependencies. That's okay. You can build it, push it to AWS, and use it on SageMaker. Okay, so lots of different options here. Okay, and the common theme here is training and deployment, for that matter, is fully managed. So you never worry about building and managing infrastructure, and you can even use spot instances for training, which is a very powerful technique to slash training costs up to 75, 80%, right? So lots of options. Bring your own code. Don't worry about infrastructure. Okay. So let me show you how this works. Okay, we can close this. So this is the SageMaker console, and then here I'm actually using our web-based IDE for machine learning, which is called SageMaker Studio. Okay, so I opened it already. It's based on Jupyter. You'll be super familiar with it. There's nothing really strange about it. And let's run the first example based on XGBoost. So let me close this, maybe zoom in a bit. Hopefully you can read okay, right? So let me quickly check. Yeah, this is okay. Okay, so here the problem I'm trying to solve is I want to predict house prices based on a historical data set, and this is a well-known toy data set called the Boston housing data set. Okay, and we can see some of its samples here. So it's a CSV file. We read it with pandas. We display the first 5 lines, right? And it has a number of features. So, how much crime is in the area and how much pollution is in the area, and the distance to the city center, and the tax level. The things you would typically look at when you're trying to price a house. And the value of the house is actually this thing, the median value. So this is in thousands of dollars. It's a pretty old data set. So at the time, I guess you could buy a house for $24,000. Not sure you can do that today, but that's not the point. So anyway, that's the value we want to predict based on all those features. Okay, so that's the business problem. And it's reasonably simple to understand. It's a regression problem, and the metric we want to use here is how close do we get to the actual prices here, right? So we're going to use a mean square error metric that gives us a sense of how well we're doing on this data set. Okay, so we have 506 data samples. That's not a lot, but for our purpose, it's okay. All right. So there's not so much data preparation here. I just need to move that first column to the front because that's what XGBoost expects. The first column in the data set should be the value that you want to predict. Okay. So moving that column here. And then I'm splitting the data set in 2 parts. One that I'll use to train the model, and one that I use to check the model accuracy. This is called the validation data set, right? So you train on the training set. So of course the model understands those samples very well, and is trying to predict them as correctly as possible. But the model doesn't train on the validation data set. So checking on the validation data set gives you a sense of, does my model generalize to data it hasn't seen before? That's a really important practice, right? Don't use all your data for training. So I take 90% for training and 10% for validation. Okay. I save those different data set to CSV files. Okay. And I'm done with data. And now we can start with the actual SageMaker workflow, which is very, very simple, as you will see. So everything is based on the SageMaker SDK, which is a Python SDK to manage all training deployment activities inside of SageMaker. Okay, so I import this. The first thing I'm doing is I'm uploading my 2 data sets to Amazon S3. Okay, I'm creating a default bucket for SageMaker here, and I'm just putting those 2 CSV files in there. Okay, all data needs to be in S3, of course, right? We're using the cloud, remember? And we can see the two paths here, right? Okay, training set, validation set. Okay, that was very simple. Now, based on our experience, this is a regression problem, and we know that XGBoost is a good algorithm. It's a tree-based algo, just like the one I showed you earlier, and it's a good algo for regression, right? It can do other things, but it supports regression. So let's give XGBoost a try. So this is one of the built-in algos in SageMaker. So all I have to do is say, please give me the name of the XGBoost container in the AWS region I'm running in, right? And here you can see in my URL, I'm using the EU West 1 region in Ireland. Okay, so give me the name for the XGBoost container in Ireland. And that's all I need to do, right? This is enough. And now I can move on and configure my training job. So using this estimator object from the SageMaker SDK, which is the generic object to configure training jobs. I pass the container, the role, which is basically permissions, allowing me to access files, shouldn't say files, objects in S3, to pull the container, etc., etc. This role is taken care of when you set up your SageMaker Studio environment. And then I have to decide how much infrastructure I want to train on. So here I'm training on an M5 large instance, which is a good general purpose, medium size instance. Definitely more than enough for a simple training job like this. And this is as much infrastructure work as I will do here, right? Nothing more. No need to fire up machine learning, no need to fire up virtual machines, no need to set up networking, etc. Right? If you're used to working with Amazon EC2 and VPCs and subnets and so on, there's nothing like that here because SageMaker takes care of that for you. So if you don't like infrastructure, you'll be happy here. And then the output location, where to save the model in S3 again. All right. Okay. The last thing I need to do is to set some parameters for this training job. Of course, these are fully documented. Here, I'm doing regression. Okay, so I set the appropriate objective for XGBoost. Again, we could do classification and other things. I decided to train for 200 rounds, and you can say, why 200? And the answer is, I don't know. Sounds like a high enough number to get good accuracy, but in case accuracy stops improving after 10 rounds, then I want the training job to stop. Okay, simple. And of course, there are more black magic parameters, but in general, if you don't know what you're doing, then don't touch them, right? We have reasonable defaults, and they should be good enough. So just set the ones that are mandatory, or the ones that you really know, what they're doing. So here, let's play it safe, stick to the simple things. All right, and the last step is just to define our two training channels. So training channels are basically data sources that the algo will use. So we have a training channel, we have a validation channel, we pass the appropriate locations in S3, and we pass the data format, which is CSV, okay? And then we call fit on the estimator, and we get the training job going, okay? So you see, from a machine learning perspective, we didn't do anything here, right? We basically put some CSV files in S3. We selected XGBoost. We just told XGBoost, hey, this is what we'd like to do, linear regression. And here's where the data is, and it's CSV, go do your thing, right? So very, very simple. So when we call fit, we see what's happening from an infrastructure perspective. So we start the training job, we launch that instance that we selected, that M5 large instance. Data is copied to that instance from S3 to local storage. Of course, the XGBoost container is pooled, and then SageMaker gets everything going, right? And we see the training log, And of course, it's also available in Amazon CloudWatch, which is the monitoring service. So here, if I'm running a notebook, but if you were running this as a script, as a standalone script, or maybe in a Lambda function or in a container, anywhere, then you would still get your log in CloudWatch. So we see all those rounds taking place. We can go down. So that's the metric, the root mean square error. And yeah, it stops going down after a while. So yeah, we can see, that early stopping ID was a good ID because we only trained for 37. Well, we trained for 47 rounds, but the best one was actually 37, which is why we stopped 10 rounds later. Okay, so the model is saved in S3, the job is complete, the instance shuts down automatically, and we only pay for 59 seconds, right? So there's no chance we're going to leave this instance on because it's terminated automatically. So you will never overpay for training. By design, it's not possible. Okay. If I use spot instances, I would probably get a 70-75% discount on this. So I would just pay for, fractions of just maybe a couple of, not even a couple of cents, fractions of a penny, right? Okay, so now we have a model. We could go and grab that XGBoost model in S3. We could copy it to our local machine. We could do some local testing. We could do all kinds of things. Okay, but let's continue and let's go and deploy. Okay, so we're going to deploy, calling the deploy API, right? And again, we just say, hey, here's a simple a basic instance I want to deploy on. So it takes a few minutes, and I actually go to the console and see that, yes, I have my endpoint. Okay, so zoom in here. That's the one you see here. So it's an HTTPS URL that I could invoke using any language, any tool, right? Push data and get predictions, right? And this is running on a fully managed instance. So here I'm going to just call the predict API, which is in the SageMaker SDK, passing some test data, right? So I'm serializing and deserializing using a CSV. And I can see the predicted price for this house is $23.95 K, right? And of course, I can pass multiple samples and get more answers. Okay. And when I'm done, I just delete the endpoint, right? And that endpoint comes down, and I stop paying for that. Okay. So you have to be careful here. Training shuts down automatically, but endpoints are not shut down automatically, right? I don't think you'd like it if we shut down your endpoints. So of course you have to take care of that. Okay, so it's good practice to, once you're done working, just go to the console and look for endpoints and terminate anything that could be running there. Okay. All right. So really quickly, we could do the same with a scikit-learn script, right? So let me just show you the difference. So I'm using the exact same data set, but this time I'm training with a little bit of scikit-learn code that trains a linear regression model, exactly the same ID here. And you can see I'm using the sklearn estimator. So I don't have to say, hey, use the sklearn container. Obviously, yes, that's what we want to do, right? And I just pass my training code here, and I do the same, right? And I train, and I deploy, and I predict. And there's nothing weird in the in that scikit-learn code. Here it is. If you're used to scikit-learn, it's vanilla code all the way, right? I'm not even importing anything related to SageMaker here, right? The only thing is, so of course you need to receive hyperparameters on the command line. That's how SageMaker will pass them to the script. And you need to read the location of the data sets and the location of the output model using environment variables. That's it. Okay, so you can take your existing framework code, add those two lines here, basically, to know where to read the data from and where to save the model at, and you can use it on SageMaker, right? So accordingly, I read the data from that location, and I save the model in the right location, and that's it. So very, very minimal changes. Okay. All right. There's so much more I could say here, but this is good enough, I think, for a first intro. Maybe just a quick few words on the frameworks and infrastructure, and then we can move on to questions. So frameworks and infrastructure are at really the bottom layer, and so this is for customers who want to build and manage their own infrastructures. Some customers are more comfortable doing that, and that's fine. So like I said, you have plenty of different instance types: CPU, GPU, FPGA. We have a special custom chip called Inferentia that lets you accelerate machine learning predictions at very, very high throughput and very, very low cost. This is really a good choice if you have large-scale prediction workloads. And of course, you can use Amazon EC2, and you can use our container services, ECS, EKS, etc. To build your training and deployment clusters. Like I said, we have Amazon Machine Images for this to save you the trouble of installing and managing all those libraries. We have deep learning containers for your container services as well, and they basically include all those libraries that you see there, and those are in most cases optimized versions of those libraries. We have teams who actually work on making TensorFlow train as fast as possible on AWS and so on. So there's a lot of benefit also in using those. Okay. All right. So some resources that I think could be useful. So if you want to know about everything then that I discussed today and more, then you should go to ml.aws. This is really the high-level URL for everything. If you're specifically interested in SageMaker, then here's the SageMaker service page, the GitHub repo for the SDK that I used, the GitHub repo for hundreds of notebook examples showing you all the configurations that you can use SageMaker with, from the very simple ones to the crazy advanced ones. This is my YouTube channel and my blog, where you could find some interesting content if you want to dive deeper on SageMaker particularly. And last but not least, I wrote a book on SageMaker that was published a few weeks ago. And you can find discount links for the paper edition. Unfortunately, this is just good for Amazon.com, but it's a very deep discount, so it's possible that it would offset the shipping cost as well. Some depending on where you live, it might actually be cheaper than other options. And in any case, you can also buy the ebook on the publisher website on Packet using that 20 SageMaker code. Okay, and that gives you 20% of the price. So this is only valid for a few more days, so don't wait if you're interested. If you're not, that's totally okay, but don't ping me on November 12th saying, oh, I forgot, because I'm sorry, I don't think I will be able to help. All right, so we have a few more minutes for questions, so let me figure out how to do this. Okay. All right, just bear with me here. Just need to cut and paste this long URL. All right, here we are.
Hi, Julian. Thank you for waiting for a second. It's Ira, your moderator. If you have a few minutes for Q&A session, so you can follow to a Zoom room and meet your participants here and answer all the questions here. And now I'm ready to say that that's all with our first speaker for today. Great. And next one, we'll have a presentation from our platinum partner. It's EPAM. And Andrei Kucherenko is our senior software manager or chief software engineer. He'll make a short presentation about our company.
grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right. To be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Hello, and we are glad to welcome the representative from EPAM, Andrei Kucherenko, Chief Software Engineer. Good morning, Andrei.
Good morning. Yes, my name is Andrei Kucherenko. I've been working in IT for more than 18 years, and today I'm going to talk about advanced engineering. Let me start about small self-intro. My areas of interest are front-end development, back-end development, mobile development, clouds, IoT, and other. Also, I'm mentor, speaker, curator of new and mentoring programs, trainer, author of open source projects named GSCPD. It's a tool for copy-paste detection in programming source code. And yes, I work at EPAM and I'm advanced engineer. Today I will talk about advanced engineers. So let me describe the problem. What we know about programmers' career path. We know that programmer starts as junior, next step is middle, and next senior, lead, and that's it. Pension and well-deserved rest. That's probably what engineers had 50 years ago, but now you can become lead engineer in 25. What should we do next? There are several ways to grow. Switch to manager or architect, or leave IT at all. And many good engineers have faced the problem. Until recently, there are no development paths for real engineers. That is why we have the advanced engineering track now. Who are advanced engineers? Advanced engineers are really the best engineers who can solve business problems, who can write code, who can teach, lead, and mentor other engineers, who has influence to engineering communities. They are best experts in their areas and have wide vision of related areas. The best engineers who enjoy solving any problem in engineering way. We have different advanced engineers in EPAM. Some of us has a deep knowledge and contribute to extremely interesting and important open source projects. Some of us extremely wide skills in technologies and easily switch between different technologies for solving business tasks. Some of us are the best trainers and mentors. So I'm going to say, don't stop to grow as engineer. You have opportunity to grow engineers all your life, and for that I suggest you to join the EPAM team and grow with us as advanced engineer. If you have any questions related to advanced engineering, you can write to EPAM. Contacts you can get in the chat, or you can find me directly, and I will describe what I know about the track. And So my name is Andrei Kucherenko, and I'm from EPAM. I think that's it from my side. I'm ready uh, to to answer.
Thank you. Thank you, Andrei. Dear participants, if you have any questions to Andrei, you can type them in the chat, and Andrei you can answer these questions there, or you can connect with him directly via Facebook or any other channels. And of course, there is a link to the EPAM Master Program at the user page under the EPAM section. So please follow the link, and you can find more information about the growth possibilities and learning possibilities at EPAM. Thank you, Andrei. I hope you will
Thank you.
enjoy the rest of the conference together with us. So thank you for connecting.
Thank you. Have a good day.
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right. To be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Hi guys, so we are ready to invite our next speaker. It's Andreas Falk. Hi Andreas, how are
Hello.
you today?
I'm fine, thanks. How are you?
Not bad, thank you too. We are excited of the second day of Devoxx. What is the weather in Germany today?
Oh, it's sunny outside. It's cold, but it's sunny. So it's quite nice.
You are lucky. Okay, what topic have you prepared for us?
I will talk about containers and Kubernetes and about security, especially for
Sounds
developers. So not infrastructure part, but more the dev side.
sounds interesting. So okay, the mic is yours. I will come back in the end.
Okay, thank you. So welcome to my talk, in my deep dive talk, containers and Kubernetes security for developers. My name is Andreas Falk, as already mentioned. I'm located in Germany, Stuttgart, in the south of Germany, actually. Uh, so I'm joining from there, from my home office, as you might recognize in these times. So you can reach me via email if you have questions after the talk, after Zoom sessions for question and answer, or you can reach me via Twitter. I often tweet and also communicate over Twitter pretty much. So my day job is pretty much consulting, developing customer enterprise software in mainly in Java in enterprise world using Spring framework and stuff like that. But my second part is about application security. So dealing with the whole application security world, like securing application. Like authentication, authorization, defending against SQL injections, all that bad stuff that could happen. And as such, I'm also part of the Open Web Application Security Project as a member, and I'm also a member of the OpenID Foundation. Both communities are really keen on making the world a bit more secure. So the OWASP deals about web application security in general, and OpenID Foundation deals with a standard you might also know, like called the OpenID Connect standard, which builds upon OAuth. Today we will not have pretty much about OAuth and OpenID Connect, but more into container security. We also have some offerings. That would be the only advertisement slide for today. We also offer trainings and consultancy support in implementation and architecture, dealing with OR2 and OpenID Connect. So if you want to bring that into your project and need help, so just contact me. We also provide threat modeling trainings and workshops. So that's also the case. And we provide consultancy in general security questions, also concerning container security, Kubernetes, which is the topic of today. So the agenda for today, we have pretty much content for the 2 hours now. So I will start with typical use cases that we have nowadays when we use containers in our world. Then the second part would be a sneak preview. So what could possibly go wrong when you're dealing with containers? It could be quite dangerous if you're doing things pretty much wrong. And then the main part will be the third part, the path for secure development. So we'll have 4 stages that we'll look into. We will start at the application security. So it is not of further use if you push an insecure application into Kubernetes or into a container. So the container in Kubernetes does not make the application any more secure than before. So if you have a SQL injection in your application, then containers or Kubernetes will not defend against that. So because of that, we have the different stages to look for security. So we'll start with application security, and we'll be dealing with basics of container security. There we'll also have some basic Linux know-how that I will tell you, so how to understand containers, in fact. And then we're dealing with Kubernetes security, and the last part will be a bit of dealing with Kubernetes secrets. The slides and the code for that talk, that deep dive, is available on GitHub already. All the practical parts, the labs for that talk are also available already. So you can just download the slides already on that GitHub repository. As well as if you want to follow along the labs as I introduce them during that deep dive session, you just can follow along. So we have demos for all that iterations for application security with a simple application, with container security, and also for Kubernetes security. We won't have a demo, in fact, for the Kubernetes secrets part. I did not have time to prepare that, but we won't have time for all the demos. So in fact, for 2 hours are not that long. So we would need half a day if we also would require the secrets in practice. So what are typical container use cases? Why is Docker, Kubernetes, and all that stuff that prominent in our world nowadays? So it all started out by simplifying the development environments at first stage. So if you're a developer, you have to deal with lots of other components, like a database, like a messaging system, like an application container server, like Tomcat, for example, in that case. And it's often difficult to set up all these components by yourself on your local machine, like setting up a MySQL database or RabbitMQ is time consuming. So often you will use what is called Docker Compose, where you can just start up several Docker containers at once, one for RabbitMQ, one for MySQL, one for Tomcat, and then your development environment is ready, set up. You use your Eclipse IntelliJ IDEA with your Studio Code and stuff like that. Just develop your application, and you don't have to deal pretty much with that infrastructure part. So that's one use case that is very familiar, a very famous use case, a very well-known use case for the containers. So the second one builds upon the development environment, which is also used pretty much in our world. So like support for integration testing. So as well, if you want to do automated testing, lots of developers, for example, use H2 in-memory database instead of the production database to do database testing in that case. But that's doesn't simulate the real production environment. So I myself in projects had several problems with that approach because we tested against H2, but in fact, we have another SQL statements running on the production database, which then cause different problems that are not tested using the automated testing suite. And for that, we use testing containers that will be started behind the scenes when you run an integration test. So for example, if you want to run a MySQL or Oracle database, then this starts up in the back. You run your automated tests against that database, and after that it will be shut down again, and your automated test is finished. You can do that with several stuff. So we have lots of support for products like the typical databases all offer support for test containers. Also messaging systems. Pretty much I also test against identity providers like Keycloak that also provides a test container. So you can also test against a real identity management system. And you don't have to simulate your JSON web tokens and stuff like that. A well-known use case for sure is using Docker containers or containers in general in CI/CD pipelines. As you can see, lots of products that are available on the market build upon that container technology as as integral part of their products, like Jenkins X or Concourse or CodeFresh. These are well-known products nowadays that have containers as integral part of their mechanisms. So for every build step, they just use Docker containers for isolated builds. So that makes it also very easy to build CI/CD pipelines nowadays. So these are all development and testing stages where containers originally have been used. Nowadays, with the rise of the Kubernetes product, we see more and more containers being pushed into production. And that's where security gets really serious nowadays. So if you just use it in development and testing, you might argue, we don't have to deal pretty much about security. That in that case, because nobody from the outside world should access our CI/CD system or should access our local development environment. But things are changing pretty much if you going into production with your containers, pushing them into Kubernetes or other environments you could also use HashiCorp Nomad as an alternative or AWS Fargate, for example. So you push your things into production using container technology. And this is the main use case where most of the magic of hackers attacking your applications happen. Sometimes they also try to attack the CI/CD pipelines, because the CI/CD pipelines often have a direct connection into your production system. Otherwise, it won't be possible to deploy automatically containers into your production if you won't have any connection between your CI/CD pipeline and your production system. But here also you have to make sure that you pretty shut off, you protect your CI/CD pipeline system against attacking. So especially the connection between production and the CI/CD system should be taken care of pretty much. So that should be as secure as possible. So now we have seen what use cases we have for using containers in Kubernetes. So what actually could go wrong if you're doing things wrong or if you're being attacked from the outside world. We had already several vulnerabilities inside Kubernetes or container technology in general. There are a lot of CVEs. This is a quite old one from 2 years ago, CVE 2018. But that also was a quite serious CVE vulnerability. And as you might notice already, so if there is any vulnerability detected for Kubernetes or containers, I think in 95% of the cases, it is a really serious problem that could lead to privilege escalation, gaining full admin privileges, host takeovers, and stuff like that. So most vulnerabilities that are detected are really dangerous for your production system. So always patch to the latest versions, especially for Kubernetes cluster and also all the container technology products. So as you can see here, for that CVE, for example, was 9.8 out of 10 as a severity score. But we already also have seen CVEs that had, in fact, 10 as a score. So the highest score that is possible, at least. Then, apart from vulnerabilities in general of Kubernetes, you could also do things pretty much wrong. Even big companies like Tesla did make things pretty much wrong. So they offered a Kubernetes dashboard that was pretty much open to everybody, exposed to the general internet with no authentication and elevated privileges. So everybody could just access the Kubernetes dashboard of Tesla. And also the hackers detected that. They pushed Bitcoin mining software to that Kubernetes cluster, which is the use case number one by attackers nowadays. They just wanted to push Bitcoin software to earn money, which is a good case for Kubernetes clusters. You can imagine that Tesla has a really big Kubernetes cluster that has lots of computing power, and that is a really good target for Bitcoin mining. And even worse, also AWS API keys and secrets are visible, so they can just jump over to other infrastructure using that public API keys. So always, if you're using dashboards that are pretty much used for Kubernetes, always check if the Kubernetes dashboard is secured by authentication and authorization. It should never be available without any authentication restriction to the public. So if someone can manage to access your Kubernetes dashboard and there's no authorization in place, the attacker could possibly manage your whole Kubernetes cluster and take it over completely and also lock you out in a special case. Also, as always for other software, look for open ports on the internet for your Kubernetes cluster. One very prominent port is the so-called etcd port. I will tell you a bit later more details on etcd, but for now, etcd is the central database for Kubernetes clusters that stores all the important configuration for Kubernetes clusters. So if the etcd database does not work anymore, your complete Kubernetes cluster does not work anymore. The complete configuration is inside there, and without configuration, your Kubernetes cluster would stop working. Also, all the secrets, all the credentials are stored in etcd as well. So that's why attackers also use that as a prominent target to attack Kubernetes. Because if you have the configuration part and all the secrets, then you don't have to deal with the normal use of Kubernetes, like using the Kubernetes API with authentication authorization. You don't need to go over that API anymore. You can just access directly Kubernetes by stealing the secrets and directly using the configuration. One prominent page for hackers is showdown.io. You might know that already. And if you search for etcd ports, you will find lots of open ports inside Showdown that you can possibly attack and just grab the whole configuration, the whole credentials of that Kubernetes cluster. Luckily, there's also a tool available called etcd control, like kubectl. There's also etcd CTL tool available. And if you have detected an open etcd database, you could just check for cluster health, for example. And if you got healthy result, then you possibly can just access that cluster. I myself stopped at that point by checking, because if you now would go further in getting stuff from that etcd database, that would be illegal. So I stopped at that point, but you could easily just continue here and check out all the contents of that etcd database. So always put firewall rules, even for managed clusters in your cloud provider. Always shut down all the ports that are not required for the outside world. But the only port that is required to open actually to the outside world is typically the port for accessing the Kubernetes API. And also, of course, the ports of your application to access your application then that is deployed. So if we now have seen all that risks that can be provided by such containers and Kubernetes, so what can we as developers do in that case? So we will not talk about all that infrastructure basic stuff. So we won't talk about firewalls, about VLANs and networks in general today. We will concentrate on the developing part. What can we do as developers to make this a bit more secure. So this is the path for secure development for today's deep dive session. We will now start with the application security and then go further to container security, Kubernetes security, and Kubernetes secrets. So when we talk about application security, then we have to talk about the typical web application security problems that are listed on what is called the OWASP top 10 list. So you might know already the OWASP top 10 list with the 10 most critical web application security problems. There are different ones, like we could have problems with authentication. Here, it is usually not the authentication protocol itself that is broken, but users using weak passwords, for example. Also, the other flows around the real authentication, like the security questions, are easily to guess. All that stuff is like resetting password flow is not implemented in a secure way, so everybody could just reset passwords from other users possibly. So these are the attack points, typically not the authentication protocol itself. So the OpenID Connect OAuth protocol is really hard to attack. So this is not the main target of the hackers nowadays. Then about authorization, we have to deal with all that access control stuff. So if one is authenticated in the application, can that person access, for example, the admin web page that is not intended for standard users? So is it checked, for example, that one user could access the shopping cart of another user, for example? So these are typical authorization failures. Then still the number one of the OWASP top 10 list is still the injection part, like the SQL injection. It is still number one, not because it's the most spread problem, but it is still the most critical problem. By just having one SQL injection in your web application, an attacker could possibly take over your whole database cluster, can then jump from the database cluster to the next server. And if you have a really insecure network backend system, then the attacker could possibly jump just through your whole servers and take over your whole network by just one SQL injection. That's why it is still the number one, just for criticality. Next thing would be rather client-side problem, the cross-site scripting attacks. If you use JavaScript pretty much, then you possibly have attack surface for cross-site scripting. Also for cross-site request forgery, these are typically problems when you provide a REST API that is secured by using session cookies. Then in that combination, somebody could just put a pre-built request in some famous forum, like if you're searching for cat photos, for example, also some other hobby stuff, you go to a forum and the attacker does some social engineering before to get to know what are your hobbies and stuff like that. And it puts some prominent web link in that forum that you don't recognize at once because it's behind a photography of a cat, for example. Then you click on that cat and behind the scenes, it just executes a use case on your web application by that URL. And if you are logged in via session cookie, then probably that request just goes through because of that session cookie automatically be sent with that request. Then also data protection, crypto stuff is really important to do things correct here as well. Especially in Europe, we have that pretty hard data regulation protection in place. And there you have to protect your application data by using cryptography. So these are all pretty much problems of your web application. You might also know what is called the testing pyramid that was originally shown first time by Mike Cohen. where he showed quasi that on the bottom you should have a safety net for all your testing, for all your unit tests, to make it possible to even do refactoring in your application. If you don't have a safety net of lots of unit tests with fast feedback, if something is broken in your application, then it is really difficult to really refactor your application or adding different things, updating functionality, if you're not sure that this breaks some other part of the application. In the middle, you have the API service tests that are require a bit more effort to implement and also have a slower feedback. These are operating typically on the API service, like for example on REST API level. And on the top, you have the dynamic stuff. You have UI testing, for example. And on the very top, you have the manual stuff, so that not automated stuff, usually like explorative testing. And on each level, you can also easily test security, which is not done pretty much as I see in projects, but it is possible. You can just test how good is your input validation, for example, working on the unit test level already. So if you're using bean validation standard in Java, for example, you can also instantiate the bean validation factory in a unit test already and just check for correct input validation. Also for authentication, output escaping, also bypassing business logic in a unit test, you can easily test that on unit test level. Also checking for error handling and logging if that happens in a correct fashion. So especially you could check if the logging output does not log sensitive data like user passwords. You can also check for that on unit tests already. Then especially for security testing, you can also do static analysis on that level, like using spot bugs, for example, or also later container image scanning would also be on that level, or checking your dependencies, like the Hibernate framework library for security problems using the OWASP dependency checker, for example, or the Node.js, the npm audit command could be part of that unit tests level. On the API service level, you could just easily test for the whole real authentication part, like also doing validation of your authorization permission model, by also using positive and negative tests on that level. So always do a positive test if a user with the admin role, for example, has access to a special endpoint, but also do the negative test if the user does not have the role admin, that you get an access denied exception, in fact, proving that nobody else could just access that. You can also easily, for example, test SQL injections in integration tests. Just try to put a typical SQL injection pattern like the famous and 1 equals 1 snippet, for example. Just try to put that in your tests inside a request to your database, and then check if your database behaves like expected, ignoring just that input change for the SQL statement, or if it really takes it into the SQL statement. Also, you could check if typical response headers are set like the strict transport security header, or you enable the XSS protection of the web browsers by the specific XSS header set in the response. You can also check for that. On the top level, you can run dynamic application security testing, like using the OWASP SEP tool, which is an open source penetration testing tool that also provides Docker containers. Here we also use Docker containers. With the Docker containers provided here, you could easily do some baseline scanning, which is quite fast. That typically only does some passive scanning on that level to have a fast feedback if there are low-hanging fruits to be detected regarding security. Then you have a special API check command available, and you also have a full scan command available. So for the baseline and the API checks, that could be easily integrated in your normal CI/CD pipeline. With every commit, you could possibly run behind the scenes that dynamic scanning. The full scan should only be done in nightly builds, because the full scan might run for 30 minutes or even hours, depending on how big your application is. And on the top level, you could just also use it in explorative testing. So by adding special security charters in the explorative testing part. So it would be an idea, for example, to have a session with your developers, also with your customers, your stakeholders maybe, and just do a 2 hours testing, for example, and everybody just tries to put as much rubbish chunk into all input fields that he or she could possibly find in your web application, and then check how the web application behaves. If you just put some emojis inside, put some SQL injection payload, some cross-site scripting, some strange characters, just check out how it behaves. That could also do a normal stakeholder could also test things like that. So these are all ideas how to test your application already for security. And then also automate all the things. So you can easily automate all the things. So static analysis can be automated in your CI/CD. Then dependency check can be automated. Also dynamic scanning, like doing that stuff with the OWASP ZEP Docker containers. All the stuff could be easily automated. Now we'll just dive into some practical part. As you can see here, this is the GitHub repository I have mentioned. So if you look into github.com, Andy Falk, which is my user there, then secure development on Kubernetes, you will find the repository here. If you want to do all that labs inside that repository, there's also a special section on the requirements. You find the presentation slides here. Also helpful tools for Kubernetes security. I will tell a bit more about that later. So if you want to run that sessions later, especially when it comes to the part of Kubernetes, you should have a Kubernetes cluster at hand. Now for that labs, you won't need a full-blown Kubernetes cluster like a Google cluster or Azure cluster. You can easily just try it on your local machine by using Minikube, for example, or also by using a tool called K3S. These are free Kubernetes clusters that can be spinning up on your local machine very easily. Just download it. Here you can also consult the docs of Minikube. If you have downloaded Minikube, just start it. Then you can also use the Docker registry inside Minikube if you don't want to use remote images. If you just want to use local build images, then you can also use that. As well, K3S is easy to use, or just use a managed Kubernetes cluster for that labs. This is also what I will do for now. So I will already prepare some cluster for the later labs already, because creating a cluster takes some time. Now before that, I should probably log into my environment before. So it takes some time today. That's strange. So now I should be logged in. So now I can just create my cluster. So I will start it now and leave it running. because it takes some time. I also can, in the meantime, show how this command looks like for creating such a cluster. So in fact, I will just create a Kubernetes cluster on the Google Cloud environment. In that case, you have to give a zone where that cluster runs. So I'm in Europe, so I take a zone nearby me, so West 3, I suppose it's in Frankfurt, Germany. Then you have to give a cluster version, what Kubernetes cluster you want to use, a machine type. Then you probably also need to specify how many nodes you want to use. I have now spinning up 4 nodes. And one interesting thing that also is for later for using Kubernetes secrets is that part here. I also switched on the application level encryption for Google Cloud Kubernetes cluster. That pretty much encrypts all the secrets on their way from the etcd database or back to from the etcd database. So in transit, it's also encrypted and decrypted on the way. So it's more difficult to grab a clear text secret anymore. So that was that case. So the other part would be some helpful tools that you could use. I will just go into details for that later stage. What I now want to show is our sample application. For the whole deep dive session, I have built a really simple sample application. You will recognize it is a typical Spring Boot application with some configuration properties. So the greetings, so it's a greeting application, so you can just configure the greeting and the default greeting message, for example, or there's also some for a secret that should not be shown on the screen. And you have a typical greeting REST controller here running that just points out a greeting in that case. As you can see here, I also use output escaping here, output encoding by using the OWASP Java encoder in that case, that encodes for HTML and for JavaScript. So with that results returned by my REST API, it should not be possible to do cross-site scripting attacks anymore, because I encode all the things, so it's not dangerous JavaScript or HTML code anymore. And there's a second type to access it, so you can also give a request parameter, so you can also give a user-defined message to that application, and that's all the use cases of that application. So it's pretty simple because we don't want to deal with complex use cases today. We just want to use a simple application for our cases. So if we just look into the application, so I can easily just put some message here. As you can see, also these things here are already encoded, so it's not possible to use that directly. So hello Devoxx could be a possible message. But you could also, for example, try to put some script inside here. So the typical cross-site scripting attack that is used in input fields or in URL parts. So as you can see, it is encoded, so there is no pop-up coming up in my browser, so no cross-site scripting is possible at that stage. So that would be one example how to secure your application against one of the OWASP top 10 attacks. For easiness, I have not put authentication inside that application because it takes some time to always put in username, password, and we don't have that much time today. So that was the first part already. Not completely here. That was the first part of the application, just doing the first iteration about application security. We have seen that Hello Spring Boot application. These are the endpoints. What I have not shown is the actuator endpoints. This is also security-wise could be a dangerous thing. So if you enable all the actuator endpoints in your Spring Boot application, it could also be a prominent attack surface for attackers. Like for example, especially the environment is really interesting for attackers. So if you don't protect that endpoint with the environment variables, then this could lead to just publicly available sensitive data. So you can also look for some secure. I don't have. Yeah, as you can see, you have all the values put out here. So you could imagine that if you have some passwords, some sensitive data configured as environment variable in your application, then this would also be put out on that part here. I'm just searching for my own. So this is, for example, what I'm talking about. So if I have my secret sensitive data, which should not be shown in clear text here, but it is shown on clear text here, you should be aware of the actuator part, that it also can show sensitive data if you're not protecting this endpoint with authentication. So you can also use that on command line for sure. I've shown also that the script alert part. You could also try to redirect using such things. That should also not be possible. Yes, we have also spot bugs inside. We have dependency check built inside, so I can just show how that looks like. So putting a dependency check is quite easy. Just put a Gradle plugin that's also available as a Maven plugin. Put some configuration. So here I tell it should fail if a CVE score is above 8, which is high critical, then it should fail the whole build in that case. You can also add suppressions for false positives as well. And here's also configuration part on the spot bugs part that puts out also reports if there are some problems detected in the static code analysis. So these things are really easy to configure, and I would recommend to use them in all your Java projects as well. So this was the application level part. So as a summary for application security level, always use do input validation for all types of input. Also use output encoding, as we have seen, for prevent XSS attacks. Always use parameterized queries, prepared statements for accessing data. With databases, enforce authentication and authorization for all parts. Also, never implement your own cryptography or session management. Use frameworks for that. Use well-known cryptography algorithms and implementations. So also a bad source of doing cryptography wrong is like Stack Overflow, just copying over some prominent cryptographic algorithm of Stack Overflow. Especially there are still lots of misguiding entries in Stack Overflow telling, for example, that base64 encoding would be a encryption algorithm, which is not the case, or just offering cryptographic algorithms like a Caesar algorithm, just shifting some characters. That is also not a secure cryptographic algorithm. And also check third-party dependencies for vulnerabilities, and always also use static and dynamic application security testing. That was the absolute basis. If you have now a secure application that you can put inside a container, then you can go ahead. We will now talk about container security. The good point here is when we talk about container security, you find plenty of good sources on the internet already dealing with that, giving advice how to secure your containers. For example, there's a NIST special publication by the National Institute of Standards in the US talking about application container security as a guidance. Then also the OWASP, in fact, offers two types of documents. One is the OWASP Docker Top 10, a special crafted Top 10 by the OWASP for Docker. And they also provide a security verification standard document for containers. And they have the standard security verification standard for web application part. They have one for mobile applications, and they also now have one for container security. Here you can find typical requirements regarding container security and also how to test it. In Germany, we have the so-called Bundesamt for Security in the IT. They also provide some document for our German people, for example. So I would suppose that in your country, you would also have a corresponding regulation stuff or corresponding part of your government that deals with information security that maybe has also a similar document talking about how to secure in containers. Especially the OWASP Docker Top 10 also has 10 prominent parts, which we also strive today, like secure user mapping or patch management strategy, secure defaults and hardening, for example, maintaining security context, also protects your secrets. Also dealing about container image integrity and origin, following the immutable paradigm. So containers should also be immutable, so it should not be changed and patched. The containers should always create new containers, for example, and also dealing with logging stuff. Now I will have a short introduction into how containers work and how they differ from what is called a virtual machine, because lots of time I still see a lot of misunderstanding, and so a lot of people cannot distinguish between a virtual machine and a Linux container, and these two things are pretty much different. For example, especially when it comes to security and to isolation part, these things are completely different stuff. So I often read containers are lightweight virtual machines, which is also not true. So virtual machines are one part and containers are another part, and these are completely different approaches. So if you look for virtual machines offer a much harder isolation than container ever could possibly offer. So you have, in fact, two types of virtual machines. You have what is called a virtual machine with a hypervisor. And you have just a virtual machine that has no hypervisor, but has some virtual machine monitor sitting above a host operating system. So if you look at VMware ESXi, for example, Xen or Firecracker, Hyper-V, these are built upon a hypervisor that sits directly on physical hardware, and that hypervisor deals with the whole isolation of virtual machines. So you see, there's no unique kernel and stuff running on operating system level, you have the hypervisor, and above that you have the different guest operating systems that then run some guest applications. In the second alternative, you have the physical hardware, then you have a host operating system running, you have then the virtual machine monitor running above that. So that's a bit more into the direction of containers, but still has much more isolation than containers, because you are not running on the same Linux kernel in that case, as it is the case for containers. We will see now in the next slide. And above that virtual machine monitor, you have running your different guest operating systems and your guest applications. So a prominent thing here is VMware Workstation, for example, or VirtualBox by Oracle are typically such products that run in that type 2 fashion. But alternative 1 and alternative 2 offer strict isolation between your guest operating systems. So it's not possible to see a process running on one guest operating system on the other guest operating system. We will now see how this looks like when you're using Linux containers. So for Linux containers, they don't have a virtual machine orchestrator or something like that between. They just run on the same Linux host, the same Linux kernel. So they run on one physical machine that runs one operating system, just one Linux kernel is running there. So we have only one physical machine running all the processes on that machine, on that Linux kernel. So the container share all the processes running on that Linux kernel. So you can also easily see a process that is running in container A. You can also see that process on a Linux host, and possibly can also access that process. So that's why the isolation is very weak compared to virtual machines. And what the attacker wants to achieve here is breaking out of the container and accessing the Linux host. So that's the main target for hackers when it comes to security of containers. So containers, in fact, are isolated using what is called Linux namespaces. You can control resources on containers using control groups. We will have a bit deeper dive in the next slides about that. Then what is called Linux capabilities is also a mechanism to isolate and to restrict access to containers. And then you have the higher level possibilities to further restrict access, like using mandatory access control, secure computing mode. And you also can use container secrets management inside Docker, for example. Important to mention here is also that Docker is not the only container product available on the market. We have a standard built by the Open Container Initiative, and we have different products like LKT or LXD that can also be used as an alternative to Docker. Nowadays, Docker is still the most prominent one, but there are also alternatives building on the same mechanism than Docker does. So when it comes to Linux kernel namespaces, so this is the number one isolation mechanism that isolates the different containers on the same Linux kernel. So every container can have its own process IDs. Every container could span its own network stuff, can mount its own file systems, have its internal inter-process communication. Every container can have its own user and group IDs, set its own host and domain names. So you typically see some ID as host name set in a Docker container. So every Docker container has its unique host name set. And also a control group, which controls what resources a container can consume, is also a namespace. You can easily just query for namespaces. In that case, we will just jump over to the next part. to Linux container basics, I have prepared some short parts here. I have also prepared a part describing setuid and setgid part, which is also a security problem, which can be a problem in containers. You might already know about that setuid flag that you can set as a permission to your files. And if you set that setuid bad set, then that means that that independent of who actually executes that file, it will also always be executed in that user context that has set that setuid flag. So, for example, if I do sudo my sleep in that case, and I have changed mod with the setuid bit set, even if I start that with sudo, that my sleep will run under my user context. And so that's typically a thing that also is used by attackers in containers. Just looking for binaries that have that setuid flag set, which could be run as root user, and they then try to misuse that binary to gain access as a root user, especially gain access to the host as a root user, then to break out the container. And by using that binary with the setuid flag set, then using that one to jump to the host and have root access to the host as well. That's why also some container image security scanners also report on presence of files with that setuid bit set, for example. What I now want to tell you is that part on Linux namespaces. You can, for example, simulate somehow that isolation regarding host names on your Linux host. So I just try to use that one. That's finished here. So if I just use that unshare command, so with unshare, you can pretty much do some isolation and use and unshare quasi with that namespace. In that case, that UTS namespace to set your own host name from the parent operating system. So I now will open a shell. And in that shell, I have my own host name environment. So as you can see now, it still has the host name of the parent, but I can easily just set my own host name here. Now, so I should now have host name isolated. And if I go there and my parent and just type in host name, it still has the original host name. So I have isolation via host name namespace in that case. So that's a poor container simulation now for host name. But you can imagine you can do that for all the other namespaces as well. And that in fact is done by your container technology. So the containers are just isolated using such namespace as I've used here. You can exit that again, and if I give host name again here, so it still has the old host name. So it was not influenced by that other namespace that I have started here. And you have different namespaces as I've shown here that you can easily use here. I've also mentioned already the next mechanism called Linux control groups, which is also a namespace. With Linux control groups, you can restrict the resource limits of your container, which is also very important. So you don't want your container to consume all the resources that are available on your host. Then it would not be possible to start another container on your same host. And usual use case is that you have running several containers on the same host. So you can restrict using the CPUs, using memory, devices, processors, and network. If you are a Java developer, the important stuff here is if you want to use resource limits and using Java, then at least you have to use OpenJDK 8 update 192 or above. So recommendation would be to use Java 11 at least. So Java 8 is really old, really legacy. We have Java 11 now for a long time already in place as new long-term Java, and I would recommend use Java 11 because Java 11 is the first Java version that is really container aware from scratch. So OpenJDK just got backported some stuff from the Java 11 part in that case. So if you use an older OpenJDK like 8 update 140, for example, or even OpenJDK 7, then you would end up that the Java would just ignore the resource limit set and would just grab the whole resources of the host. So if you look into that Java application, then it would probably consume 2 gigabytes of all the host memories, for example, or the whole CPU. So recommendation is to use a recent OpenJDK version like Java 11 and just go forward. So Linux capabilities is also a very important concept used by containers for security. In previous times, in previous older Linux versions, older Linux kernels, you only had 2 choices. Either you are a supervisor, a complete root user with all administrative privilege access available, so you could possibly do all the things on your machine as root user, or you are a standard user that has pretty much no privileges, just running some standard applications, but not going further into some privileged access. So you had these 2 choices. Now with Linux capabilities, you can tune that and fine-grain your privileges that you have. So even for a normal user, you could just set some capabilities to a file or to a thread, and then give some other privileges in addition to the standard one. So in standard, the files or threads that do not have any capabilities if they're run by a standard user, but you could easily just add, for example, the capability called netbind service, for example, to a process, or by running Docker, you can also, as you can see here, do a cat drop all to not give any capabilities and then just add a specific capability for the netbind service. So in that case, netbind service is a very important capability because netbind service makes it possible to bind to a port beneath the port 1024. As you might know, all ports up to 1024 are privileged ports that a standard user is not allowed to bind to. And as you can imagine, you have, for example, an HTTP service that is run in Docker like Nginx or Apache that typically uses port 80 to bind to. For these applications to run inside Docker, you would need that netbind service capability at least. So it is possible to bind to port 80. I've also prepared some practical stuff on that. As you can see here, there are lots of capabilities available, like a capability also to be get owner of some files. There's also a capnet admin, so to have like admin rights on all network operations. So you can also modify routing tables. That is, for example, a typical capability that is used by service mesh frameworks like Istio, because they want to modify routing tables, so they need capnet admin as capability. Then you have CapNet Band Service, as I've shown already. Also, CapNet Raw is a really important one. For example, if you want to use the ping command, that typically has the capability CapNet Raw to open a raw socket, which is required to do the ping command. CapSysAdmin is a capability having lots of other capabilities. So if you are root, then you typically have that CapSysAdmin capability. So that is the capability that gives you all the privileged access you need as a root user. Then you have capability to reboot your system, for example, which could be dangerous to some part. You can change root, for example, to give another root file system. You can change the system time, or also access privileged syslog operations. So the system log is also a privileged part. Not everybody could just access the system log. So for example, you could just try, for example, to use get cap on the ping command. No, that's strange. That's strange. That works yesterday, so I don't know why this works. It does not work now. But I have ping available. Oh, that's strange. Yeah. But that's the demo part. But you can also set the capability for my ping, for example. You can also use that for running processes, for example. If you have a process ID, you can just also call that. What is more interesting for our parts to use it in Docker world, you can also print out capabilities of Docker. Then you might notice that Docker by default adds default capabilities as a standard to your Docker containers. So if you just run a Docker container with nothing else changed, no special configuration, it gives the Docker container already a predefined default set of capabilities. And by just running that command, we could easily see what are the capabilities. So I hope this runs now. I have to pull the. So as you now see, these are the capabilities that are set by standard of Docker if you don't configure any other thing for Docker run. So as you can see, you also have the cap netbind service by default. So that's why by default it is possible to use Nginx or HTTP server as a Docker container, because it can bind to port 80 by default. It also has CapNet Raw to do some routing stuff, for example, also change root. So typically pretty much balanced default sets between usability for Docker and between security for Docker. So that's really a balance set between these two topics. So with less capabilities, the standard user might not be aware of that capabilities and cannot do things he was expecting to do. So if you now try to do the same in a privileged mode, like running with root access capabilities, then things change pretty much. So if you now try to operate it that way, now you can see if you just add the privileged flag to your Docker container, then Docker gives you pretty much all the capabilities. So you are full-blown privileged user now on Docker containers. And this is a anti-pattern you should not use for your Docker containers. So there is almost no case that you should use privileged as a flag here. So that is really dangerous. It opens up the security surface pretty much for hackers. If a hacker gets grab on your Docker container with a privileged flag, then it's much more easy to break out that container and be also privileged and root on your host system. For example, when you use privileged mode, you could just easily use a command like fdisk. You can pretty much change the partitioning of your container. So as you can see here, it just prints out some fdisk commands. So that would not be the case if you would run it without a privileged flag. Then you could see you just basically see nothing. The fdisk command just won't work in that case. So as you can see, it could be pretty much dangerous to then execute reboot commands, fdisk commands, or just mounting different file systems. So also be possible to mount host file systems and then access these host file systems. Playing around with socket stuff, with Docker socket stuff, and really dangerous things could happen. So this would be another command which you should take notice of. I mentioned that you could just drop all the capabilities and then specifically add that capabilities that you need for your container. Like for example, the netbind capability. So if you just use that one, you just drop all the capabilities and just use that capability, then you see here that the current capabilities now is only the cap netbind service. Just one capability, and that's much more secure than just using the default or even using the privileged ones. Because what attackers want to achieve are privilege escalations. So to be root and just break out of the container. You can even make it more secure by adding another option like no new privileges set to true. Then it would also not be possible to misuse setuid binaries, for example, to gaining new privileges. So that would also be prohibited. So we have also the Linux mandatory access control system calls. I would skip that part for now. I just would mention that with gvisor, for example, you could have sandboxing functionality where you can sandbox your container in other sandbox. So the breakout is even more difficult. But we will now deal with Docker images. So this is how containers and images are working. So usually you build your own container images, which are usually built by using a Docker file. In a Docker file, you have to specify some base image, like using Alpine, for example. You could also use Ubuntu, distroless images from Google, for example. Then use a Docker file to describe what packages you need in addition to your base image. And then also your application will be packaged into that container image. Then you will build that container image, put that image into what is called a container registry. And then if you use a Docker run command, this just grabs it from the container registry, that container image, and then runs that container image in your Docker environment. Just using the concepts like namespaces, C groups, and stuff like that behind the scenes on your Linux host. So that container image uses the isolation by provided namespaces in that case. So you could break a container isolation by different things, like containers run as root by default, so you have to be aware of that fact. So if you just run containers, these are always run as root with that standard capabilities set by default, which that we have shown. If you use the privileged flag, then you would have the full capability set to the Docker container. You should also be aware of that mounting sensitive directories could be a dangerous thing, like mounting sensitive directories to for example, the etcd password data store and stuff like that. Also, mounting the Docker socket could open up an attack surface, because a very prominent use case is using that approach into CI/CD system to connect to your Jenkins slaves, for example, using Docker socket, which is a very easy approach, but it's also the most dangerous approach, because basically everybody who has access to the Jenkins file could then just also play root via Jenkins file commands, going over the Docker socket to the Jenkins node, and then has root access to the Jenkins node and can pretty much also execute commands in root privileged mode. So there are also other possibilities provided by some Jenkins plugins not using the Docker socket. Also, shared namespaces would also be a attack surface. Like here, for example, so you can just mount some host root file system, and then you can just also access all the host file systems. Then all is root is also anti-pattern you should not use. I will show how to make it better. In that case, how to be not root on your Docker file, it's quite easy. Just add additional user in your Docker file, like it's shown here, like run add group and add user with a user ID of 1002. So a good advice is also always use user IDs above 1000, because beneath 1000 user IDs could be system users, and you don't want to have a conflict with some predefined users. So just use a higher user ID in that case. So we have added an app user, a special one, and then we, by the user directive with user 1002, we just advise Docker, please use that user for running our Java application and not the root user anymore. Now this is a typical Docker file using OpenJDK and just using our Hello Spring application as a sample. It gets also more easily if you use what is called chip plugin, which is provided by Google, and distroless images by Google. Here you have two advantages, not only security-wise. One advantage is that you get much smaller container images when you use that approach with distroless images, because distroless images just put inside a container what is really needed to just execute your application. So imagine you're not building a Java application, you're building a Golang application. It just puts in the statically linked Golang application and pretty much nothing more. So there is no shell available, there is no full-blown operating system binaries and stuff like that available, so you can not perform a ping command, not perform any other stuff, open a shell and stuff like that. So just the required components that really required for just executing your application, nothing more. So this reduces the attack surface pretty much, but it makes also things a bit more difficult. If you want to debug your container image, then you cannot access that very easily. One other advantage is that it can increase your development turnaround pretty much time-wise, because one point is that you don't need to have Docker installed at all on your machine, so it does not need a Docker daemon anymore to build Docker images. It just uses that plugin and that builds the images, and it also builds the images in an optimized fashion, so it recognizes that you didn't have changed your used third-party dependencies, for example. You only changed application code, so the layering in Docker containers are optimized by the tool. So they just builds the top level layer again and recognize that. So it's much faster in building container images and getting smaller images. So you get distress based images for all the programming languages like Node.js, Golang, Java, stuff like that. My recommendation would also be to use distress images as base images, so it's a bit more secure as well. And here you can also specify user 1002, for example. You have also the advantage here that you don't have to add that user beforehand. Just specify a user ID here, and it won't take the root user anymore to execute all this stuff. So this is a recipe for secure Docker run. Basically, don't use the privileged one. So that would the worst case that you can use Docker run with the privileged flag. So the default one, Docker run, is also not very secure. A bit more secure is the Docker run with the security options, no new privileges. Even more secure is by just dropping all the capabilities and just adding a specific capability. And even more useful and more secure, also resource-wise, is that you also restrict using your resources by using only half of the CPU, for example, and only using 200 megabytes of memory for your Docker. So that would be the best thing. So Docker would love that command pretty much. So that's a small recipe to make it step by step more secure to run your Docker containers. If it comes to Docker images, to especially Docker base images, you also have to be aware that there can be base images on Docker Hub, very prominent ones that have lots of vulnerabilities inside already. So the top one with the most vulnerabilities from the last report done by SNCC is the Node.js base image. So that had originally over 580 vulnerabilities inside. You can reduce that vulnerabilities by using different variants of Node.js base images, like using the Slim variant drastically reduces the vulnerabilities number, and even using the Alpine one reduces that in that case to 0, so much more secure than just using the standard Node image. So always also check if there are better alternatives for using different Node.js images. And also MySQL, you see all the prominent base images like MongoDB, HTTP, Nginx, stuff like that, Redis. All these have vulnerabilities inside. Luckily, there are also open source image security scanner available, open source ones, commercial ones, like Trivi, for example, or Claire or Anchor. They all provide open source scanner that can be just used for free, for example, in your open source projects. And these scan your container image for 3 different parts. It's on 3 different layers, as I might say. It checks for operating system vulnerabilities and also for vulnerabilities in your third-party dependencies that you use in your application. And it checks that on different levels, like, for example, use base image on the parts that you add in your Docker file and also for your application. What is also a good choice is to use, for example, your own container registry. So especially in my projects where I use big customers, they always use their own registry, their private registries. Here it is absolutely prohibited to load any base image from the Docker Hub. So all images, all base images are inside that private registry. They are pre-checked. Some base images are specially crafted by that company, for example, like base image for Java, for example, should only be taken from that private registry. And if you want to use your own on-premise registry, for example, or push that easy way to your cloud environment, then you could use Harbor, which is an open source registry that offers all the recommended patterns already. So it secures artifacts with policies and role-based access control, so not everybody could access them. It has image scanning on board. You have the choice between Claire or Trivi nowadays to configure. It also includes signing images with Docker Notary Trust standard. So you can also sign your image as trusted. So you can check if the image was not changed after the creation of that image. So no third party could just put malicious code inside a pre-existing container image. So also use that one, for example. Also, Docker and Snyk announced a partnership to put the Docker image scanning command directly inside Docker, which is already available as a beta version for Mac OS and Windows. For the standard installation on Linux, it is not yet available. So if you're using a beta version of Windows and Mac, you can just easily use the command docker scan now and just directly scan images with the Docker command. You don't need any third-party scanner anymore. So let's jump into that part. That would be the second lab, like a root container. Here we have built a root container of our application that I have shown already. We are using OpenJDK Slim Buster variant as a base image here. To make a standard Docker container image, there is a Docker Gradle plugin available that you can use to build that Docker image. I think it's not described there. No, it's not described. If you want to use that yourself, you just call that build Docker build file. I've done that already, so what I would use now is that I would use that already built your Docker containers. Just have to log in. I just already logged in. So for example, the Hello Root application I just built yesterday, I think 13 hours ago. I've pushed the latest one already. And as I've told you already, that container, if I just run that container now, that would run with default as root. Let's just try that one. Now I have to stop my application running. That's a thing that I always forget. So I already have run my application here. And try it again. So now I have running my container. So if we now go to the application, so that should still be running. What we now see is the running application running in the Docker container, not the application in my IntelliJ anymore. And if we now wanted to check what is the user actually executing that part, then it just types out, it is really the root user that executes that part. So it also uses that capabilities as we have shown before. Nothing special here. What we now also can do is checking that image for vulnerabilities. I'm using Trivi in that case, for example. It's always a good advice to clear the cache before running Trivi against your container. And then we just want to execute the image scanning. To not be overblown by plenty of reports now, we just scan for the high-end critical ones against our own container image. As you can see, it's just the first step is to download the newest information security-wise from the database. What are known security vulnerabilities for container images? Then it scans the image, and as you can see, we have different CVEs detected here. Even if that is a pretty new image, so I've used the most recent OpenJDK base image in that case, but it still has also some pretty old CVEs. And the recommendation here is now you have to look through all that CVEs that are reported and take into account if that CVE is applicable for your application. Like, for example, that CVE is quite old and is not applicable for our application because we won't compile C code in that case. Also that one. Also for PowerPC stuff and stuff like that, it's not the case. So have a critical look on all that CVEs that are reported here, and then check if that CVE can have influence on your execution of your application directly. So most CVEs here don't have a direct impact on our real Java application, but there might also be newer CVEs that directly have some problems with our application. So Trivy is really easy to install. Just download the binary and then execute the binary against your image. And as I've already told that you can just integrate Trivy easily in Harbor registry, for example. To make it a bit more secure now, you can build a rootless container. What I've changed here now is that I added the user here and using that user with that user ID. So now if I would run that command here with the rootless Docker image, before I have to stop the old one. Otherwise I would have problems with conflicting ports again. And I'm just copying that again here. Then we run the rootless variant now. And again, try to that was the wrong command, just give it the right name. So it's better to copy and paste. Now, as you can see, we are not running with root user anymore, so we're just using the application user, so not the root user anymore. And we also have different capabilities also set probably by that thing. Not in that case, so we don't have capabilities set now. We will see how to set them in the Kubernetes part later. So I think I have to hurry up a bit. So I will skip that part with the chip. That mainly does the same as the rootless container, but just using a chip plugin, which makes much more smaller images and also takes out the shell to the container. We will now skip that part and go on to the next part, to the next stage to go into Kubernetes security. But a small summary of container security 101. So really important is that you learn Linux security basics. So you have to understand how containers work, that they use Linux namespaces, use Linux capabilities, use what is called seed groups to restrict resource consumption. You should load images from trusted registries only. So Docker Hub is not a trusted registry, as I can tell. There are lots of images that have malware inside that are put there by intention to be used. Always scan images for vulnerabilities in your CI/CD pipeline, especially. Say no to root for your containers. Do not hardcode secrets into container image. Always use the Docker concepts of putting secrets into your container image on the command line. Limit the resources, memory, CPU-wise, process-wise, and also, as advice, also add the security modules like ccomp, AppArmor, SE Linux above. So Docker has also some default sets configured for you already for Linux security modules, which is also a good fit between security and usability already. So next stage would Kubernetes security. And always my first slide before diving into security with Kubernetes is the question, do you really need the complexity of Kubernetes? I've seen lots of projects that just use Kubernetes because everybody now uses Kubernetes. But that is not a reasonable choice. If you are an architect, I would always ask the architect, why do you need Kubernetes? And if I get the answer, oh, I want to try out Kubernetes, it's the newest technical thing to do, the whole world is using Kubernetes, so that is not a good answer. You should always have a business-like reason for using Kubernetes. Like you have plenty of applications you have to orchestrate. If you just want to put one application as a container in a productive environment, Kubernetes would be a much too complex environment for you. So it is a complex beast, as I can tell. And lots of developers don't understand how Kubernetes really works. So my recommendation is always to also check alternatives for Kubernetes. Very easy one is, for example, AWS Fargate. You just push your container into a Fargate service and you don't have to care anymore how to configure that. In that case, how to configure the infrastructure. So all that managing of a Kubernetes thing is not your case anymore. You just have to deal with your one application, make that application secure. Don't use root as user in a Docker file, and then just push that container into Fargate. So AWS deals about the rest. Also, you could use Google Cloud Run, which offers the same. You could still use Docker Swarm, which is not that prominent anymore because of Kubernetes. Another alternative would be HashiCorp Nomad. And then if you come to the point, yes, you really need a Kubernetes cluster, then the second advice would be never run your own production cluster yourself on premise or stuff like that. Always try to use a managed Kubernetes cluster. There are really good clusters available by Azure, by AWS, by Google, like the AKS, the EKS, the GKS. So we will have a look shortly into GKS, the Google Cloud Kubernetes cluster. Always use a managed one. So it is quite easy to spin up a production cluster at once at first stage, but it's really really difficult to constantly patch and manage that Kubernetes cluster in a secure way. So that's a really hard effort to take. So these are a really short Kubernetes basics overflow. So on the right side, you have your Docker containers. You put them what is called inside a pod. And a pod is the smallest unit running on Kubernetes, as you can tell. So you can put many Docker containers in one pod. But so the usual recommendation is that you have a one-to-one association between a pod and a container. You just only use plenty containers if they really have a shortcut communication, which would not be possible over different pods via usual network connection. So if you have a requirement that these two containers could not communicate over normal network connections, then put these inside one pod. But in 90% of all cases, just put one container in one pod. And then the main thing about Kubernetes, why all people use Kubernetes, is the scaling part. So Kubernetes deals about all your applications. So you tell, I always need 2 instances of my application running in Kubernetes. Then the replica set is the main thing that handles that always 2 instances are running. You don't handle that directly in Kubernetes. What you manage is usually at what is called a deployment. In the deployment, you tell, I need 2 instances, and behind the scenes, a replica set is built, and that is then controlled by the Kubernetes schedulers that look into replica set and always check, do we have running 2 instances? No. Okay, we have to spin up another one to confirm to the replica set. To open up your application to the outside world, what you will need is a service. So a service is what is called somehow a TCP IP layered load balancer that opens up your private pods to the outside world, and it cooperates usually with what is called the ingress service that opens up the ports to the outside world to your service. So your service always also deals with finding your pods. So if you have several instances, it does a load balancing over your pods you're running. It just uses one of the pods, and the ingress just opens up a port to the outside world, for example. And this is usually done by your cloud provider and handled by your cloud provider. So this is a really fast overview. What is more important for us security-wise is that Kubernetes opens up lots of attack vectors now. This is taken from a O'Reilly book, Kubernetes Security, which is freely available. You have plenty points to attack a Kubernetes cluster. Like, for example, as I've told the etcd port, for example, you can attack over the API of Kubernetes, what is called the control plane components. So Kubernetes always has 2 node types running, one master node, the control plane node, which is to control the whole cluster, and the worker nodes where you put your pods, your applications into. And you can also access machines, VMs inside here, which is one case that the attacker wants to achieve. Intercept control plane traffic here. Access the kubelet directly, which is the component that takes care of running your pods on the worker node. So attacker could try to communicate directly with that kubelet without going via the API of Kubernetes, or by using container escaping, get access to your node directly, so to the host directly, and then do strange things on your node, like, for example, also putting another Docker container directly on the nodes doing Bitcoin mining. So this is a visualization. So what is usually operational work on your Kubernetes cluster, and what is the development part of your cluster? So as you can imagine, the operational security part of Kubernetes is even more work. And even using a managed Kubernetes cluster by cloud providers, you also have to deal with VLANs, with firewalls, with load balancers to initially set up your Kubernetes cluster in a correct way. So you also always have to take care that there is a firewall in place, that all communications are using TLS, they're all secured with HTTPS communication, with server-side certificates and client certificates. Always use authentication and authorization when communicating between master node, worker nodes, and also for the API server. You can also read these things in the Kubernetes docu, in the 4 Cs of cloud native security. And for us, the rest of the minutes we have, the important stuff is the development security of Kubernetes. So what you can do as a developer also in Kubernetes is, for example, the easiest part is switching on, for example, Kubernetes auditing. That is usually only a checkbox when using a managed Kubernetes cluster. Then with auditing switched on, you get a log of all the actions happening on your cluster. So if anybody pushes a new pod, if deletes a pod, changes a pod, all the actions are audited in detail. So you can recognize if some other people that are not supposed to do anything on that Kubernetes cluster, would recognize that by looking through your auditing log. So that's a really important point, but very easy to solve. Then also Kubernetes provides authentication, authorization. You can do the same stuff that you have done on Docker. You can set resource limits, but by using pod security context, pod security policies, you can restrict your containers from running with a root context. You can drop capabilities. There's a newer approach called the Open Policy Agent, which could also restrict access to your containers or enforce some policies, so you cannot deploy any containers anymore having root access, stuff like that. And also you can restrict communicating between pods, for example, using network policies. So these are the base concepts you could use to restrict all the security here. For authentication, you have to take care that there are typically two categories of users on Kubernetes. There are service accounts that are managed by Kubernetes itself. These service accounts are corresponding to your applications that are running. So each application has at least a service account by default. And then you have the normal users with typically different roles on your cluster. You have different authentication mechanisms. I will not go deeper into that part because usually the authentication strategies are configured by your cloud provider already. So cloud provider, you can configure to use client certs, to use OpenID Connect tokens, for example, for authentication. So bind the identity management part of your cloud provider also to the Kubernetes authentication part. When it comes to authorization, you have to get to know how the role-based access control inside Kubernetes works. So basically, the most important thing here is that you have to deal with the service account level and the user level. You should be taking care of that. Not every user should be a cluster admin, basically. So also use fine-grained authorization for your user operating with your Kubernetes cluster. For example, you could also give a user only a role for one namespace. So you can split up the namespaces in the Kubernetes cluster for different development teams. And via role-based access control, give them only access by some role to one namespace. Only a few users should have cluster-wide admin access. So to reduce attack surface. So role-based access always works in the same way. You have a subject to bind your roles to, and on the other side you have target resources to bind the roles also to. So the subject can be a user, group, or a service account, as already told. Then you have cluster-wide roles or you have namespace-bound roles. And with role binding, you bind your role to a subject, and you can specify roles then for your target resources. And the target resource can be an API group, it can be resources, all resources like a pod, like a service, like Ingress, like all the Kubernetes services can be bound to a role. And then you have verbs, what action to take on a resource, like if you can create a pod, can get read a pod and stuff like that. So that was the authorization part. Then when it comes to resource limits, so that's the same as you would set for Docker. You can just set CPU limits and memory limits. You can put hard limits, so the limits that cannot be over committed. So if you want to use more than one CPU, then your container would be killed. And with requests, so these are the resources that you need at least for starting your application, for normal operation of your application. This is what is called a container security context. We won't have time for showing all the labs now at that stage, but you can have a look at the GitHub repository for yourself afterwards and just try that labs for yourself to put that inside Kubernetes. What you can set here is basically that you tell that it should run as non-root, and then it should not allow privilege escalation via setuid, for example. It should not use run privileged, so that's the same flag as you use on Docker. Again, run as non-root for that container. So that the whole thing here is for the whole pod. And this thing here beneath here is the run as non-root, especially for a container, because you could have several containers. So you can already restrict your whole pod from running as non-root. Then also recommendation is to use read-only root file systems. So if you need some write access to some temporary directory, then a good approach would be to just mount a temporary file system directly, but not use the root file system for that. And then drop all the capabilities you don't need. So you can also easily add one capability then, but dropping all capabilities is a usual case. So lots of containers won't need any capability. And the pod security policy, so that was a security context that you have to set for each and every container in a special way. So, but it's easy to forget to add a security context for each container. So the other approach would be to put policies cluster-wide instead with using a pod security policy. So the Kubernetes documentation specifies 3 different approaches here. So in some rare cases, you need to have a policy that allows privileged containers. Like for some infrastructure, like putting FluentD stuff for grabbing log files from syslog. These would need privileged access, but these are only very seldom cases where you need that. Most containers should use at least the baseline, which restricts it a bit more, or even better, the whole restricted one that does not allow any privilege, any any root user as for the containers. And the pod security policy looks just almost the same, like a security context. You also specify privileged false, don't allow any privilege escalation. You can drop capabilities. And you specify that it must run as non-root. And this is called a no-root policy as name, for example. There's also policy order selection criteria. I will skip that. And now it comes again the part of role-based access control. You have to bind your policies by using service accounts to your specific pod. So you declare some pod security policy, you specify a role for that pod security policy as a target. Via role binding, you bind that to a service account and you specify that service account in your pod, and then you're using that pod security policy. Because when you enable pod security policies on your cluster, as soon as you enable pod security policies there, you won't be able to deploy any container on that cluster if you don't bind to any provided pod security policy. This all sounds a bit complicated. It is quite complicated to get that all right. That's why I will skip that for now. We have a newer approach called the Open Policy Agent, where you just also deploy some additional admission controller to your cluster called the Open Policy Agent, where you can just write rules for yourself. So don't allow, for example, root containers running, where you can also have a playground to check these rules. And then you can install a Kubernetes gatekeeper that uses the open policies as an admission controller and then always checks each and every deployment here. Also check if you're using Helm 3, because Helm 2 is also playing root on your system. So we will skip that for time reasons. Summary is here. Follow Container Security 101 as I've shown. Use a managed Kubernetes cluster. Enable audit logs. Use authentication role-based access control. Use pod security policies or the Open Policy Agent as an alternative. Upgrade to Helm version 3 to remove Tiller, which is playing root on your cluster basically. And also always monitor your Kubernetes cluster. So if one tries to Bitcoin mining your cluster, then at least you should get notice of that. So the last part I will go through quickly is the Kubernetes secrets part. So how to deal with all credential secrets on Kubernetes. So it's not only a problem of Kubernetes, but also how to do that in your development environments. So a lot of people also put secrets in clear text in your Git repository, which is also a bad thing. So the good news is that you could also use Google key management systems for both parts, for Git repositories and also for Kubernetes to solve the problem. So these key management systems then do the encryption, decryption. So all secrets only are inside here. And you don't store them in your Git repository anymore in clear text. So Kubernetes secrets look like this. There's a special YAML file. As you see here, these are base64 encoded, so not encrypted. And by default, if you don't configure a Kubernetes cluster in a correct way, they are also written only in base64 format in the etcd database by default. We have seen that. Pay attention to Spring Boot Actuator. And this is what cloud providers do now for securing secrets in the etcd database. They do secrets encryption at rest so that the database itself is encrypted on the file system. So if one steals the etcd database, cannot physically access the secrets anymore because they're encrypted. And what is called application layer secrets encryption, that is also added by Google, for example. You just switch that on by some checkbox, and then it's also in transit encryption in place. This is the mechanism, how it works. So it uses 2 levels of encryption keys, a key encryption key, which lies in the key management system, and the encryption key that lies in Kubernetes to even make it more secure. Always use a key management system like Azure Key Vault, Google Cloud, AWS KMS, HashiCorp Vault, and stuff like that. So HashiCorp Vault, I've taken that picture from HashiCorp, also offers a new feature called Kubernetes Sidecar Injector, where you have to do some build stuffs here to define roles, use the Kubernetes public CI cert, then configure your secrets, and then that injector is put in as a sidecar into your pod, and it deals with getting secrets from Vault, authenticating to Vault for getting secrets, and then it deals with the whole secrets communication between Vault and your pod afterwards, and you don't have to care anymore about where to put your secrets. These are all in Vault, and Vault takes care with the sidecar to manage all these things. So there's a really good tutorial with that link beneath there. And what about secrets in Git? You can also use KMS systems like Vault, and also use things like Helm secrets and stuff like that. So best practice here is always encrypt secret data at rest and in transit, and only base64 encoded by default. So always take that in account. And also don't mount secrets, do mount secrets instead of doing environment mapping. Environments are always getting through logs and caches and stuff like that. So this is the summary. Kubernetes complex, check alternatives, follow application security 101, follow container Kubernetes security 101, ensure your secrets are encrypted, never store secrets in source control, and check out all the demos we did not have the time for today. So there are really good books to be recommended. So if you want to know how Linux really works, there's a 3rd edition coming, I think, March next year, on that book. Then if you want to harden your Linux security and understand Linux security, there's a Mastering Linux Security book on that topic. And when it comes to container security, there's a really good book by Liz Rice that was created this year by O'Reilly. I can strongly recommend that container security book. It goes much more deeper into detail than I had the possibility today. Yeah, some online references also. Yeah. Yes, I'm finished. Yeah. Okay, I just finished on time, I think.
Thanks. Thank you very much. So you can continue communicate with your audience in the Q&A Zoom room and also answer all the questions here. And I want to say thank you for you. Thank you very much. And bye-bye. See you next Devoxx. I hope so.
Yeah, thank you.
Okay, guys, and now before the next speaker, we have online Kahoot with our partner. It's company Playtika. So enjoy the time and prepare for the next speaker.
Hello. We are glad to welcome the gold partner of Devoxx Ukraine, Playtika company, and its representative, Alexei Kisilov. Alexei, hello.
Hi.
Hi, welcome to Devoxx Ukraine Online. And what Kahoot game have you prepared for us today?
Hi everyone. First of all, happy to be at such a great event despite the rough times. I'm manager from Playtika, and in this time slot I will say first of all a couple of words about Playtika and our R&D department in Kiev. And our Kahoot quiz will mix actually information about Playtika and some tricky Java questions. So pay attention to what I will say and just try your luck. So right now I already generated Kahoot quiz game and its pin. So if you see my screen, what you should do is to go to kahoot.it website or use the Kahoot mobile app if you have it and enter this PIN code. And while we're starting to getting people, couple of words about Playtika overall. Playtika is a leading gaming company. It was founded in 2010 and now it has a lot of games with almost 30 million monthly active users. It was among the first to offer free-to-play social games, and on social networks, and after on mobile applications. We have like 3,500 of employees through all over the world. We have headquarters in Herzliya, Israel, but we have offices in Tel Aviv, London, Berlin, Montreal, Chicago, and many other cities, including 3 cities of Ukraine. It's Dnipro, Vinnytsia, and Kyiv. In Ukraine and Kyiv in particular, we have our core R&D department that delivers a platform of more than 100 microservices written in Java. And this platform provides to all our games core functionality and different bundles like contests, clans, missions, and so on. And every Playtika game integrated with this platform can use the power of it. And I'm very proud of it, and I'm very proud of the high loads it can take with all these 30 million active users. And I'm proud also that the pipeline we built allows us, like department of more than 100 people, to make 2,000 deploys on our environments last month. I think the people are coming, so a few words, maybe a few promotions. We also will have a raffle later this day. We will the prize will be rather fruitful. It would be a MacBook. And also, I would like to promote the speech of our colleague. Should be today. He would tell us about some interesting case and interesting research he made here in Playtika. So I think, yeah, one more thing. All 8 questions will have 1 minute for you to answer. But because of the delay, I think it would be less time than 1 minute. So you'll be able to pick an answer like in 30 seconds gap. So keep that in mind also, and try your luck. Okay, if number 74 will be here, at least for, okay, 77. We're still getting people, so probably 10 to 20 seconds and we will start. 3 persons actually from this Kahoot quiz, rather prizes. Okay, so 5, 4, 3, 2, 1. Okay, let's start. This one should be easy. It was mentioned at least 2 times. The answers are going. It's great. Okay, we have a lot of right answers. Good start. I think after the half I will name the main contesters for the win. This one wasn't named particularly, so a little bit of luck or a little bit of Googling. Yeah, probably I will also name the question. Number of Playtika office locations around the globe is. Okay, 33 right answers. It's great, but it's less than half of all the answers we have. Let's go. Third question, how many microservices there are in Playtika platform? We mean the platform that we built here in Kyiv. It is a core bundles. It has its core functionality like segmentation. It has a lot of features, stuff like missions, contests, and clans. So, how many? Okay. A lot of people, yeah, were thinking that it should be the highest number, but not. In some day we will have 300 microservices, but now it's 125. So I will start. Funny Monkey for now is the leader, with Doctors and Andre is the second and third. Next question, how many people work on Playtika products? With the answers of 3,500, 5,000, 500, and 180 employees. This one was definitely named in the video and in my speech, so hopefully it would be easier than the previous. And yes, it was the easiest one as for now. 3,500 is the right answer. But it also matters the speed of your answers. So as we can see, there is not a big changes here. Now some Java questions. What will be the output when we enter 1 plus 2 plus 3 with some additional thing, plus 4 plus 5? Some of classic tricky questions from all Java quizzes. I hope that this question will be also the easiest. But okay, yes. Yeah, first two integers will be treated as integers, and then it will be the string, and after that everything will be concatenated, and Java will handle it as a strings. Good job. Nothing changed. Just Funny Monkey is going to the stars with his score. Again, some strings question. What will be the output if we compare these two? Okay. Fairly simple, as we see. Yeah, it's the same object, the same place in memory, that's why. And the result will be true of such comparison. We have new third and second place. Andre is second, and Rini Vesio is third, with Funny Monkey being our leader. What is the Balmer Peak? It's either a mountain in South America or correlation between imbibing and alcohol and cognitive ability improvement, or it's the name of Steve Ballmer's yacht. It's a mountain in North America. Okay, not so easy as I thought. It's a famous correlation between alcohol and some cognitive skills. If you're not heard of it, please Google it. It's really interesting. And the last question. Yeah, see what's going on here. Funny Monkey, BG, and Ekem Rayev are the top three. The last one. What is this? And some strange things. There you can see a pattern probably. Is it an assembler? An SMS of after 5 bottles of beer and average code in Playtika or load? The faster you answer, the more points you get. Yeah, it was code, and almost everyone knew it. So this is our podium. Cookie, the third place. Funny Monkey, our leader, became second, and who's the winner? It's RBG. Guys, please contact us and you will have some prizes. That was our Kahoot. Thanks, guys.
Thank you. Thank you, Alexei, for this exciting Kahoot game. The questions were really funny, some of them. So thank you. The winners, I congratulate you, and please join the Playtika chat. You will find the link at our user page, and contact the Playtika company to get your prizes. So thank you once again for supporting Devoxx Ukraine Online, and hope to see you next year with us.
Yeah, I hope to. Thank you, guys.
Thank you. Yeah, dear participants, also I will remind that Playtika has some other prizes raffles, and the main prize is a MacBook, so you can register for this raffle and the winner will be announced at the closing ceremony. And now I'm glad to introduce our next speaker, Ben Evans.
Hi guys, nice to come back to you. Hope you enjoyed the Kahoot, online Kahoot. And now we are ready to go to our next speaker in stream 3. It will be Dmitry Sergeyev. Hi Dmitry, how are you today?
Hi. I'm doing great. How are you?
Not bad, just the second day of Devoxx. It's impressive. What have you prepared for us today?
Well, I have prepared a nice talk, 2 hours long, about Kafka streams and Spring Cloud. Hope everybody will enjoy it.
Yes, okay. I'll say you good luck. And for your audience, I'll recommend don't hesitate and follow the our mobile application to choose to vote for your speech if they like it. So good
Great.
luck.
Thank you. Okay, so welcome to this talk. My name is Dmitry Sergeyev, as you probably heard. Here, I'm going to show you some cool things and discuss Kafka streams and also Spring Cloud, because that's probably the most popular framework at the moment, and many of you work with that, and it helps to simplify things a lot. First of all, about me. So I'm challenging my neck in tech for 7 years already, and I'm very happy with the latter, not so much with the former. 100 of those years are spent with Java. Prior to my current company, it was everything related to IoT. Now it's not, so really very curious about new domains. Not only Java, but also I'm passionate about urbanism product management. So in case you are interested in those topics too, I'm very excited to talk to you about, well, with some maybe online coffee cup about those topics too. And here I've got 3 books that I like the most from all the domains I like. So really recommend those. So let's start. the first question is, why Kafka? Have you ever wondered why is it called Kafka? Why is such a name? So Jay Krebs, who is the creator of Kafka, just told an interesting story about that. So he was creating a tool optimized for writing messages. And he started thinking, what name should I give to this tool? Like, it's about writing writers. Maybe it should be called after some writer. And in high school, he was attending lots of literature courses, and so he remembered Kafka from those courses, and he thought, Kafka, it sounds cool, and also it's a writer. So for writing system writer, it's sounds good. Let's go with that one. So there is no much of a relationship actually. It's just because it's writer, Kafka sounds cool. Okay, and let's go to the actual presentation. Well, we're going to cover these questions and topics here. First one is, what is Kafka Streams? What is it all about? What is it exactly? Then we're going to discuss stream application architecture, meaning from what parts constitute the upstreams application? How do you design it? How do you basically wrap your hand around what's not? We're going to do some live coding. We're going to write Kafka Streams application that uses Spring framework. It was meant to use also Raspberry Pi, but just I was testing my code, this presentation, to make sure everything works, and I had this nice temperature and humidity sensor that just was working fine, but then it just died. So I thought, okay, let's buy a new one, right? I want my talk to be 100 like ready with all this cool IoT stuff going in there. So I bought a new one, and I tested this morning my code. Yesterday it was working, everything was good, and this one, like now I have two of them, died too. So unfortunately, in this talk, we're going to mock our Raspberry Pi. It's actually nothing will change from the code perspective, but still, sorry, no Raspberry Pi in this demo. We will simulate one. Then we're going to discuss stateful and stateless processing. What's the difference when you need which one? Also windows and aggregations, not the operation system actually, but more of a concept. Then how does it work with Spring? Of course, you want Spring, right? You want to simplify things. You want to integrate with existing libraries. Just know a lot about Spring. So yeah, there will be some Spring also. Also an interesting topic, how time flies. It's not that obvious as it might seem. In Kafka Streams, there are some gotchas in there. Also, distributed transactions and deduplication made easy. Very interesting topic, a lot of debates and discussions going in there, and we'll see how we can solve some interesting problems with Kafka Streams. And last but not least is how to deploy things, how to make sure your cool, nice code doesn't break in there just because you forgot to tweak some things when you deploy things. Okay, so what is Kafka Streams? Kafka Streams is a client library for processing, analyzing data stored in blah, blah, blah. It's a cool, nice definition, but it's too long, right? We like the shorter ones. Too long, didn't read. So Kafka Streams is just a library used by your application. So it's just, a regular dependency. You add your Maven, Gradle, or just don't call anyone, Ant project, and you use it. So it's like a jar, you use in your library, just a library. Actually, it's not something something supernatural. Under the hood, Kafka Streams library uses Kafka producer and consumer APIs. So it's actually a library that works on top of Kafka, right? It uses data in Kafka topics. So everything you already know about Kafka is perfectly matches like Kafka Streams when you're going to learn it, when you're going to use it, because a lot of concepts are just they are basically the same things in there. It also provides API for processing data in Kafka. So just what I told now, those are the APIs, the functions, the classes you use to process data that flows in Kafka topics. It also contains solutions of the data stream processing problems. So aggregations, state, recovery, scaling, a lot of things you are going to develop on your own if you don't use Kafka Streams, but you do want to do some processing of data that flows in Kafka. No need to develop that from scratch. A lot of those things are already in Kafka Streams. So what are the use cases? When can you use Kafka Streams? So there are a lot of use cases, but I mentioned here the most popular ones, probably the most, just those that are easy to get with Kafka Streams. So first, website and mobile app activity analysis. So for example, you have your clicks, your impressions, views, you collect a lot of information on your website, and maybe you have a really big website and Kafka Streams help you serve in those. So you collect all this data, and for example, your business analytics, your marketers, they're coming to you and they want to get some most popular items in the last 5 minutes, or most popular comments in last 5 minutes, or something like this. So Kafka Streams give you an ability to generate this kind of insights from data in real time. So there is no need to do some batch processing, to wait 2 days and then present some batch results to your marketers, and they tell you, I know I'm not interested anymore in this thing. I needed that 2 days ago. So that's not a problem. With Kafka Streams, you can do this in real time. Then processing and aggregation of application logs, also very popular use case. So you're collecting a lot of logs probably if you have a considerably large system. And here, same thing, you can generate insights in real time. You can trigger some alerts in real time. Anything you can imagine, you can derive from your data in real time. It's about Kafka Streams. Also, an interesting use case that comes from a friend of mine, streamed content generation. So my friend is working in a media company. They're just generating some news things, and they need to be on the edge, and they need to show things faster than others. And what they do, they actually parse some RSS feeds, some other websites, some Facebook groups, different points that can generate some new information that might be interesting to a wider audience, and they feed all this data into Kafka Streams. Then they assign an importance or value or some metric that tells them that this is an interesting thing, and they maybe combine some news, combine some things, and they post it on their website. So their website is automatically generated using Kafka Streams in real time from all the news around the world, and they are basically they're the first ones. They combine all the information that users are interested in, and everything is in real time, very fast. And of course, there might be a lot of other use cases. I'm pretty sure you will find one in your project or in your past projects, and of course in your future projects after this talk. So what Kafka Streams gives us out of box? It gives us fault tolerance. So if your application just died in the middle of processing, that's not a problem. With Kafka Streams, you can actually handle those cases. You can reprocess data. You can make sure nothing is lost. You can make sure that you catch up from where you stopped, from where you failed, and all the things comes out of box. Also scaling. So because Kafka Streams is built on top of Kafka Array, it's already a system built for huge loads, for massive amounts of data. Kafka Streams continues this path, and it gives the same thing. So there is a good, nice architecture under the hood that gives you ability to scale just enormously. Also, what differentiates Kafka Streams from other similar tools or libraries is exactly one's processing semantics. This is something that comes actually from latest versions of Kafka. This is not something that comes by default. So this is very important. If you saw here that that Dmitry told you there is exactly one's processing, and you just simply created an application and went into production, not so easy. Make sure you enable some properties, and we will see which ones in a while. Also, it gives you aggregation operations like windowing, count, many cool things we will see, and we'll discuss what exactly it means. Maybe not anyone knows what is windowing, and that's totally okay. Then late arrival records handling. What if some records got stuck because of what if your internet got slow, something got disconnected in the middle while some information was arriving to your system, and it arrived late, a couple of hours after, or maybe days or something. And in many cases, you don't want to lose this one. You want to make sure you can process that, and it can get into your system in a good way. This is also possible. And also, there is an ability to extend default functionality. So if you're missing something from default Kafka Streams API, it's not a problem. You can extend interfaces and things and make some new functionality that you need on your project, and we'll see that as well. So, most interesting and most complex probably thing here is architecture. So there are three concepts you need to understand with Kafka streams. The first one is processor topology. It is actually a graph, a directed, acyclic graph that defines the logic of processing. So imagine a graph, or just look at it on the right. You have some information that flows into this graph on top. Right here I have Kafka topics on the top of the slide, and some data flows into the graph that you defined that somehow process the data. So the data flows into this graph that you defined. We'll see how to do this. It gets into processors as a stream. So the processor is a node on this picture here. It's a node in your graph. It is actually a function that can process the data in some way. You can think of them like Java Streams API, right? All those map, flat map, for each, and all those things, they are very similar, and they actually sound the same, and they look the same, and work almost the same in Kafka Streams. And those are your nodes here. So each function like map, flat map, here on a node, here in a graph, is a node that functions and somehow processes the data. It consumes the data from a stream, and a stream is an ordered, replayable, and fault-tolerant sequence of immutable data records, where a data record is defined as a key value pair. So each message in Kafka Streams, as in Kafka, is a key value message. And the processor, your function, your for each or map or flat map, processes these record one by one, and it transforms, it creates, it merges them, it maybe splits them, and it sends them downstream through this graph to other nodes, and in the end it leaves your graph, right? In the end, you maybe consume, you can send an HTTP request, you can send it to another Kafka topic, anything else, like, so the data gets into your processor topology, the graph that defines the processing logic, through so-called source processors. So if you will be reading Kafka Streams documentation, source processor is the entry point of your computational graph. And the sync processor on the bottom here on this slide is actually last node, right? Not last node in your processing graph. That's where everything stops, where data leaves your graph, or where it just consumed with some terminal operation, like for each, for example. Topologies, where's the prime Spring Boot, right? It just I wanted to start with a starter or something like this, and before we get there, let's understand one important thing: how processor topology, this Kafka Streams concept, matches your understanding of microservices, of application instances of your Spring Boot apps, right? So here on this slide, we have an orange frame. So an orange frame is a boundary, and you need to really understand this one, is a boundary of topology and microservice. So topology is always within a microservice. You cannot have topology that spans multiple different types of microservices. So topology is always inside a microservice. It is inside one type of your microservices, inside one one microservice. And there might be combinations because of this. And we have them. There actually might be three combinations. The first one is when you have your topology with multiple processors inside a single microservice. So here, orange frame, your microservice actually contains a lot of different operators, things that process the data, and you have the whole, this whole topology in there, right? The second case is when you actually split a big topology into multiple ones. When you have many small topologies, each containing, let's say, one operator, one function, one transformation. And in that case, you have a topology, right? In each microservice, you have many microservices. So each node here corresponds to a microservice. And still, you have, high-level topology in your terms. So you still have a graph, right? You have this graph, but in terms of Kafka Streams, topology is only within each microservice. But the whole one, the big graph in there, here is just your high-level thing. You can call it topology, but it's not topology in Kafka Stream terms. On the right, it's a combination of both, actually, right? You can have few functions in one microservice, another few in another microservice. And now you have two topologies, one big graph still, right? But two Kafka Streams topologies and two types of microservices. Hope you got this one. Yeah, it probably sounds complicated, right? You saw Spring word in the name of this talk, and you thought there should be a starter. I hoped to see a starter, and it just should go. So you can exhale. There is a starter. There is a project actually in Spring ecosystem called Spring Cloud Stream Kafka Streams. It's such a long name, and I bet I will make some mistakes. So don't blame me. So there is a starter that sounds something like this, and under the hood, the Spring starter uses Kafka streams. So there is a Kafka stream library from Apache in there. And also there is a Spring for Kafka library. So Spring, of course, has some wrappers, some APIs, some simplifications for working with Kafka, and those are used in this starter. What it does, it automatically creates and configures a topology. So you're not with Kafka with Spring Kafka streams. You don't set up topology on your own. You don't use topology API for Kafka streams. So the starter will do it on its own. Also, from latest versions, it supports functional paradigm. So, and we'll see that because we're modern, right? We want functional. Okay, this is enough theory, right? The talk promised some live coding, and we'll get there soon. So before we start coding, we probably need to plan, right? I hope you do. Yeah, I hope you're doing this. Yeah, I hope you're planning before you're going and coding. So what we're going to create is a simple application that consists of three parts. The first one will be the weather sensor application. It will be written in Python, and we are not going to spend time there. It's not interesting in our theme here. So this weather sensor collects temperature and humidity from some sensor, and it sends measurements to a REST API over HTTP. So the second part is a REST API application. Very clever name here. So it's just a simple application, with all those Spring controllers, and just a simple HTTP REST API that collects measurements sent by a weather sensor and forwards them to Kafka. So it's just a very simple one. Get data from HTTP, send them to Kafka. It's there because maybe you want to add, some security. You want to secure your APIs. Maybe you want to enrich data. You want to add something to your weather sensor message and send it to Kafka together. And last part, the most interesting for us here, is Kafka Streams application. So it will be a separate microservice that will consume data from Kafka topics. It will consume those temperature and humidity measurements. It will process them somehow. We'll discuss how in a moment, and it will trigger alerts. Yeah, actually, as you can see a note on the bottom here. You can actually get rid of the second one. You can actually make weather sensor send data directly to Kafka. But I decided that this architecture is probably more popular, and it gives you, it just solves more use cases. Because, for example, you can replace weather sensors with the web browser, right? And it's just, it's more usual to collect something over HTTP from the web browser, right? Okay, so let's start doing things. First, we're going to bootstrap the project, and I'm going to do everything from scratch, so that if I face some problems during coding, you'll see them, and if you face them too, you'll see how I solve them and what they actually mean. Yeah. So sorry, let me hide this thing here. Going to create a new project here. File, new project. It's going to be Maven project with Java 15, right? Why not? Why not use Java 15? Let's call it Kafka K-Stream Devoxx. Let's give it my name as a group ID, an artifact K-Stream Devoxx. Okay. Yeah, I want a new window. Okay, we got our project. Seems to work. It looks like it there. It was an easy step, right? So just hope you understood this one. Next step would be to actually create our REST service send some data to Kafka, collect it from the measurement sensor, and there will be some common library that I will explain in a while. So let's do first thing. Let's create a submodule here that will be our REST API application that will collect data from the sensor, and it will send it to Kafka. Here I'm going to use Spring Initializer, Java 15. Let's give it the same group, but just subgroup K stream Devoxx. REST, very simple, Java 15. Everything else looks good. I'm going to use Lombok just to save some time. This one needs Spring Web, right? What else? It also needs Kafka. Spring for Apache Kafka. So Spring Web for our REST API, Spring Kafka for sending data to Kafka, and Lombok for sending time. Okay, it's there. And let's add this one as a submodule here in Maven, right? Also, I want to enable auto reload for Maven, right? Just don't want to click on this thing all the time. Okay, so it got our REST application. Okay, it sees it's a source. Good. What you don't like here? Let's aggregator. Okay, doesn't matter. Let's create our simple REST API. We will call it weather controller. So it's a REST controller with a mapping. Actually, I have here another project that I tested with, right? And here is the actual code of the sensor of the Python application that emulates the weather sensor that collects some humidity and temperature and so on. It just sends them. I'm not going to show you this code. It's very ugly. Don't write code in that way. I did it just because I could. So this is the API it sends data to, our weather sensor. So let's use it. It sends data over POST, so over HTTP with a POST request. So it's POST mapping, public, nothing in return, collect. Let's just call it collect. Now we need to have a class that represents our measurements. Let's call it measure weather measurements. And I'm going to create this class actually in a common library because we will have, we'll just use the same class in our Kafka Streams application. So let's have a common module in here. Module will be just plain Maven, stream Devoxx common. Okay, in this module, I'm going to also use Lombok. By the way, I'm going to write POM files, maybe not in the best possible way. Just don't blame me because we're going to save some time here. I'm sure you're good at writing POM files. Yeah, so let's create a class here, right? What was the name? Weather measurements. Package. There is no package. Why there is no package? Let's create a package. Let's move it in there. Good. So it's it didn't get Lombok here, right? Why is that? Probably because the POM file. Yeah. Let's copy. I'm going to copy some things just to save time here. It probably complains because of the Java version, because it's 15, and maybe because it's not configured very well. Just going to copy and paste some things here. So let's make this thing here in the root, and just let's copy the same thing to here. Just make sure it works. REST common, okay. Okay, it's downloading some dependencies. Let's see if it sees. Yeah, I know. You know why? Because there is no version 1.18.16. You probably already know that, guessed that, right? That's I who is spending her time here understanding these things. Okay, while it's downloading dependencies, let's see which what is the body of the message, right? So our sensor sends this type of these fields. It's device ID. We'll have few of them, so we need device ID to differentiate between them. It sends temperature Celsius, humidity, and a timestamp. So those are the fields we need to have here. Private long device ID, private float temperature Celsius, float private float humidity, and this one is actually an instant. Yep. Okay, why it takes so long waiting for moment impaired completion? It's got stuck here. I hope my internet is working. Okay, impaired here, instant. And this one actually also needs some annotation because it's in timestamp, right? And we want to parse it so that checksum can parse this one from a JSON. So I'm going to add one more dependency here. Checksum data type GSR 310, and yeah, it's JSON format as I remember. Let me just check this out and probably just copy it from there. So this one is needed for basically parsing our thing. So back to our controller, add dependency on module common, then import class. Yeah, I added. No, why is it complaining in there? Everything looks good. Okay, so we got our measurements here. It's actually request body, right? Next, we need to send this thing to Kafka. So I'm going to have sender service is a good name. I think not, but still measurements. Create field final sender service. What's that? Let's create this class. Okay, we got it. Now let's edit, of course, so we'll be able to alter it. Create method. This one is going to be service. And here we actually need Kafka template private final Kafka template. So this is a class from Kafka, from Spring for Kafka that sends messages to Kafka. Very obvious. The message key in Kafka is long, our device ID, and the body is weather measurements. And it's very simple. Send. We give it a topic, a key, and a value. So the topic will be weather data. The key will be measurements get device ID, and the actual message itself. As you see, it's complaining because we need to define a bin for this Kafka template. So we're going to create a class called Kafka config. It's going to be configuration. And so we need to have a bin public Kafka template long measurements, Kafka template, return new Kafka template. Yeah, it needs a factory to instantiate itself. it's a bean. Of course, it's a bean. Now we need to give it this factory, another bean in here, bean public Kafka producer factory. Producer factory in here. This one is new default Kafka producer factory. It needs another arguments here, producer configs. It needs a serializer, new long serializer from Kafka. Also, it needs JSON serializer because we're going to send our messages serialized as JSON to Kafka. And the last thing here is producer configs return map of producer config bootstrap servers localhost 1992. Okay, seems legit. I hope it should work. So let's start our REST application. No, one more thing. Let's make sure it actually works, right? Let's add some logging in here. Log send. What am I writing? Sent and message we sent. Good. So now let's start this application. By the way, I have my Kafka running in Docker Compose. Let's make sure it works. It runs. Pose up. Okay, I'm starting Kafka and Zookeeper here because we need some to test it with, right? And another thing is I'm going to launch this Python application with a sensor that sends some data. And we hope, you see, it collects data. Still collects it. Why it doesn't send it? There should be a log saying sent. Or Kafka just died. Okay, you know what? Probably because some conflicts with an existing one. So I'm just going to remove it completely. Yeah, so now that we have Kafka running, let's go and create those topics. It's here, being. So inside Kafka and all installations, you usually have very useful tools. If you didn't know about them, it's very useful. One of them is Kafka topics, sh, that we can create a topic with. Just in case you don't see what I'm writing here, let me enlarge it. Localhost 1992, topic weather data, right? Create partitions 1, replication factor, maybe 1, 2. What? Already exists? Okay, exists, then fine. So our Kafka looks to be running. Yeah, send weather measurements. You see, so we're sending data to Kafka. We see our Python application tells us send the measurement, so it works. And make sure in Kafka, always make sure it actually sends data. So there is another tool here called Kafka console consumer sh, right? let's make sure we see those messages in Kafka, and the group will be some group. Yeah, so those are the messages our REST application, our sensor sends to REST application, the REST application sends it to Kafka. Good. So now we have the first part of the chain. Just let's stop things here. Okay, what's next? So we got REST service sending to Kafka. We got common library. Next is Kafka Streams application, the actual thing, right? So we need to bootstrap one more module here. It's going to be called Streams module Spring Initializer. Same package. Streams 15. Good. So again, Lombok. Here we actually need Cloud Stream dependency. Lombok, Cloud Stream, and that's probably it. Everything we need from the initializer here. Okay, streams. Let's add it as a module. And let's make sure all the things are in there too, because I had some problems with that when I was testing. Just going to copy it in there to make sure all those things works. Build, I already have build, right? I already have plugins. Plugin in here, properties, good. So as you see, when we generated project, it actually added one interesting dependency, Spring Cloud Stream, but it's not enough. We need one more. One more dependency is called org Spring Framework. Why Delta completed some things? Spring Cloud Spring. We need Spring Cloud Stream binder Kafka streams. So Spring Cloud Stream gives us some APIs, some interfaces, but we need an actual implementation of some of those interfaces that work with Kafka streams, because there are also other tools in there like RabbitMQ, for example, but we want Kafka streams. So we add this as an implementation. And if you go here, you will see that under the hood, it uses Apache Kafka streams. That's what I told you. Okay. What you don't like here? Duplicated properties. I agree. You're always right. I'm always wrong. Okay, Streams application. We have it here. Let's try to run Streams applications. What we'll see. So it's starting. And it shut it down. So because we don't have any processing logic in there, it just started and stopped. It actually also probably connected to Kafka, so it just stopped. So the next thing we need to do is actually write some code, right? Some processing logic. And let's discuss what exactly we're going to write in there. So I told you we have some temperature information, some humidity information from our weather sensor. We're going to calculate average for 5 seconds of temperature and humidity. And if those averages exceed some threshold value, then we fire an alert. So it's a nice implementation, let's say, of alarm of temperature alarm system in your home. To make sure you don't have fire in there. And in order to write this, we'll need to understand two important topics. First one is K-stream. So and the second one is K-table. When you have messages going one by one, it's a K-stream. When you have aggregations, like here, average, you need K-table. And let's discuss what it is, those both things. So stream is probably more familiar to you. It's just a stream, like a sequence of messages in a Kafka topic. Like here, you have a message with the key being Alice and the value being 1, and then you have a message Charlie 1, and so on and so forth, one by one. Messages and topic, very easy. This is called a stream, or a class that represents that in Kafka Streams API is called K-stream. Then a K-table is actually a snapshot of all values or all latest values for all keys in a stream. So if you will play messages in a stream one by one, putting them into a table like here, Alice goes to Alice 1 and Charlie goes to Charlie 2 in a table. Then when you see Alice again, you just override the existing value, if any, right? So the table represents latest values for each key in a stream. And what's interesting is that is actually a duality of those concepts. So at any point in time, you can go from a stream to a table, right? Just as we did that. But you can also go from a table to a stream. So if you will iterate over every row in the table and push it, let's say, to a Kafka topic, you will get a stream. So like here, we have a table and we just push iterating over those rows and we get a stream. So at any moment in time, you can convert K-table to a stream and you convert K-stream to a table. Now having this basic knowledge, let's go writing our first function that will calculate average value. What's here? Why is it complaining all the time? So the first thing we need is average config processor config. So first of all, functions with the latest value, they're usually defined, with the latest version of Spring Cloud, they're usually defined as beans. So our processing function is actually a bin in the configuration class. It is public. In our case, it's function. So we use just plain Java functional interfaces. Why is it function? Because function consumes something and it gives you something in return. So in our case, we consume messages from weather data topic, right? We calculate average and we send average to the next topic. So it's a function. A function that takes K-stream, just as we discussed, a stream of messages with a key being one and a device ID and a value being weather measure. I need to take this, right, and I need to add it as a dependency in here to this model. Add dependency. Good. Now import. Come on. Now import. So we get K-stream and we return K-stream. But here the key will be same, but the new object will contain average information. So it's weather measurements average. Right? Let's create class this one, and we'll populate those fields afterwards. And we need to give it a name to this bean. It will be averager processor. Good. So let's start writing. Because it's a functional interface, we have an input here. This input is actually we need to process data. So we have our temperature and humidity messages in weather measurements class, and we need to first of all we need to group by key because we want to process the average information for each device separately, and the key here is our device ID. So so we have our group by key. Then we need to create a window, and this is a new concept that we need to discuss here. A window. What is a window? A window is actually a set of messages in a topic on your time axis that you process as a whole. For example, 5-minute window is a set of messages for 5 minutes that you can process as a whole. You can calculate an average for them. You can sum them up and so on. So for example, in this picture here, we see two keys. So two keys in the Kafka topic. The first one is the green. In our case, let's say it's device ID number 1, and the blue is another key, device ID number 2, for example. And we have temperature measurements over time that are sent to our application, to our this stream function that we just wrote. And we want to process each 5 minutes, or in our case, it would be 5 seconds, as a whole. So it's a window. Windows they also have some interesting characteristics in Kafka streams. First of all, windows, they emit value each time there is a new. So even if the window hasn't finished yet, if there is a new record within the window boundaries, it will be emitted downstream. So the next topic in our case will receive this message, and we will need to find this this characteristic, because we only want to have a result of aggregation only after the window was closed. And for that, we'll use an operator called suppress. You'll see that in a while. So now that we have a basic understanding of Windows, let's discuss stateless and stateful processing. So Windows, as you probably might guess, are stateful. So they have some state over. We say we want to have average over 5 minutes. In order to calculate average, you need to get amount of records per 5 minutes, right? And divide them by, we need to have a sum of temperature, for example, for 5 minutes, and divide it by amount of temperature records that we got during this time. And somewhere we need to store how many records we have seen so far. It's a state that needs to be managed somehow. So it's a stateful operation, state. Another type of operations are stateless, right? Like for each, right? When you're doing for each, you just somehow apply some function to your incoming record, and that's it. That it just goes in there, and that's fine. No statement in here. So, for example, stateless operations are like this: send a message to another system or write a log. And examples of operators: it's filter, map, for each, or print. Stateful, and as I told you, count amount of messages, join few streams. So it's possible in Kafka Stream to actually join multiple topics and process those messages. So examples of operators: aggregate, count, and reduce. And it might sound obvious, but Kafka Streams store state in a state store. So it's actual name of the concept in there. So, it's a thing where it stores state. So state stores are actually stored in local file system using RuxDB. So there is a database under the hood on the file system that stores this state. By default, it's located in a temp folder. It is actually baked up to a changelog topic in Kafka to restore a local copy after restart. So because it stores this, it stores a state in a local file system. What if, for example, in Kubernetes, your pod just died and it got rescheduled on a different machine with a different file system, right? And there is no did I lose my state? No, because it's also baked up to a changelog topic. So so local file system is used for doing that quickly, right? For retrieving everything very quickly. No need to go to Kafka and so on. And changelog topic is used to reconstruct a local database when you got rescheduled somewhere else, your application. And also, it's very important to understand that you need to have application ID set in your Kafka Streams application. It's a property. I'll show you that later on. It differentiates different like names of the changelog topic and so on. For example, we have changed the format of the data you store in the state store, and it's maybe not backward compatible. In that case, you need to change application ID, so it will use another name for the state store. Okay, let's get back to code and now try to code all the things I mentioned. We're going to finish the average processor. We're going to write the alerts processor, and we're going to launch everything up. So we got our weather information grouped by key. So for each device, you'll see that it gives us k group stream. Now we want to have a 5-second window for each device, and for that we use time windows of duration of seconds 5. Another thing here is a grace. So grace is amount of time Kafka Streams will accept late arrived messages. If you remember, I told you you can do late arrival message handling in here. So grace is a, let me go to a picture here. So here on the picture on the right, you have W10 and some messages in the window, and you see some of them are, the last one on the right is discarded out of grace. But the third one is actually not, even though the window was closed already. That's because a grace time was configured. In our case, we're just going to set it to 0. No need for grace time. We just simplify things. So if something arrived late, we just discard it. So now we have time window case stream. So a string of messages by 5 seconds for each device, and we're doing aggregate. Now we are actually aggregating this thing in a window. So we need to give it some functions. I'll discuss which ones exactly. So first of all, we need to have some class, some object that stores this intermediate state while we are aggregating. And we'll call it very simply intermediate aggregation state. Let's create it right here. Private static class, intermediate aggregation state. Class, forgot you name it, class. Data, all args constructor, no args Lombok to the rescue. So intermediate aggregation state is going to store information that we need to calculate average. So it's amount of records and their sum. So it's temperature count, how many temperature records we got, their sum, temperature sum, also amount of humidity records, then amount of sum of humidity records. So later on, when we collected all of them for our 5 seconds, we're going to divide sum by count and get an average. And here, just return new intermediate aggregation state. Now, the actual thing that does aggregation for a window, it actually returns key value long weather measurements. It also takes a window. Yeah, no, sorry, I'm wrong. I'm wrong here. It gives us the result of the aggregation like this. It takes message key, in our case, it's device ID. It takes a new message that comes that we need to add to the aggregation, and the previous aggregation result. So we are going to return new intermediate aggregation state. So temperature count, what we're doing intermediate aggregation state, get temperature count +1, right? So we got a new message here, +1. Then intermediate aggregation state, we get a sum of temperature we saw so far, plus we add temperature that we got here. Then humidity, and humidity sum. Okay, so this function, right, will be applied to each incoming message in our window, and it will add it to the aggregation, add it to the sum and to the count. Another thing is, because, as I told you, we need to use a state store. We need to Kafka streams need to store this intermediate aggregation state between retrieving different records from Kafka. We need to help it a little bit with that. So we say that this state store should be materialized with a serializer of type. The key is of type long, and the value is of type JSON serialization. and we give it a class. Okay, now that we aggregated them, we have those aggregated values. We need to do suppress. So if you remember, as I told you, by default, Kafka Streams emits a result of this aggregation downstream each time new record is received, even if the window itself wasn't closed yet. So for that, we use an operator called suppress. So we say, please don't send aggregations downstream unless window has closed, and also we say we give it a size of the buffer, the maximum size. You know, you can configure that if you got too much messages in there, then okay, I'll let you send this message downstream. But in our case, we use unbounded, so it will just keep it there forever, until the window was closed. Then you'll see that because we were doing aggregation, we got a key table, right? Where device ID is a key in this table, and the aggregation result is a value. So now we need to convert it to a stream. Remember, I told you at any time you can convert key table to a stream and vice versa. And then we do map. We need now to take those intermediate aggregation state for each device and calculate the actual averages. Very simple. This average, key value being long, and the container for our average, right? So we return key value pair where device ID is still being the key, and the container that holds the actual averages. So let's add them here. Let's add a device ID in there, just make sure we have it. So what do we have? We have floor. We have, let's do double temperature average, right? And private double humidity average. Okay. Yeah. So device ID still long windowed key. Temperature average should be simple enough. So intermediate aggregation state get temperature sum divided by intermediate aggregation state get temperature count, right? And same goes for humidity. Okay, seems to be the thing we wanted, right? So now that we have average processor, let's write the next one. Let's write the one that will be sending alerts. Or you know what? Let's try to start this one first of all. So let's start our streams application. Let's start our REST application. Let's start our weather sensor. Okay, so see now that our Kafka Streams application doesn't shut down anymore, because now it's so that you have a function, right? You have a function that does something, but you have probably mentioned but we didn't define any topics in Kafka Streams application, because how does it know which topics to use here and which topic to send data to? And the answer is know-how. We need to basically define this thing. So let's stop it. Let's go to application properties that I'm going to actually change to YAML. And we need to define some properties here. First, we need to define Kafka. We need to define cloud stream bindings. So each function, each processing function, like this one, like averager processor, is actually a binding in cloud stream terminology. So you take it, name of the function, the name of the bin. You say in 0, which means first incoming argument, this K stream, because as you remember, you can merge a lot of them, but in our case it's just one. So this incoming 1 destination is weather data. That's the name of the Kafka topic. And out, meaning where we're going to send data to, out 0, we're going to send it to a topic called weather aggregation, right? Another thing is that you can also define things like Kafka boots server hostname and port, right? But by default, it connects to localhost 1992, which is good. In our case, that's totally okay. So let's restart it once again. So what we are going to see, we want to see aggregation, right? I have restarted wrong application. So we want to see data in the weather aggregation topic that has aggregation. So we're going back to Kafka console consumer, and we're going to listen to another topic here. And we want to see some values here. So 5 seconds, right? REST application, sends data. Okay, opening store, something is going on. So it's opening the store for aggregation, right? And we see aggregations. So this is the topic with aggregations, and we see temperature average and humidity average. And you may notice that even though we're sending data pretty often, it's actually 1 second or something like this from the sensor, we are not getting them here. And you'll see that we'll see few messages here in a batch, right? But I promised you real-time processing, no batching. That's actually possible, but here by default it uses Kafka commit interval of 30 seconds and stuff like this. So everything every 30 seconds are committed to Kafka at once. That's why we see 6 messages, right? Because 30 seconds divided by 5 seconds for Windows is 6 messages here. And I will show you how to change that so that it's really real time and one by one. Okay, we have our averager processor working. Next thing is create a processor, another function that triggers some alerts if temperature is too high. Let's call it alerts processor config. Same, it's configuration. And we're going to define a bin, public here actually it's consumer. It's interesting, it's something different. So we had function previously here, function, but here we have consumer. And the reason for that is that alert processor is going to consume data from a Kafka topic and just see if it exceeds the threshold and just write a log. We're not going to send the result to another Kafka topic. So it's a sync processor, right? In terms of Kafka, it's a terminal operation. It's just like a for each. So it consumes a stream of long and average here. Import. And alerts processor, return input, and guess what? It's just for each, right? It's just a for each action. We're just taking like a record from Kafka. Oh, it's actually a pair. It's probably a pair. It's probably a key, right, and a value. So a value here is our aggregation, our average, and we're doing a very simple thing. If value get humidity is more than, let's see, what values do we have? Humidity 50, 51, 50. Okay, so if it's more than 51, then just let's do some log. Let's do log barn threshold reached and a value. Okay. 51D is probably, oh, it's fine. Okay. It's a bean, right? Don't forget to define it as a bean. And let's restart our application. No, one more thing. We forgot to do the same thing, right? We need to tell our second processor where to take data from. So in our case, it's alerts processor in weather aggregation, right? So what is out for a previous one is an input for this one, and no out here. Let's start it. Boom, exception. What's here? Multiple functions found, but function definition property is not set. So when you define multiple functions in Kafka Streams in Spring Cloud, actually you need to help it a little bit to make sure you want all of them, and or which ones you want to have actually. So you need to define this small little property here, function definition, Spring Cloud function definition. And the function names, and here you need to put function names separated by a semicolon. Once again. Okay, threshold reached, right? It works. But there is one thing you really need to always set in the settings. And the thing is, it's, I think, streams binder functions, this thing. I need to take each function and give it an application ID. Remember, I told you that application ID is actually used as a Kafka group, consumer group, and also used as the like a prefix, the key for the state store. So if you have a state store in multiple functions, there might be problems, and there also might be problems with committing your offsets and other things and fetching data. So always give it an application ID like this. And so in future, if you change the class, the structure of the object you store in a state store, you can just dump the version here and push it to production, and it will use another one. It will not collide. Once again, start. Okay, so we see messages threshold reached, right? So which means that our second processor works. It gets some data, and it works, right? So going back to our slides, yeah, this one we covered, this one we wrote. Another thing to understand are the different concepts of time in Kafka Streams. So you might be wondering, I told you we have created a window of 5 seconds in our code, right? But what is the time of an event? Meaning each record that gets to our application, what's the time of that record? Is it the time when our application received it? Is it the time when Kafka received it? Is it the time when it was created? Like if you remember, we added some timestamp initially into the class we're sending here. no, sorry, it's a wrong project. Here, timestamp, right? But we haven't used that, and that maybe Kafka uses it automatically, or so this is something that is not clear at the moment. So there are actually three types of times in Kafka streams. The first one is an event time. It's a moment of time when an event happened on the source. So in our case, event time is this timestamp that we send from a device. Then processing time is a moment of time when the message is processed by an application, right? It's also legit. And the ingestion time, moment of time when the message got into Kafka. So in order to use one of those, you actually need to implement timestamp extractor interface and help Kafka streams a little bit to basically understand what is the time of an event. And we're going to create this interface here. Where is our streams application? Whether timestamp extractor. Where's the thing getting popping out here? Implements timestamp extractor from Kafka, which implements method extract that takes a record. So each record that goes through your application is passed through here, and its key and the value, of course, right? And you need to help to give Kafka time of that record. You can somehow derive it from record, or you can use partition time, or whatever you want to do. So in our case, because we have different classes that are going through Kafka, like weather measurements, weather average, and so on and so forth, let's create an interface. Let's create an interface called weather timestamped. I told interface, right? That has a simple method, long get timestamp. And our classes are going to implement this interface. Yeah, because it's from block, it's just not obvious, but I'm going to do it like this. Okay. Override timestamp, just to make it clear. So we're going to use milliseconds as a timestamp in Kafka, and also we're going to give our average here same timestamp. Implements timestamped. And I forgot to add it here, actually. Right? To epoch millis. And probably something got broken here, right? I need to give it a timestamp. Let's say the timestamp of the aggregation is the time it was aggregated. End time. Good. Okay. It looks good. Yeah, but now that we defined extractor, this one, we need to. Sorry, you haven't defined it yet, actually, right? We need to define it. We need to take record value if record value is instance of whether timestamp. I haven't enabled preview features, so it's just whether timestamped. Then return whether timestamped value get timestamp. Or if we're not lucky enough and just some another thing here, log barn strange class here, and we return system current time. Okay, and we need to help Kafka streams a little bit. We need to actually define the binder configuration, default timestamp extractor. I need to give it this. Why is this thing popping up again? We need to give it this class so it uses it. And let me rerun our streams application. Oops, some exception. Because timestamp is null. That's interesting. That's why. That's because we have some old messages in there that were that get into Kafka without this timestamp field in there, right? So we have some schema migration task going in here. Let's just do it very simple. If timestamp null, then system current and mills. If not, then use this one. Not something probably you want to do in production, but still, that's how we do it. That's how we migrate schema here. Okay, looks good. Looks good. So we have defined this thing. Going back to our presentation. One more thing to understand with a string time is that Kafka Streams understands what time is it now only when a new message arrives. So it doesn't use your computer's clock. It doesn't use it. It uses time of an event. So at any moment of time, Kafka Streams thinks that the current time is the largest, the newest timestamp it ever seen. Okay, so it derives time from the records, not from the clock on your computer. And knowing that, let's test an offline scenario. Let's simulate some interesting thing. What if our IoT sensor got offline, right? Maybe you have some, I don't know, some sensor somewhere in on a ship somewhere near in the Pacific Ocean, and it just got disconnected from the internet, which is okay, right? And when but the data was still accumulating on that ship, and when it got online again, when it got into some port, it just streamed all the data again. And we want to make sure it works. Just let's test the scenario. Let's see how it goes. So I have here actually two instances of weather sensors. I will launch them. And the difference is that one of them uses localhost for as an address of my REST application. Another one uses weather station DNS name, host name for sending data. That is actually equals to localhost as well, right? As you can see. So it works. It should work. We see weather measurements from device 1. That was the first one, and very soon we will start seeing messages from a device with an ID 0. Let's wait a second. So let's actually. Yeah, so here in the aggregation, we see device 0, device 1, device 0, device 1 seems to work, right? Now let's try to emulate a disconnection, a loss of connectivity for one of those devices. And I'm doing that very simply. I'm just changing a host name here, and we'll see that one of the devices. Yeah, so this one, you see, it stopped sending measurements. No sent measurement anymore. So it's now offline, though it still generates some data. And the code is written in a way that it stores them in a queue, and it will push them, it will like pop them once it gets online again. So let's try to do fix the connectivity for that device. And because it's Python, you know, it's just not so quick as Java. And of course, it's not because of that, but we'll see that it got online again and sent measurements in a minute or so. So let's just wait here for a sent message. I believe there is some exponential backoff or something like this going in Python library I'm using for sending data. And that's why it just has some big pause until it begins to send data again. Yeah, you know, it's all the time I'm testing this thing. Yeah, I got an error sent measurement. So okay, it started sending data, and let's see our logs of our application. So everything looks good, like no errors, looks fine. Here we see device 0. We again see messages from a device 0. So it looks like this use case worked fine. It looks like everything is great actually. But if you're doing something like this in production, you have like big problems. So let's try to actually enable logging level for org Apache Kafka streams to debug. Restart our streams application. And simulate the same case. So I'm going to send one of those devices offline, changing the DNS, changing the hostname mapping here. Okay, it stopped. I think it's fine. And now let's fix the internet for this device. Once again, we need to wait a minute or so for this thing to get back to life. Come on, it's Python. Never as quick as Java. Yeah, make sure we see logs here in our streams application. I don't know if it's an oh yeah, finally we got messages. We got some logs here. Oh my god, you know what? You won't see what I wanted to show you because wrong name here. Extractor. It's actually not uses our weather timestamp extractor, right? So yeah, that's a problem. We have to restart it. So always test your code, right? Always make sure what you wrote there actually works. Okay. Again, quick disconnection for our device. Let's wait actually just 5 seconds and bring it back to life. Yeah, so here now it says weather timestamp extractor. And again, we're here waiting for this Python library to come live again to start sending data after disconnect. Come on. I'm not sure it's actually an exponential backoff. It looks like it's just some static backoff after it got some error and just waits for a minute or so. Okay, send measurement. Boom. That's what I want to show you. Skipping the record for expired window, and it's you didn't see that on an info level. You see, that's a problem. Actually, records that arrive from the sensor that was offline, records that were generated during its offline period, are skipped. They didn't get to your application. It just Kafka Stream just dropped it out, and it might be a big problem for you. So I was working on a project involved in collecting health information, and we saw this problem. Luckily, we saw it not in real patients, not in real world scenarios, but it's a big problem. And I will tell you why it happened and how to fix that. So once again, messages sent by a device that was offline are skipped. They are just skipped by the Kafka Streams application, and you didn't know that unless you enable this locking level. So it's only possible to make sure you didn't skip them by having some testing in place, by just making sure it's in somewhere else. Let's discuss what happened. So expired window, why? The problem is that stream time is tracked per partition, not per key. If you remember, I told you that Kafka Streams thinks that the current time is equal to the largest time of the last event it saw. And because we get two devices, the one that was online all the time, the green one here on the picture, and the device that was offline for some time, the blue one here on the picture. The Kafka Streams saw newer messages with newer timestamp for the green device here, and it just advanced the time. And when it got messages from with an old timestamp, those that were collected during the offline time of the device number 2, it saw it, but the time is already more than 15, like on this picture, and it just got rid of them. So the problem is that the stream time is tracked per partition. So actually, if you have many keys, many devices in this case, sending data to one partition, which is a very common scenario, and that's something you want to do, you might have some problems if you have offline generated data. So there is a ticket in Kafka Jira where there is some discussion about this, and that some ideas that maybe there should be an ability to track time per key, not per partition, so there will be no collision of times for different devices. But this is not something that is there yet, although there are some solutions. So you might wonder, okay, what's now? So Kafka Streams doesn't work for Internet of Things or other use cases where you need to generate some offline generated data that was sent just too late. Actually, there are solutions. So first, you can create a custom operator that implements that basically you can implement a custom function in Kafka Streams that can track time per key and not per partition. And I actually pushed an example of that with this long name of the class in the GitHub repo. You will have a link after this talk where you will see a solution for that problem. And really, if you work with IoT or something where you have offline generated data, this is the solution you really want to check this out. Another solution, of course, to wait for a solution from the Kafka team. Although it's almost a year since this ticket was created, and I was participating in discussing that with Kafka team, and unfortunately, there is no solution out of box at the moment. And of course, there is always another solution. So because the time is tracked per partition, you can create as many Kafka partitions as there are keys, right? So you will have a separate partition for each key or for each device in our case. So time will be tracked separately. And of course, that's not very sophisticated solution, and you'll get problems scaling that out. But if you don't have a lot of keys, then why not? That's easier than writing some custom code. You can just do this thing. Yeah. One more interesting use case. Now that you know about K stores, about those K tables, right? Kafka state stores K tables, you can organize tables in Kafka. So even though Kafka is everybody thinks about it as a queue, as some log stream of messages, it actually can be used as a database with a table. So let's see an example here. So on one of my projects, we had a problem. We had so each rectangle here is a microservice. So we had some source of possible duplicates. Some microservice upstream was generating duplicates, but it was only possible during 5-minute window. So after 5 minutes, no duplicates. But during those 5 minutes, some duplicates were possible. And on the bottom, we had consumer who doesn't tolerate duplicates, who really will fail, and the whole business will struggle if some duplicates will get in there. So what was implemented before I came there and we started thinking how to fix that. There was a deduplication implemented in the PostgreSQL. So for each key sent to Kafka topic, to microservice number 2 here, there was a Postgre tracking each key. And when duplicate arrives, you're going to PostgreSQL. You see if this key is set to processed, right? If it exists there, then you kind of skip it as a duplicate, right? And if it's not there, then it's first time, and you write it to Postgres and you send this thing downstream. And those of you who are into distributed systems probably saw a problem here already. The problem is that, let's imagine a scenario that we have a message that goes here that writes its first time, right? It writes it, the second microservice writes its key to PostgreSQL, and then it dies. The microservice dies. So you already have a message in PostgreSQL, but you haven't sent it downstream, right? So Kafka, for example, let's say our Kafka message wasn't committed, your Kafka transaction, and so this second microservice gets this message again, right? It gets it again, it goes to PostgreSQL, and it sees that it was processed already, and it skips it, right? So it's just you lose this message. This message is not sent downstream. You can say, okay, let's swap these things. Let's first send it downstream, then write to PostgreSQL. Okay, in that case, again, what if your microservice dies in between? So you have already sent this message downstream, but you haven't written that to PostgreSQL, right? And same again. Now, new message comes here. It sees that in PostgreSQL there is no record of that, and it sends again. You get a duplicate. So So you have basically two ways to write a code. One that potentially loses the message. Another one that potentially creates a duplicate. Right. The problem is that sending message downstream and setting and writing that to PostgreSQL is not an atomic operation, and it can be broken in between. Right. So a very cool thing in Kafka Streams that helps you to solve this is a K store. That's what I told you. So the cool thing is that you can actually replace PostgreSQL in that case, or any other, let's say, relational database, for example, or any other database with Kafka Stream state store. So you have same table that we got in PostgreSQL, but now in the Kafka Streams. And the cool thing is that now you can use single Kafka transaction for committing incoming that you received incoming message, writing that to a deduplicator tracking table, and also sending this message to the downstream as a single transaction. So all steps 1, 2, and 3 are becoming a single Kafka transaction. Those are now atomic operations. Those are all are applied or all are rolled back, and that's a very cool thing. In many cases now, if you have some tables in remote in third-party databases, you can now replace them with Kafka Streams table, and utilize a common transaction, a common atomic operation to make sure you don't have duplicates, you don't have lost things, and you're getting exactly once here, and you're getting deduplication. It's very cool, and it works on top of Kafka transactions. You better go and read about that before you implement those things, so you understand only how it works, and you need to make sure that you deliver it to Kafka and not to HTTP, for example, or something like this. So just go and read about that. There will be a link in the end. In order to basically you enable this use case, in order to make everything in a single transaction, it's very easy to do this in the Kafka Streams application. You just need to enable this option, this long one. I'm not going to read that. Set it to exactly once, and you'll get transactions. You'll get every incoming and outgoing message reading in a single transaction and committed as a single transaction in Kafka Streams. So let's try to enable it. So it's configuration here, processing, guarantee. Oh, make sure you write it correctly here, or you will not get the transaction. You might get problems here. So restart our Streams application. Not sure it's it's written here. Good. And by the way, we will also see. Yeah, let's wait till it starts. An interesting thing here, after you enable the transaction, is that now messages for each device are sent one by one. Remember, previously we got a 30 seconds commit interval in Kafka, so we got all the messages in batch. Now, because you have enabled transactions, Kafka Streams commits for every message it got, right? Because every message is a separate transaction, is a separate atomic operation, and it now commits them one by one. So now you got this real-time processing with no batching, and it's just that simple. So you get exactly once, and you get like real time with one option. It's very cool. Yeah. So last but not least, things to know when deploying to cloud. So first of all, make sure you're using one of the latest Spring Cloud Kafka Streams versions, because Spring Cloud Actuator Health Endpoint didn't track Kafka Streams liveness before version 3.0. And you know what? That means that if you get an exception in your Kafka Stream processing logic, this Kafka Stream thread just dies, and it sits silently in there, and your application is still running. It's not going to shut down. It's not going to die. It's not going to inform you. No, there is a log, of course, but are you tracking logs all the time? So make sure you are using latest version with a health endpoint. Actually, health endpoint tracks real liveness if there are any problems with your application, and make sure to restart it once your monitoring system got this problem. Also, it's better to have the same persistent temp folder. Remember, that's the folder that stores those intermediate aggregation states between application redeploys, because it helps Kafka Stream to recreate state stores immediately, as opposed to rebuilding from the changelog topic. So if your Kafka Streams application dies and it got some state in those state stores, and when it recreates, let's say your Kubernetes schedules a new container, right? If it sees the same TMP folder, it will use it. It will use the state in there, and just quickly it will start very quickly. But if it doesn't see this TMP folder, it will go to Kafka Stream changelog topic, where the state is backed up, and it will reconstruct the whole K table in this store by reading one by one all the messages in the change log, which is long. So that's why it's better to make sure your local, the place where your state store is stored, is visible between redeploys, between rescheduling of your application. So it's, for example, you might consider deploying to the same node, or you can use stateful sets in Kubernetes and it will do it for you. Yeah, and that's actually it. I hope you really enjoyed this talk. There are a lot of questions, of course, and topics I could cover, and hope to have a nice, cool discussion after this talk. Here you can find some QR codes for examples for the code I wrote here in the middle. There is on the left. There is also a QR code with the Google Doc that contains links to some topics, articles that explain some things I showed you here in more detail, so you can really nail those topics. And on the right, there is my Telegram channel. Please subscribe. And from time to time, I'm posting there some interesting things that were not covered here, some deep dives and some cool things. That's actually it. Thank you.
Thank you, Dmitry. Thank you for this deep dive, and you can continue the communication with the audience in your Q&A Zoom room, and also answer all the questions here. Thank you very much.
Thank you. Thank you too.
And now, guys, we'll have a presentation from our gold partner, Svitla Systems.
Okay, welcome back, and I'm glad again to introduce our gold partner, Svitla Systems Company, and the representative, Natalia, who will give the short presentation about the Svitla Systems.
Hi everybody, my name is Natalia and I'm talent hunter at Svitla Systems. Let me tell you more about us. Svitla Systems is a multinational software company. Our head office is located in California and business and development offices around the US, Mexico and Europe, Poland and Ukraine. We have 600 plus developers and provide a wide range of development services for such well-known companies as Ingenico, Ancestry, Thermo Fisher, AstraZeneca, and others. What I love most about Svitla is the freedom to choose your work location. And thanks to schedule flexibility, you get more time for your hobbies, family, and less time commuting. And what is also very important, no micromanagement. Moreover, there is no bureaucracy. Any question is solved quickly and easily. We care about your comfort. We do everything we can to help you focus on your work and your personal life. We truly appreciate our developers' work-life balance. We enjoy some vacation days, national holidays, days off, sport activities, family days, and splendid birthday presents. We care about your education. Svitla constantly organizes in-house and public tech webinars named Svitla Smart Talk. You can visit our Facebook page to see the schedule. Also, Svitla covers tickets for others' IT events and courses. Svitla is well known not only for its family-like attitude, but also for a big number of most innovative projects. I'm going to show you several projects we are especially proud of. For some of them, we are hiring now. The first one is a leading traveling platform. Each month, it helps over 400 million developers to make their trips across the globe. The app is available in 30 languages and works across 50 countries. Leading team collaboration platform like Skype and Zoom, it helps enterprise users stay connected. It is used by thousands of companies and sends over 500 million messages daily. Multinational US technology company focuses on e-commerce, cloud computing, digital streaming, and artificial intelligence. Next one, a biotechnology leader, American provisioner of scientific software and services to healthcare, life science, and biotechnology. Safety observations solution, trained to recognize construction risks in photos and other projects' data. It creates an automated risk assessment. Global leader in robotics, enables self-driving robots development, deployment, and operations. Works in 40+ countries, serving the mining, military, aerospace markets, and agriculture. Of course, we have more projects to tell you about, and we will be happy to do it personally. You're welcome to learn more about us on our career page on svitla.com. And now for more exciting part, our prizes raffle. Take a chance to win our awesome backpacks, AirPods, thermocups, and t-shirts, and more. Go to the Devoxx website to see Svitla systems page. You will find two options. First, simple fill-in form, and second, advanced Java quest. If you wanna challenge yourself and solve our tricky tasks. Again, links to raffles at Svitla systems page at Devoxx website. Thanks for your attention. I hope to see you at Svitla. Take care. Bye.
Thank you. Thank you, Natalia. Very exciting projects you're working with. And yeah, guys, very exciting prizes, new AirPods. So just solve the Java quest from Svitla Systems and take your chance to win. Thank you.
Thank you.
In Itera, we are specialists in creating digital business. We have a proven track record of developing innovative solutions that bring great user experiences and high business value. Our method is to work in cross-functional teams, combining our skills of business development, service design, user experience, development, testing, security, DevOps, and cloud platforms. We are always excited about collaborating with new, innovative customers and have high ambitions for common achievements in areas such as designing excellent user experiences, scalability and cost benefits improvements through our hybrid delivery model, providing more for less, increased operational effectiveness through smart use of technology. And this is just the beginning.
Hi guys, and I'm happy to invite our next speaker. It's Devlin Duldulau. Hi Devlin, how are you?
I'm doing good, thank you. How are you?
Not bad, thank you. I see as in all video on YouTube, you are in the hat. You're wearing
Oh,
hat every time?
yeah, yeah.
Is it so
Hat
cold in
and
Norway?
a beanie. Yeah, it is, and not only that, I have a curly hair, so I tend to put some hat because otherwise it would be just like boom.
Oh, every girl dream about curly hair. Okay, Devlin, thank you very much for this nice small talk. The stage is yours. I'll come back in 25 minutes with the questions.
Sure. Okay, so let's start. By the way, again, I'm Devlin Duldulau. I'm a senior consultant here in Norway, and I'm here to talk about Paceto, or platform agnostic security tokens. Okay, so just a recap of JWT. We know JSON Web Tokens are an open source industry standard RFC 7519 method for representing claims securely between two parties, right? And here's the JWT sample. You have the subject, right? And IAT as issued at time. This is just a basic of JWT, just to have a recap here. Of course. So next, oops, slides here. Delay. So JWT is used today for securely exchange information between two servers and for a single page application authentication and authorized operations across servers. And we have acronyms for this. Let's go for some acronyms here in JSON world. So we have here the Jose, I don't know how to pronounce that. It is a framework intended to provide a method to securely transfer claims between parties. And here we have this JWT, which is representing claims in compact in URL safe means. And JWE, yeah, we also have JWE, which encrypts content. JWS secures content with digital signatures. And we also have JWK, represents keys used for signing and encryption. And lastly, JWA, this is actually a cryptographic algorithm and identifiers used with all of the above. And some supported algorithms here. We have HMAC plus SHA-256, which is asymmetric, RSA plus SHA-256, which is asymmetric, and we also have ES-256, it's an asymmetric key cryptography, algorithmic elliptical curve digital, etc., and PS-256, which is RSA also, using SHA-256 and MGF1. So these are just supported algorithms of the HOSE. And just a quick look back on symmetric encryption and asymmetric encryption as well. In symmetric, one key session, and in asymmetric encryption, we have the private and public, which is two keys, right? And so signing versus encryption. Encryption, unreadable, unreadable data to unauthorized parties. That's how we use it. And then also for confidentiality. And for the signing, we need it for data integrity and non-repudiation, message authentication, and most of all, integrity. And there are also multiple ways of signing. So here we have with the secret using HMAC, and another one with a private key using RSA, which is asymmetric. So yeah, these are the ways of signing. And another one here, remember, multiple systems can issue tokens, and a token can be used by multiple systems, and all of these systems can use different libraries. So we're done here with the recap. So let's go to the vulnerabilities and exploitation in JWT. Here are just samples, or most common, and you can also find a lot of these vulnerabilities. So one would be not checking the signature. So some JWT libraries methods here are decode and verify. So we all know here's the decode. It's just gonna decode the token without verification or verifying it. Yeah, and getting the claims or the payloads of the token, but not really checking if this comes from a reliable source. So exploitation here: get a token, decode and tamper with payload, then send the token. Now you can use it. So that's one of exploitation here. And another exploitation that you can see in JWT is the none algorithm. None, so meaning used to be supported actually by default in few libraries. Basically, none don't sign the token. So that's the meaning of none. And exploitation here. How to do it? Get a token, decode the header, and change the algorithm none or none. You'll see, and then decode and tamper with the payload, and keep or remove the signature. The second, another exploitation here in JWT, we have algorithm confusion. For instance, the token has been signed using HMAC instead of RSA. If you tell the receiver it's an HMAC and it verifies it with a public key, thinking it's RSA. Exploitation here in algorithm confusion, you just get a token signed with RSA, you only have access to public key, and then decode the header and change the algorithm from RSA to HMAC, here's our sample, and then tamper with the payload just replace it, whatever you want, and then sign the token with the public RSA key. Another vulnerability is the KID parameter. So KID is an optional header claim which holds a key identifier, particularly useful when you have multiple keys to sign the tokens and you need to look up the right one to verify the signature. This is done prior to the verification of the signature. And exploitation here. Yeah, here, get a signed token containing KID parameter, decode the header and change the KID with the SQL injection payload, tamper again with the payload, and then sign the token using the return value from the SQL injection. Another vulnerability. So we have here weak keys. So an example, JWT sign with the HS256 here and secret. So remember RFC 758 standard states that a key of the same size has the hash output. For instance, you have 256 bits for HS256 or larger must be used with this this algorithm. So you can easily extract the secret key here. Because why? This only 4 characters here. It's like SN1F. You can easily do this. I'll let you show how. Exploitation here. Get the JWT cracker. You can download this. It's you can find it in the internet. Just Google for JWT cracker, and then run this JWT crack, and then pass the token, and you can now extract the secret here. For example, here it's SN1F. This only takes, I think, 10 seconds, depending on your computer. So the moral lesson here is, as much as possible, use more than 16 characters or 12 characters to create key or for your keys, because the longer the characters of your key, the more protected your token will be. And there's more actually. Invalid curve attacks, and library CVE. You can also find this online. There's a lot, and etc. So these are the expectations that you can find in JWT. So developers need, we need easy to use tools that don't open the door to a ton of attacks, right? And there are a lot of ways for JWTs to go wrong. Bake in the HOSE or the JOSE standards that I showed you earlier. The HOSE, the advocate response to this criticism of different exploitation is use specific library. So that's their response. The problem here is this shifts the blame into the library developers and the library users. And we have these industry anti-patterns here. Example, standard designers. Let's give users a lot of choices. So that's an anti-pattern. And the advocates, they'll blame the implementation rather than the standard. And the security experts would say declare a standard harmful, and then they provide no alternative. And then we end up, we developers, we end up rolling our own crypto, which is not the recommended way. So can you really blame us developers? And here's Paceto. So what is Paceto? Platform Agnostic Security Tokens. So Paceto is this is what you can find in the Paceto website. Paceto is everything you love about Jose or Jose. The JWT, the WE, the JWS, without any of the many design deficits that plague the Jose standards. So let's go to Paceto format. So here's Paceto format. We have the payload, we have the purpose, the version, and there's the optional footer there. And you can see also the color here. The version would be this V2, and the purpose will be the local here. You can see it also the explanation later. And the payload, which is this token here, and then the footer. So what is the version? So version tells you what version of Paceto is being used with token. If version 3 comes out a year from now, then users would only be allowed to use version 2 or version 3, but no longer version 1. So compatibility mode, you can see there, and then the recommended one is the V2. So what about the purpose? So local referred to as symmetric or shared key Pacetos, because that is the type of cryptography that they use. Always encrypted, so that's local. An attacker that was able to get a hold of the token will not be able to see the data inside unless he has a key. The public, on the other hand, both Pacetos are always signed, but public is not encrypted. So what's inside the Paceto payload? Just like a JWT here. You have the ID, email, permission, those regular claims. You can also have the sub, the AUD, the EXP, which is expiration, the default, those default NBF, not before, the issue that, the KID also, you can also use it here. So those are the default. In JWT also default key that you can find in, or you can use in Paceto payload. So here it is, the ISS, which is the user who created the token, EXP, the expiration, when does the token expire, and sample here again, the IAT IAT, the issued at, when was the token created. So that's the payload. And what about the optional footer? So some people wants to do key rotation, so they would want an encrypted part of local token. They get stored like a key identifier that references a specific public key or specific secret key. So here's some Paceto implementations. I got this, I think, last year. I'm not sure if this the case is. They're still on progress, some of the libraries here. So we have here the for Go, which from supported from version 1 to version 2 of the local and public. In .NET, the only not supported is the version 1 local, and there's also for Node.js, which from version 1 local to version 2 public are supported. In PHP also, everything supported, and Rust as well. So Swift, as you can see, you can now you use Paceto in any programming language and framework. So we have here JWT versus Paceto. Just a really quick here. So JSON Web Tokens has a lot of options, including often unauthenticated options. And Paceto, on the other hand, you have two options, version and purpose. Everything is authenticated. Local tokens are always encrypted. so that you don't accidentally leak sensitive information for a local system. And then he's the creator of Pacero. He mentioned some important things in Pacero, and here they are. Basically, you should have an opinionated interface. That's right, opinionated, because we're not, most of the time developers are not expert in security. That's not our forte. Usually do mobile and web application and web development, or sometimes desktop development, right? So yeah, you should have an opinionated interface. So we have a guidance, and then the encrypt here. This should be your API for any encryption library, and you have your message, your key, and an optional data to including the authentication tag. Decryption should be exactly the same. You should have hard-coded version protocols, which means that like Paceto, you have version 1 and version 2. And what else? Mentioned you don't have version 1 ECB mode and version 1 counter mode. You just have one version, and that's it. And always logically separate symmetric from asymmetric cryptography. Okay, a quick demo of Paceto here. We still have time. Show taskbar. So here's a Java code, and here's I'm using the Paceto library for Java. And basically, you have here sample of methods that you can use. You have create token, parse token, get claims, get audience, right? Parse token with read requirements. I'm just logging it here. And you also have these, the claims. Yeah, basically it. And then here's the result of it. We have here the parse token. We have the version 2 local, and then the payload here, all the way here. And the claims, you can see here, I'm just printing out the claims. AUD, allow, expiration here, and then audience, custom claim. Yeah. So this is just an example of Paceto. So for more information, you can go here to Scott Brady, 91.com, OpenID, and npm.js, Auth0.js for other resources. How to do some best practice in security. And yeah, so that's it. That's a quick introduction of Paceto. Just a replacement or alternative to JWT if you want to try, if you want to read. So yeah, I hope you learned something here. Thank you.
Thank you very much, Devlin. Thank you. Now you can meet your audience and continue the discussion in Q&A Zoom room. You have near 20 minutes for Q&A session. So follow, please, the link and meet your audience here. Thank you.
Okay.
Guys, thank you. If you enjoyed the Devlin's speech, Devlin's presentation, please go to our mobile application Devoxx and vote for his speech to help him win the prize. And now I'm ready to invite our next speaker. It will be Yegor Mayorov. Hi, Igor.
Hello.
How are you today?
Thank you. I'm fine. And you?
Not bad. It's the end of the conference. It's the second day. It's not bad, but a little bit tired. Have you enjoyed our speeches today?
Yeah. I just have listening to Devin, and it was very interesting speech. And also, I liked very much speech about deploying Spring Boot application with Spinnaker.
Okay, thank you. And what topic have you prepared for us?
Okay, I'm prepared topic about reactive data access in Java using R2DBC. I will share our experience of using this framework in production.
Thank you. So, okay, it's your time to shine on Devoxx Ukraine 2020. Good luck.
Thank you. Hello, everyone. Welcome to Building Reactive Application with R2DBC. Today, I'm going to tell you about reactive data access with SQL databases in Java and our experience of using R2DBC in production. But first, let me tell you a few words about myself. My name is Igor Mayorov, and I'm working as a software engineer at Infra Department for Playtika. Most of my career, I was building different enterprise systems using Java, and currently I'm working on building high-load services using Spring Cloud Stack and Java. Also, I'm curious about reactive programming and its application to building modern enterprise systems. Here's our agenda for today. We will first look at R2DBC specification, its types and design principles, and then we will switch our attention to Spring Data R2DBC, and we will look at some examples of using Spring Data R2DBC, and also we will try to understand how Spring Data can make our life easier as developers. And finally, we will look at some features which will be cool to have in Spring Data. Before I start, I want to give you a little background about where this talk is coming from. As I told you earlier, I'm working for Playtika, and Playtika, first and foremost, is a gaming company, and we develop games of all genres. From time to time, Playtika acquires some games and gives them a boost by integrating those games with Playtika's core services and infrastructure. However, this talk is not about game development. It is about infrastructural and core services we have around all the games. We at Infra are mostly working on these core services, and many of our core services are working under high load. And in order to handle this load and better utilize hardware, we are introducing a reactive approach to some of them. I want to give you a little background about how we come to Spring Data R2DBC usage. This is a simplified view of architecture we had initially. Here we have a client which sends request to an API gateway. API gateway forwards this request to Service A. Service A uses preloaded configuration from a database in order to handle this request and send response to a client. Also here we have Service B, and Service B is responsible for manipulating of configuration via Service A API, and then this configuration is stored in the database. And we had a problem with this architecture. We noticed then when we have a huge load from a client side, and at the same very moment, Service B starts to manipulate configuration, the latency of client request handling starts to grow, and this is something unacceptable for us. So we decided to fix this issue, and in order to fix this, we decided to move configuration. We decided to move code responsible for configuration management into separate service. And here you can see Service C. This is new service, and Service B is manipulating configuration in service via Service C. Service C stores this configuration in the database, and also there is additional API on the Service C, which is used by Service A in order to pull for configuration changes. But we have one question: how to implement data access layer in Service C? And approximately in the same time, Spring Data R2DBC was released, and I am as a fan of reactive programming, I was really interested in trying Spring Data R2DBC. Luckily, in Playtika and especially in Infra department, we have possibility to use new technologies, And I decided to leverage this possibility and implement data access layer in new service using Spring Data R2DBC. If you have experience working with or implementing reactive services that interacts with relational database, then you might know that it is quite painful experience, mostly because JDBC API is a blocking, and the implementation of JDBC API uses blocking IO, and blocking in reactive world is not allowed, especially in computational threads. So people start to use separate thread pool for scheduling database related work on this thread pool. And this approach works somehow. However, it is not truly reactive. And it limits scalability of your service anyway. And engineers from Pivotal recognized this problem, and they decided to go ahead and create standard API for reactive programming with SQL databases on the JVM. And this API is included in R2DBC specification. R2DBC specification starts from SPI, and SPI is a synonym for an API. SPI is intended to be implemented by different driver vendors from one side, and from other side, SPI is a foundation for building humane client, which is supposed to be used by developers like me and you. Here are databases which already have R2DBC driver. First one is Postgre. Postgre received a driver from a Spring team. And recently MariaDB announced about their R2DBC driver. Microsoft SQL Server and H2 also supported, and there is a driver for MySQL database. And the driver for MySQL is not like official one, but it is very, very, very good. We used it with MariaDB for quite a long time, and it worked perfect for us. And CockroachDB also supported, because it shares the same via protocol with Postgre database. And you can use Postgre driver with CockroachDB. There are several principles on which R2DBC specification is built. First and foremost is to utilize reactive streams, types, and patterns in API defined inside specification. Second one is to be completely non-blocking up to a database. Third one is that specification should be as comfortable as possible for implementers. And this is because in our daily work, for example, with JDBC, we almost never use JDBC directly. We are using some wrappers around JDBC, like JDBC template or even Hibernate, etc. And for this reason, authors of R2DBC decided to shrink its API to absolutely minimal operations, set of operations required in order to make this SPI comfortable for implementers. And clients should not use SPI directly. They should use some clients which are built on top of SPI. And the fourth design principle says that SPI should enable multiple Fluent API implementations on top of it. And the last but not least is that R2DBC specification, it is not just a bunch of interfaces and methods inside them. It also includes a detailed description of every interface and every operation. Here are main interfaces of R2DBC SPI. In some sense, they are similar to the ones we have in JDBC. The first one is Connection Factory. Connection Factory is the same as data source in JDBC, and its main purpose is to get connection, to provide connection. The next one is Statement. Statement is similar to Statement in JDBC. However, in JDBC, we have like three interfaces for modeling a statement. First one is a statement, then callable statement, and then prepared statement. Authors of R2DBC decided that there is not really important what you're calling. It is enough to have one interface statement, and you can just, if you have a parameterized query, you just create statement from a connection and then bind your parameters and call execute. If you have unparameterized query, then you just create statement and call execute. That's it. And the next one is connection. Connection is the same thing we have in JDBC. And the next one is result. Result is similar to result set in JDBC. Row is interface which represents just a single database row. and raw metadata is the same as result set metadata. And finally, batch is a special interface for executing batch requests in batch. Well, if you try to implement something using bare SPI, you will quickly understand that it is not very convenient, mostly because you need to manage a lot of technical details by hand. For example, you need to manage opening and closing connection, you need to manage transactions and so on. And in order to do this with R2DBC, you need to have really good understanding of Project Reactor and know very good some advanced operators of it. And the worst thing here is that you might end up in a situation where you mix technical code with your business code, and this may make understanding of your business code a little bit harder. Spring Data R2DBC is a humane client which is built on top of SPI. It has really fluent API, and also it encapsulates a lot of technical details and helps you to focus on your business code. Let's look at what Spring Data R2DBC can provide us. The first thing it provides is a database client class. This class wraps connection factory and encapsulates all resource handling logic inside. Such resource handling logic as opening connection and closing connection. Also, it provides much more fluent API than we have on API of R2DBC specification, and all Spring Data is based on Project Reactor. Let's look at simple query example using database client. We have here a select query, and there are several possibilities to execute this query. The first one is using domain-specific language on database client. We first call select method on the database client, then we call from method, and inside from method as a parameter, we need to pass table name somehow. So the first option is to pass table name as a just plain string, and the other option is to pass your entity type, and then Spring Data will try to derive table name from your entity. The first possibility is to use table annotation on your entity class, and if there is no table annotation, then Spring Data will try to derive table name by convention from a class name. Also, a cool thing about database client is that you can plug into database client DSL some criteria. This is criteria from Spring Data relational module, and you can just call machine method on database client DSL and pass in this constructed previously criteria, and this is where close for your select. And the next method we have here is a fetch, and fetch is part of database client DSL. It returns fetch specification, and you can say how many entries do you want to receive from database. In my case, I told that I want to receive all entries. The other possibility to execute select statement is to just call execute method on the database client, and inside this execute method provide your query as a string. And after that, you need, if you want to receive type result, you need just to call as method and provide target type which you want to receive. And all other operations like insert, update, delete can be done with database client in a similar order, in a similar way. And for example, in case of insert, you might need to bind some parameters to a query, and there are special syntax in database client for this. Method is called bind. You might have a question after looking at those examples. How can Spring Data know how to convert a row to your entity and vice versa? And there are several possible answers here. The first one is that you may provide custom author, for example, read converter to a Spring Data configuration, and this converter should implement converter interface from a Spring framework, and it should accept as a parameter into its single convert method row and return your target entity. And inside this method, you obviously provide logic which should implement this conversion. The same story is for insert and update queries. You can provide your custom write converter, which will convert, in this case, author or your any target entity into outbound row. Outbound row is a map-like structure It's a class from a Spring framework, and it contains as a keys column names and as a values settable value, which wraps your actual value. If you do not provide write converter or read converter, then Spring Data will do it best and will try to convert to derive column names from your entity fields. The first possibility for Spring Data is to use column annotation on a field, and it will take a column name from this annotation. If there is no column annotation, then Spring Data will try to convert field names to column names just by convention. Also, Spring Data provides R2DBC entity template class. This class is built on a database client, and it provides very entity-oriented methods and really fluent interface for executing different CRUD operations. Also, it enriches database client API with two additional methods. They are count and contains. Here is an example of R2DBC template in action. I want to perform here select query, and in order to do this, I need to execute only a single method, select, and optionally I can pass a query here if I want to, and a target type, which I want to receive as a result. Query is a special type inside Spring Data relational module, and query can include criteria, can include limit, offset, and sorting rules for your selection. That's it. Also, there are similar operations on R2DBC entity template for insert, update, and delete. And it is very, very comfortable to use class. I would recommend it to use if you can. If you don't need to execute some very complicated queries. For complicated queries, please use database client. And of course, the most convenient way of using Spring Data to DBC is defining your custom repository by extending reactive CRUD repository. And you receive a lot of very useful methods from reactive CRUD repository. Yes, but also you can define your own. In order to do this, you, as usual with Spring Data, define just a method and in an interface, and then you can annotate this method with query annotation and specify exact query you want Spring Data to execute inside this annotation. If you have parameterized query, then you need to bind some method argument to a parameter inside this query by using param annotation with a parameter name. The other possibility here is to just specify method without query annotation, and in this case, Spring Data will just derive query from method name. Exact rules about this you can find in Spring Data documentation. There are a lot of rules regarding this. Here are methods which we receive when we inherit reactive CRUD repository. We have here methods for inserting, save and save all. We have here methods for retrieving find by ID and find all. Also, we have three methods with different parameters for deleting. And if you want to sort results somehow and provide sorting order for your results, you can also extend reactive sorting repository. It has one additional method to all we see in reactive CRUD repository. This method is called findAll, and it accepts a special parameter sort. You might have a question here, where are methods for update? And there is no special methods for update. If you want to perform update, you need to use save and save all also. And you might be interested here, how can Spring Data understand whether it should perform update or insert operation when you call save? And there are several strategies to understand this. I will talk here only about default one. By default, Spring Data looks at ID at field which is annotated with ID annotation. And it looks if field has already populated with some value, non-default, then it will execute update and such entity is considered non-new. And if this field is populated with default value, then such entity is considered new and insert will be executed. Other strategies are described in very good details in Spring Data documentation. At this point, you might think that Spring Data to DBC features looks really cool, and that is true. But what about transactions? And this is really good question, because we have like transactions in imperative world, and this implementations works really good. Mostly because there is one thread in which you handle your request, and you do not change your thread during request handling. And those transaction managers use thread local variable in order to store some information about transaction. And this is not going to work in reactive world, mostly because you have possibility to change threads very often if you need so, and it is totally okay and even encouraged in some situations. So we need a little bit different approach here. And approach is actually was found. Transaction management is built on top of subscriber context feature of Project Reactor. This is a special feature of Project Reactor. Subscriber context is actually a map-like structure where you could put different values by key and then retrieve values by key. And this subscriber context is can be accessed by any operator of Project Reactor in reactive pipeline. So it makes it very comfortable to first store some information about transaction in this subscriber context, and then retrieve it and update it using at appropriate place. And on a code level, in order to support reactive transaction management, reactive transaction manager interface was created, and this interface provides reactive API. And there is a single implementation for now of this interface. It's called R2DBC Transaction Manager. Also, there is a support for declarative transaction management via transactional notation and programmatic transaction management via transactional operator. Let's look at declarative transaction management in Spring Data RTDBC. Here I want to say author and all related books in one transaction. In order to do this, I need, first of all, annotate my method with a transactional annotation. And the second condition, I need to return reactive type from a method. In this case, mono, but it can be Flux, for example, or some other publisher even, yes. And that's it. And I got a transactional behavior in this code snippet. And similar thing we have for programmatic transaction management. The only difference is that in order to manage transactions programmatically, we need to have transactional operator class instantiated. It is created by using create factory method, and this create method accepts transaction manager, reactive transaction manager. And here we have similar scenario. I want to say author with all its related books in one transaction. In order to do this, I need to make all this pipeline transactional. This is actually what Spring Data to DBC does under the hood when you mark some method as transactional. Okay. Yes, I hear you. Yeah, I'm finishing. Okay, finishing. Okay, you just create transaction by just executing transform deferred, and then you call transactional on this transactional operator, and that's it. From this point, you have transactional pipeline. There are several features which will be cool to have in Spring Data. First one, composite ID is not supported. The problem here is that you cannot use reactive CRUD repository, database client, or R2DBC entity template with entity that has composite ID. And in order to handle such case, you need to just implement it by hand. You need to define your query as a string and then bind parameters by hand. Other problem with Spring Data R2DBC is that it doesn't support batch operations. And batch operations supported on SPI level, but not on Spring Data R2DBC level. In order to do this, in order to do batch execution, you need to get some connection somehow from connection factory, or use this hack. I figure it out and get connection from a database client. And the other problem is one-to-many relations modeling. This is one like expected, because you don't have ORM. String data R2DBC is not ORM. It's just I would say table to entity mapping tool. And in this case, you need also to do everything by hand. And in this case, you need to first just retrieve all authors and collect them, then execute another query against database and retrieve all books for this author. And then when you get all books, you can finally create entity which has all information about author and information about books. And in the end, just a few words about connection pooling. There is a special R2DBC pool project which provides a non-blocking reactive connection pool. It's based on Project Reactor pool, which is a general purpose pool, also reactive and non-blocking. And I can say that we use this R2DBC pool in production and it works perfectly for us. It has really rich configuration, similar to the one we used to in GDBC-based pools. And that's it. Thank you for your attention.
Thank you very much, Igor. Thank you. Now you have a Q&A session in Zoom, so please follow to continue the communication with your audience. Thank you very much.
Thank you. Bye.
And for you guys, I want to remind, don't hesitate to visit our mobile application to vote for the best speaker and best presentation of Devoxx Ukraine 2020. Next one, in a few minutes, you'll watch the presentation from our partner. It will be DNS Simple. And now I want to say thank you very much for these 2 days in the third stream. It's my last live, so next you'll see speeches from first stream, keynote speakers. And thank you for these 2 days. It was a pleasure to be with you. Bye-bye.
Your domain is the backbone of your business. You need a stable, secure, and reliable DNS provider to protect your investment and ensure your customers can always stay connected to you. But being stuck in a room with a hungry mosquito is way more appealing than navigating the world of DNS management, until now. DN Simple has solved the problem of needlessly overcomplicated DNS management with automated tools that most people have never even dreamed of using. Want to register a new domain? Enter your information once and you're done. How about selling domains from your app? Integrate your sites with our API to instantly provide more value for your customers. Set up the DNS records needed to connect to services like Heroku, Shopify, and G Suite with one click. And use our automated SSL certificate generation to easily secure all of your websites. It's so user-friendly, everyone from grandma to this super genius can connect their domains to the services they use without ever thinking about DNS. Simple, secure domain management is right here at DN Simple. Try us free for 30 days.
Thank you, DN Simple Company, for supporting Devoxx Ukraine this year. And we want to invite to the presentation our next gold partner, Luxoft Company.
The future of business depends on the transformation of yesterday's legacies. Luxoft meets the challenges of today by developing the solutions of tomorrow. Because innovation lies in our core, it allows us to reinvent and not just respond. Domain integrity, coupled with ability to scale, is how we define our purpose. Think about tomorrow's autonomous driving landscape. Digital companions that always steer you in the right direction. We will empower the mobility revolution to put stunning user experiences on the road. Imagine the patients of the future, connected to 24/7 health monitoring systems and treated by algorithms that can predict and even prevent diseases. We can help our clients to improve patients' experiences and drive them into the digital era. Our perception of money might not change in the future, but everything else will. Luxoft helps integrate businesses with advanced technologies that deliver an unparalleled experience. Using our blockchain expertise, we help to remove data silos and improve trust. We are taking full advantage of the growing symbiosis between human and AI talents. With self-learning machines and robots on our side, we will be able to shape the world of tomorrow. With our client-centric approach, Luxoft quickly connects the dots to identify a perfect solution, from development to delivery. We offer technology hope. We embrace customer fear, and we drive the experience of tomorrow. And because we live and breathe technology, we see what others have missed.
Hello, Devoxx community. Even though I cannot see you, I can feel you, that you are there behind the screen, and it's a great pleasure to know that you're today gathered at this conference. My name is Lesia Manzevich. I'm an employer branding manager at Luxoft Ukraine, and it's a great pleasure for us to support Devoxx throughout the years, especially this year. It makes us even more proud that this year, in times when we are all threatened and many events are canceled, Devoxx managed to turn from the biggest Java-related Ukrainian event into truly global happening. Way to go, guys. This is beyond amazing. Java is actually one of the most popular technologies in the world, and hundreds of thousands of solutions are being built daily utilizing this technology. At Luxoft, we honor it and use it in many projects as well. If you enter our website and go through it, you will see many vacancies and events dedicated to Java. Please feel free to study more and join us at any event or join our team at any time. When we participate in conferences, we at Luxoft always strive to make new friends and to get to know people. This year, for obvious reasons, we are forced to do it digitally, but nonetheless, we really want to establish that contact with you. So please feel free to join our Telegram channel and to take part in our friendly giveaway, to test your knowledge in Java, and not only in Java, through our Galactic IT quiz. You can find the links in the partnership section of your screen, of your today's screen. We have a lot of presents for you at Devoxx. These are gift certificates, chargers, backpacks, and even a bike. So as the Devoxx is a 2-day conference, we will announce our winners tomorrow. That means you have still plenty of time to join and to become a winner at our giveaways and Galactic IT quiz. That's probably, I will wrap up my presentation, but the last but not the least, I would like to mention that Luxoft unites over 3,500 people in Ukraine and over 12,000 people globally. We strive to make difference and to bring excellence to our customers. And we think that it's a great cause. That's why we always encourage people to join our team and actually to make a world a better place somehow. So please don't hesitate, join, participate, take part in the quiz. And at Devoxx, learn, become smarter, and have fun. Enjoy. It was a pleasure meeting you.
Okay, dear participants, we continue Devoxx Ukraine. We have just 2 talks left. And now I would like to invite to our virtual stage Bruno Souza, Java evangelist, founder of the largest Java community in Brazil, SuJava. So he will connect from South America today. Bruno, welcome. Hello, Bruno.
Hey! Hello, everyone.
Hello.
Can you guys hear me well?
Yeah, we do. We hear you well, see you well. So how are you today?
So good to see you. Oh, we're doing fine, doing fine. Great day today. Awesome to be here on Devoxx Ukraine. You know, thanks everyone for organizing this awesome event. You know, I've been to Ukraine. I think when I went there was it still called the Java Day in Ukraine? I think it was, right? But you know, I'd love to be here with you. I wish I could be there, right, in Ukraine,
We
doing
wish
this
there
because
too.
it's such an awesome experience to be there with you. So thank you everyone for inviting me again to be here.
Yeah, thank you so much for supporting our event and giving a talk and participating in the round table. So I will not steal more time from your presentation. So the mic is yours. Please start.
Okay. All right. Awesome. So let's get going with this. So let me just kind of adjust this thing here. All right. So basically, you know, we're talking here about you know, learning faster, right? So let me show this here for you, right? So that's the idea. A lot of people want to learn faster, right? So that's what we want. We want to learn faster, right? To be better, right? To be a better developer, right? So that's kind of the idea. When I learn faster to be a better developer. But the reason why we want to do this is because we're going to get more results, right? And I think that it's really, really important that we have to think about what results all about, right? And the one thing I want to show you guys here is that really, for you to learn faster, for you to be a better developer, better professional, and for you to get more results, it's all about the skills, right? So that is the topic that we're going to talk about today. So we're going to talk about those 4 things here. And one thing that I want you to think about is that we, right, developers, technical people, we tend to be, Java developers in particular, right, to be aficionados, right? Maybe about learning, right? We want to learn everything. We're going to learn new technologies. We're going to learn new frameworks. We're going to learn new languages. We're going to learn, all the new version of Java, right? We're going to learn. So that's why when we talk about learn faster, right? So we're going to talk about learning faster. Oh man, so I can learn faster. And then if I can learn faster, that's awesome because I can learn more things, right? But at the same time, we do understand that learning is not the objective, right? Think about it. How many times have you bought a book, right? Or how many times have you bought a training online, right? And you never even opened the book, you never even read it, or you never accessed the training that you bought, right? We fictional about learning, but we understand that just learning is not enough, right? Another thing, how many of you put, all the books you read on your resume? Right, that's not what you put in your resume. You don't put what you read. You don't put your train. Maybe one or another, but usually you don't put all your trains that you took. You don't put all the videos that you watched on your curriculum, right? What is it you do? You usually put your experience, right? It's not about learning. It's about your experience, right? And so the one thing that I want to discuss here is actually, experience. Doing things, right, is the only way for us to get skills. And I think this is really, really important because we tend to forget that, right? We know that the most important thing is not learning, is experience. But we kind of mix things up by thinking that, the more I learn, the more experience I have. And that is not true, right? It's not about learning. It's about creating the right skills, right? And so because skills is so important, we understand, how do we acquire skills, right? What is the real way to acquire skills? And so let me just kind of see here, because one thing that I really would love to do is, if you're watching here, really would love to do to see, if you have any questions, right? So I want to make this very, very interactive. So, I'm just going to go to the chat here. So if you're watching me here, I can see the chat at the I think we are on track 1, right? So I'm at the chat on track 1. So if you can go and ask questions there, so we can make this very, very interactive. It's not about what I have to say. It's about what is your challenge that you're facing right now that I can help you out, right? And I see there's a couple of questions here from Luca, for example, and Jkeds, right? Okay, so we're gonna go over these questions in a minute. That's awesome. I'm loving this. All right, so basically, and feel free, to ask as many questions as you want there. Okay, so basically, it's all about experience, right? So, and that's one very important thing. It's not about learning; it's about experience. So, it's skills. You only acquire skills by doing. So we have to understand what are skills and how do they work, because a lot of times we kind of confuse what skills are. So let's think about skills for a minute, right? I want to say one thing that lots of people don't think. When we think about skills, we understand, like, for example, if I want to be a soccer player, for example, or I want to be a basketball player, or if I want to be a skateboarder, right? There's a lot of physical skills. We understand that, right? Now I have to have my muscles. I have to, prepare my body so I can actually go and do those things. So there are physical skills, and we think, okay, so those are physical skills, but programming, software development is an intellectual skill. So it's not physical, it's intellectual. But we forget that even the intellectual skills, they are biological. Okay, they are physical in a way because they're biological. The connections in our brains, they're physical connections, right? The cells in our brains, they're physical. I mean, they're like muscles. They're different types of cells, but they go by the same rules of biology. So that's very important for us to understand, because we have to understand that learning is not the objective. The objective is doing. So let's think about how biology works and how biology has to do with skills, right? So, you have in your brain lots of neuron cells, right? You guys know this very well, right? So those are cells like this. You've seen this in your biology studies when you were in high school, for example, right? And if you remember, right, so the neurons, the connections between the neurons are the things that actually makes you a developer, right? It's very cool, right? So how do we actually create those connections? The same way that you have to practice to get muscles, you have to practice to have neurons, right? Software development neurons, Java neurons, right? So how do we create our Java neurons? One thing I want you to understand is that, in this cell here, there's this little thing here that you might have, that you might recall from the drawings when you're a kid, right? Or maybe you've seen this lately or something, right? So this here is called the myelin shaft, right? So this is myelin. Myelin. Man, come on, what does this have to do with Java? You're gonna see in a minute. I understand. So let's just see in a minute. Myelin is this little it's an insulation barrier, right? So the more myelin you have in your neuron, the faster the electricity travels on the neuron, right? So the more myelin you have in your neuron, the faster energy travels in the neuron. What this has to do with skill? Because the faster electricity passes through your neuron, the faster you think, right? So I just want you to understand, and basically the way it works, right? If you cut this thing here and you see from, you get this thing and look from like this, what you're going to see is that you have the neuron here, the axon, this thing here, right here in the middle, and then you have, the myelin covers around it, right? So basically, when you become good at something, your body puts myelin around the neurons so your neurons can run faster, right? And so, and what does faster means, right? That's very, very important. What does faster means? Well, let me tell you what faster means. A neuron with lots of myelin around it can be 100 times faster than a neuron without myelin. 100 times faster. And not only that, it can activate. The time for it to activate is 30 times smaller. So it's 100 times faster, and it can activate again in 30 times, in 1/30th of the time. So you know what this means? Do you understand what 100 times faster? Think about the Java VM. If the Java VM is 100 times faster, right? What does this mean? 100 times faster means magic, right? It's magic. Remember how we call that amazing basketball player? We call him Magic Johnson. Why we call him a Magic Johnson? Because 100 times faster in the brain makes you way better than other people. So much better that other people look at you and say, "That's magic. How can this person do this?" Right? How can he be so fast? How he can do things like this? So that's what you need. So Christina is asking, project counts as experience. I'm going to talk about side projects in a minute, Christine. But but the thing is, if you can if side projects, Christina, can help your neurons be faster, then yes, they're going to help your skills. So let's think if they can, right? So what we want is that we want to make our neurons faster, right? I know this is a biology class, but let's think about it. I want you to understand, skills are myelin. Skills are not crazy things. They're not like ethereal things, like things that you don't understand. Intellectual skills are myelin in your brain. The more myelin you have, the better skill you have. That's simple like this, even for physical skills, right? Because for you to be able to, throw the ball in the right place in basketball or kick the ball in the right place in soccer, your brain has to be working. There's no such thing as muscle memory. The only memory you have is in your brain. So the neurons that goes from your brain to the tip of your foot, they have to have myelin in it for you to be able to do things in a physical thing. So skills are myelin, right? And why this is important? Because myelin is a biology thing, right? So let's think about it. If everything is biology, right? Let's think about how to do skills. Let me show you the rules of skill achievement. There are 4 rules. There are 4 rules of skill achievement, and they're all grounded in biology. Rule number 1, you have to activate. You have to activate. What does that mean? I can't get stronger. Let's say my muscle, right? I can't, do push-ups with this arm here and my other arm will going to be magically strong. That's not going to happen. The only muscles in my body that will get stronger are the ones that I activate. So if I want a muscle to get stronger, I have to activate the muscle. That's biology. You can't force in your brain like, muscle, get stronger. You can't do that. You have to activate the muscle for it to get stronger. It's the same thing with your brain. You can't get a neuron to be faster. You can't put myelin in a neuron. You can't inject myelin in your blood your blood current and then you magically get better. No. You have to activate the right neurons for you to get better. So if you don't activate a neuron, you don't get better. So that's why, Christina, we have to do things, right? If we do things, then we activate the right neurons. So that's the biggest misconception we have. If we learn, if we read something in the book, let's say I get a book to read something, just to learn. If I read something in the book, am I activating the neurons? Let's say I read something about Java in a book, right? So I'm reading, Java bytecode, right, in a book. So which neurons are being activated? The neurons of doing, of working with Java bytecodes, or the neurons of learning about Java bytecodes? So it's just the neurons of learning, right? So it's not the neurons of, it's just the neurons of reading. They're being activated because those are the ones I'm exercising, right? So if I really want to get a skill, I need to activate the doing neurons, let's say, right? So that's why, of course, some learning is important, right? But for us to get skills, we have to activate the right neurons. So we have to do things, right? And so if you don't activate the neurons, there's no myelin, you don't get better. Okay, so that's the first rule. The second rule of skill achievement, right? You have to force it. Okay, what do I mean by force? Let's think about muscles again, right? Let's say I have this 1 kilo heavy thing here, right? And I want to get muscles in my arm. So I'm going to do like 10 push-ups with this, right? So if I do 10 push-ups with this, and that's good, right? My muscles are going to get better, right? So tomorrow I do 10 push-ups again with 1 kilo. And then after tomorrow, I do 10 push-ups again with 1 kilo. A month from now, 10 push-ups again with 1 kilo. A year from now, 10 push-ups again with 1 kilo. Is my muscle getting better? Is my muscle getting stronger? No, it is not. Why? Because after a week, I'm strong enough to do 10 push-ups with 1 kilo. And then my body doesn't need to improve my muscles anymore. That's the same thing for your neurons. If you don't force your neurons, your brain's not going to put more myelin in it. Your brain only puts myelin on the neurons that are being forced. No force in the neurons, no myelin. So how do you know how to force a neuron? Well, how do you know how to force a brain? You do it more than you are able to do. You do until it hurts, right? But more than that. It's very important. You do until it hurts, but not more than that, because you don't want to destroy your muscle, right? So you do it a little bit more. Same thing with your neurons. You have to force it, but how much you have to force it? Look, lots of people say, oh, you have to work outside of your comfort zone. Very problematic this, right? Why? Here's your comfort zone, right? Working outside of your comfort zone, it's outside. Right? And then, when you work outside of your comfort zone, you make a lot of mistakes, right? So if you make too many mistakes, like it's destroying your brain, if you make too many mistakes, that's forcing too much, right? So for us, we want to work on the edge of our comfort zone, right? This is the comfort zone, right? We want to work on the edge of our comfort zone. How do we know we're working on the edge of our comfort zone? We are making mistakes. Mistakes, right? If we're making mistakes, we are working on the edge of our comfort zone. Now, if we have no idea what we're doing, if we're getting everything wrong, we are completely outside of the comfort zone, and that's actually prejudicial, right? So like pushing your muscle too far. But if you want to improve, you have to work a little on the edge of your comfort zone. You have to make mistakes. If everything you're doing is always right, you never make mistakes, then you're in comfort zone, right? So you have to make mistakes, a little bit of mistakes, but not completely wrong, okay? So that's the idea. So basically, that's forcing. It's working on the edge of our comfort zone. Make sense? So if you don't force, your body is not going to put myelin around your neurons, and then you're not going to get better. So you have to activate the neurons, but activate them stronger than the easy part. You have to have difficulty of doing it. If you don't have difficulty of doing, then you're not improving. All right. Now the third lesson about the third lesson, or the third the third rule, right? Those are rules. The third rule about skill acquisition, right? It has to be frequent. Okay? Right? You have to do it continuously. Right? So actually continuous could be a better word. We have to do continuously. Continuously. Right? You have to do continuously. What do I mean by doing continuously? Look, let's go back to our muscle again, right? We go to our muscles and we say, okay, I don't have time to do 1 hour of exercise every day. So what I'm going to do is I'm going to wait to the end of the month, and once a month I'm going to go to the gym and I'm going to do 30 hours of exercise at once a month. Will that work? No, it will not work. It will destroy your body, right? And you're not going to have time to increase muscles, right? You're going to have your body completely destroyed, and you're not going to have time to increase your muscles at all. So it doesn't help to just kind of bundle together and do a lot and stop doing, right? You got to keep doing every day, a little bit every day. 5 minutes a day, 15 minutes a day is better than several hours on the weekend, right? 5 minutes a day, 15 minutes a day is better than several hours on the weekend. That's very, very important. So you have to do continuously every single day, right? Every single day. So is this a coding equivalent of do something every day that scares you? Yes, Alan, that's right. Exactly. So activate, right? Something every day, frequently, right? That scares you. That's a little bit stronger, right? You're totally right. I love this phrase, Alan. Okay. So the fourth rule of, you got to do it frequently, right? So you got to activate the right neurons stronger every day for you to get the skills. Now, the fourth rule, I just want to tell you this. The fourth rule is a sub-item of rule number 3, right? So let me just do this. It's not four rules. It's actually 3 rules, but a 3.1 here, right? A 3.1 rule is if you stop, you lose it. All right? You know this very well. If you do exercise and you stop exercise your muscles, and you spend like a month not doing any exercise, or 2 months not doing any exercise, your muscles all go away, right? All the effort disappears. Same thing for your brain, right? If you stop activating your neurons, things go away. Really, there's a famous musician that would just say, if I stop practicing 1 day, I notice. If I stop practicing for 2 days, my wife noticed. If I stop practicing for 3 days, the world notice, right? So if you stop, you lose it. So those are the 4 rules of skill acquisition. Any skill, right? You have to apply this. So let's answer some questions here, right? So Christina says mind blowing. So thanks a lot, Christina. Awesome. So think about those 4 rules to acquire skills. It's not about learning. It's about skills. So now let's answer some questions here. So Christina asked, do side projects count as experience, right? Do they help us get skills? So if you do a side project, does it activate your neurons of doing? Yes, it does. Does it forces you? It depends on the project. If you're doing a very easy project, then it doesn't help. Okay, but it's doing a project that's hard, right? Yes, it does forces you. Do you run your side projects for 15 minutes, for 1 hour, for 5 minutes every single day? Christina, if you do this every single day, yes, it helps you, right? So yes, and of course, if you're doing a project, you're not stopping training, right? So basically, yeah, so the 3 rules, remember, those are the 3 rules of skill acquisition, right? So if your project helps you to do that, Christina, yes, it solves you, right? Let me see here. What else? What other question I can answer right now? You know, mean by learning back end, by trying, practice things that you learn it might help you get the direction skills, isn't it? Yes, exactly. Right. If you apply, if you try to look, let me tell you one thing. Let me tell you a story here. Right. My friend Oleg, that's here, organized this event. Right. Oleg gave me a gift. Right. For me, I'm part of the event, so he sent me a gift. He sent me a new video game. Right. For me to play on the PlayStation or Nintendo. I don't even know which one I'm going to play on. But he sent me a new game. So right after this talk here, I'm going to go, I'm very excited about this new game. It looks like an awesome game. I'm very, very excited. So what I'm going to do, right after I finish this talk here, I'm going to go and I'm going to read the manual. Right? Is that what I'm going to do? I'm going to read the manual? No way, right? No one's going to read the manual. What I'm going to do, I'm going to go play the game. Look, that's the same thing if you want to do back end, or you want to do anything about Java, or you want to do anything, cloud computing, or anything you want to do. It's not about reading the manual. It's about going and doing, it's experimenting. So that's what I'm going to do. I'm going to play the game, right? So that's what you should do. Of course, if I go play the game and I have no idea how to play the game, I have to learn a little bit. Well, what are the commands, right? And then I can start. Same thing for everything else, right? You have to learn a little bit, enough for you to get started. Once you get started, then you can learn more, because now you're doing something, and now you're activating your neurons. Now you're forcing yourself to try to solve the problems. You're making mistakes, right? Because you're trying to learn. So that's what Teresa asked here. I agree with the continuous improvement. However, it takes some time to get into a topic. How can you focus on some problem for just 5 minutes? Do you have, okay, all right, so Teresa, so let's talk about the 5 minutes in a minute. But very important, right? Of course, it takes some time for you to get into a topic, right? It takes some time for you to learn something enough, but it's just a little bit of time, right? A lot of people, they want to read the whole book, right? Or they want to learn everything about Java, or they want to learn everything about containers to start doing anything. No. You start doing first. And then you figure out what is the next step. You do enough to figure out the next step. All right? We do enough to figure out the next step. Teresa, I'm going to leave the 5 minutes here for a minute, all right? Because I want to talk about other things first before I come back to the 5 minutes part. All right? So let me go answer some more questions here. That's all I want, right? I want to answer as many questions as I want. As you want to ask me. So people who start coding late in their age, over 40, right? They're late for programming. No, Luca, that's a good question. No, why? Because even if you're over 40, you can still grow neurons. That's an awesome thing. Your brain is very plastic, right? And so you can grow myelin. Myelin grows in your brain until you die. Right? Until you die, you're still growing myelin in your brain. So you can put myelin in the right neurons. Doesn't matter what age you are. So yes, Luca, it's totally okay to start after 40, right? That's not a problem. Jakey says, I started programming when I was 31, right? So that's awesome. Fully qualified lawyer and did this. So that's awesome. Congratulations, Jackie. So yes, I totally agree with this. I started at 44. Your brain's hungry for new experience. Go for it. Exactly. Because your myelin, look, we learn it in school, right? That the neurons don't grow. If you lose a neuron, there's not going to be a new neuron in place. And that is true. After a certain age, your brain doesn't create new neurons, but your brain creates new connections and myelin, right? So you can use the neurons that you have. They're already there, right, to create more myelin and create new connections to start programming. So that's totally fine. You can do after 40, no problem at all. Let me see here. Can we consider learning to be a stage to get skills? Let's say read some Java books and start to do things from until you forget it. Okay, so no. Very careful, Vitality. So yes, learning is a stage to get skills. Yes, you're right. But then you go in your question and you say, let's read some Java books. No. Read one paragraph of one book and you start doing, right? You start doing as soon as you can. Do not read some Java books. It's not going to help you. Do not even read a full Java book, right? Read the first example and try. Start with the minimum thing you have. You start doing as soon as you can, Vitality. That's what's going to make a big difference, right? Find a mentor is the best way to improve your skills, in my opinion, right? Okay, I'm gonna talk about mentor later. Okay, mentor is a great way here too. I'm gonna save it here for later. Okay, so Vitality says, yeah, then you never stop the learning phase, right? So yeah, so don't do this. Don't ever, you gotta, the learning has to be mixed with the practice. You learn, mix it with the practice. Okay. Okay, so yes, so yeah, you okay, so don't we can talk more about how you can read websites a little faster if you want that, right? Okay, cool. So lots of smiles. So why do textbooks exist? All right, Alan, that's such an awesome question, Alan. Man, look, this is like a really awesome questions, Alan. So let me tell you, there is a curse of teaching, a curse of training that's very complicated, Alan. Look, think about it. For you to get skills, you have to activate the neurons, right? And you have to force it, right? But to force it, you have to make mistakes. And when you make mistakes, how does that work? It's frustrating, right? When you make mistakes, man, this is frustrating. And so if it is frustrating, you don't want to do it, right? You have to force yourself. Now, let's say you buy a book, Alan, and that book is, it's a frustrating book. You're reading the book and you try the examples and you make mistakes. It's frustrating. Or you go to a training at a school, for example, and you try things and you make mistakes. It's frustrating. So what happens? You complain about the book. You complain about the training. You say, that's a terrible training, right? It's frustrating to go through it. So what do trainings and books do? They do it in a way that's not frustrating, right? They do it in a way that you don't make mistakes. And if you don't make mistakes, you don't force your brain, right? And so you like the book. You say, oh, that's an awesome book. Oh, that's an awesome training because I was able to do everything. And then you go home and you have no skills. And then you have to go somewhere, right, to get these skills. You have to do a real project in your life, right, to get the real skills. Make sense? Right? So that gets completely crazy. So that's a paradox of teaching. You have to make it interesting enough for people, and by making it interesting and easy for them to learn, you're not forcing them, so you're not helping them get the skills. Isn't it crazy? Right? So that's completely crazy. And so it's good for you to know that. Once you understand that, what happens then it's better for you, because now you can choose how you learn, how you acquire your skills. Make sense? So most tech books come with company code to follow by doing. So the problem is most people just read. They don't actually do things, right? Most people just read, they don't actually do things. All right, so that is complicated. Okay? So that's very important that you go and do things. All right? So let me ask one thing. For me, it looks like there's a delay on the stream. Can you guys still hear me well and see me well? No problem. I'm just gonna continue here because for me it looks like the whole video is kind of slow motion here for me. All right. So bottom says how you don't forget what you learn it, right? If you're not working with it, so that's the biggest problem. Bodan, you gotta keep doing. You gotta keep insisting, right? You gotta keep working on it. If you stop working on it, you're gonna lose it. Rule 3.1. You stop, you lose it. So you can't stop. You have, okay, all cool. All right, thanks, Luca. Thanks, Christina. All right, so if you stop, you lose it, right? So don't stop, right? You got to be refreshing everything. All right, okay, awesome. So how do we refresh things, right? Okay, we're here loud and clear. Okay, I talk very loud, right? So maybe you have to turn down the volume a little. So basically, the way to do this is refresh your skills. So let me give a very simple example here. Very, very simple example. Most musicians, when they start practicing, right, what is that they do? The first thing they do in the practice, when they're going to play the piano, when they play guitar or play the piano, the first thing they do, they play a song that they're familiar with. A lot of them, they love this one they love, so they play that. When you play something that you're familiar with, what do? You activate the right neurons, right? You activate the neurons. You poof, your brain kind of flashes on the right neurons. And when your brain flashes on the right neurons, you activate them, right? And you activate them, you refresh the pathways. You refresh everything. So that's a good thing, right? So that's why we do code katas, for example. When you're going to start practicing, a easy way for you to do a little code kata. Refresh your brain. Refresh the fundamentals, right? That's why it's important for us to do code katas, right? Because then we refresh the for loops and refresh the language features, and we refresh the collections, right? Because then it flashes our brain. We activate the right neurons. Don't forget, right? So that's an awesome way to do that, right? So do you know learn in public? What do you think? Mainly is explain what you're learning to others while you're studying, even if you're a complete beginner. That's awesome, David. That's very, very good. Why? Why this is very good, David? Because when you explain look, when you're reading something, when you're just learning and reading something or watching a video or watching a class, right? You are activating the neurons of watching. You're activating the neurons of reading. You're activating the neurons, a little bit of the neurons of the learning too, right? Of the doing, a little bit, but not much. Now, when you teach one something, the only way for you to teach something is that if you know how to do it, right? So when you're teaching something to someone, you are actually doing. So you are indeed activating the neurons of doing. So yes, David, it's very important. So there's a phrase I love to say. You think that you think when you think, but the truth is you only think when you speak. You only think when you share. You only think when you only think when you try to explain to someone else what you're doing, because then it helps you activate the right neurons. So that's an awesome way, David, to do that. Yes, I totally agree. Even if you're a complete beginner, right? You can teach others, complete beginners, to do that thing, right? Okay, so last question I can see here. I'm going to talk about mentoring in a minute, Hugo. I just want to mention two more things before I talk about mention. And I'm also going to talk about motivation. All right, so Nadia and Hugo, let me just kind of quickly go here. One more thing. So I don't have a lot of time. I have about 10 more minutes. So one thing that I would love to do is I'd love to give everyone a book. Before I go, I want to give everyone a book. Why I want to give everyone a book? So so if people can put my book there on the screen, that would be awesome. Why do I want to give you a book? Because there's two things that are going to happen, right? If you download my book, you're going to get my contacts, right? So you can talk to me. If there's any question that I didn't answer here, you can send them to me and later on, and I can answer over email. But the other thing is that I'm giving you a book that has the 4 steps for you to take action. So people that are asking about motivation, for example, this book is really going to help you with motivation, because it's going to show you the 4 steps that you need to take action, right? 4 steps for you to do things. Okay, so that's an awesome book. And actually, I'm going to also put here on the chat why they put this on the screen. I'm also going to put here on the chat the link for it. And all right, so if you can go here on the chat, or you can see on the screen as soon as they put there in the screen, and then we're going to see then you're going to be able to see the book. Maybe they're not going to be able to put it on the screen because I forgot to send the images for them earlier on, so I'm not sure if they're going to be able to do that. But if not, it's on the chat, right? You're going to have my book right there for you guys to download, right? Let me know if the links works, right? So, okay, so now let me talk a little briefly about a few things here, right? So we're talking about, we're talking about learning, right? And skills. So now you understand how to get the right skills. You understand how to learn the right way, right? Now, think about being better. How can you be better? For you to be better, right? What you have to do is you have to apply your efforts on the right skills, on the most important skills. If you apply apply your efforts, if you activate the neurons for the most important skills, that's how you get better, right? Should we read the whole book? Just a path. That's awesome, Sergey. That's why my book has just one paragraph. Really, right? My book is not about reading. It's about asking questions. I ask a lot of, so my book is all about doing, right? My book is going to ask you lots of questions for you, right? For you to improve your career, right? So that's my book has very, very little. It's a very short book. It's going to take you less than 10 minutes to read it. It's a very short book, but if you start answering the questions, right, you can use that book for months to answer, to get everything going for you in your life, right? So it's a very, very short book, and you're totally right, Sergey. The whole idea is not to read the book; it's actually do the things the book tells you to do, right? So that's the idea right there. Awesome question. All right. So for you to be better, you gotta go after the right skills, right? The most important skills. So how do you know which one are the most important skills? Well, the most important skills are the ones that give you the results you want. Very, very important. You can't really acquire skills if you don't have a clear focus. What is that you want for your life? What is it you want for your career? What is it you want for your family? What is it you want in terms of money? If you don't know exactly what results you want to achieve, that's very, very hard for you to decide which are the most important skills for you to achieve those. Make sense? It's not about doing everything, guys. It's not about doing, learning everything. It's about deciding what are the most important results that you want. Once you know exactly what results you want, so, I want a better job. I want I want some better thing. So hey, Chris is already here. So hi, Chris. Awesome that you're here. So you're talking next. So you guys got to stay here because Chris Richardson is going to give the next talk, and his talk is totally amazing. So that's awesome. All right. So it's really, really important that you know exactly. And there's one thing. A lot of people are afraid of focus, right? A lot of people are afraid of focus. Why they are afraid of focus? For one thing, it's very scary, right? It's what we call FOMO. FOMO is the fear of missing out. The fear of missing out. So that fear, oh man, but if I focus in one thing, I'm going to miss out so many other things, right? So that's the fear of missing out. So instead of the fear of missing out, that's not what we're wanting. We want to have focus, right? Now, the most important thing, why people are afraid of having focus. They're afraid of having focus because they think that having focus is, oh, but Bruno, if I focus on Java, then I'm never going to learn Kotlin. And that's not focus. Java is a tool, right? So having focus in Java is like, you're asking someone to come fix your roof, and the guy says, oh yes, I'm gonna fix your roof because I'm an expert in hammers. You don't want to hire an expert in hammers to fix your roof. You want to hire an expert in roofs to fix your roof, right? So it's not about the tools, it's about the problem that you solve. So it's not about the tools, it's about the results you want. So you got to think about the results. All right? Okay, with that, I think that we never get I don't think we ever got the image for the book here on the stream, but at least you guys get in the chat, right? I can actually put the link here on the board here while I'm answering the last two questions, right? How about this? I'm just gonna put the link here. So it's jav.mn, JavaMan, right? That's me. jav.mn / all in small letters, right? All small letters / best year. Okay? Right. So if you come here, jav.mn, JavaMan, that's me, right? / best year, that's where you're going to get the book. So I'm going to leave the link here while I answer the last two questions here so we can get all the questions answered. I really need to fix my roof. Okay, awesome. All right. So let me ask questions here. Someone 5 minutes a day, right? 5 minutes a day. It's an awesome way for you to, 5 minutes a day is an awesome way for you to start doing anything, right? But Bruno, 5 minutes a day is not enough for me to do things. Yes, it is. 5 minutes a day, it's awesome for you to create a habit, right? The most important thing is you create a habit. Once you have the habit of doing your side project every day, once you have your habit of, of doing a code kata every day, once you have a habit of doing things every day, you're already, halfway there, right? Because the most hard thing is motivation, right? Motivation, that's what someone asked there. How can I have motivation? Motivation is not going to take you very far. Motivation is very, very energy consuming, right? So it's not about motivation. It's about doing every day. So doing 5 minutes a day helps you create the habit. Once you have a habit of doing something, then that's going to change your life by itself. All right? A great thing. Where can you find a coach? If you want to, you go send me a message and then we can talk about it, or come to the question and answer that we're going to have in 2 minutes, and then we can talk about where you can find a good mentor and coach. But let me tell you one thing, Hugo, in terms of mentor. Mentors are the best way for things. Why? Because mentor is going to force you. Mentor is going to challenge you. Mentor is going to help you barriers more, then you can faster achieve what you want. So that's an awesome way. And you can have mentors by reading a book. Let's say you're gonna, Chris Richards is gonna come here, right? You can say, okay, let me read Chris' books, and I'm gonna follow what Chris is saying. I'm gonna do what Chris is saying. So that's a way for you to have a mentor. Come here, ask questions on events, talk to people online. That's awesome, great ways to get mentors. A lot of interviews ask theoretical questions, also ask topics which do not exist and will exist in their projects I'm interviewed to. Should I learn certain topics just for an interview, or should just skip such companies? So Dimitri, let me tell you, you have to know enough about what's going on to understand the process, right? So that's important. It's important that you have a general understanding what's going on. But you, Dimitri, have to have a focus. So go after the companies that focus on the problems that you want to focus. So remember, focus is about the problem that you solve. Once you know what problem you solve, then you can go after companies that want that problem solving. That's how you go after the best companies. All right. So Yuri said, amazing speak. Thanks a lot, Yuri. The best speak for a long time. So if you like this speak, If you like the talk, go vote for it, right? So they invite me again so we can have more time together. So that's awesome. Okay, so go vote for it. A lot of positive energy, was awesome. Thanks a lot. Thanks, everyone. All right, so don't forget to vote on talk. That's all I'm talking about. Focus on something takes me 30 minutes to get concentrated. So let's talk more about this in the question and answer. I think that's going to be better. Download my Best Year, because that book is going to help you focus even faster than 30 minutes. All right, so that's by 40. That's the end of my talk. So thanks everyone. Thanks Oleg for the invitation. Thanks everyone for being here. And I'm going to go to the question and answers right after this. Thank you.
Thank you, Bruno. Thank you so much for this energetic talk. We are very excited here after your talk. And dear participants, the link to the book is published in the chat, and we will publish it once again now. So yeah, go download it and follow the Bruno's advices. Yeah, thank you so much, and please join the Q&A Zoom room and have more discussions and more questions to Bruno. Thank you.
Thanks,
Thank
everyone.
You so much.
It was awesome. Thanks for the opportunity, and thanks for running this awesome event that you guys are doing. Keep doing it. Thanks a lot.
Thank you. Thank you. See you next year. Yeah, dear participants, and in a minute we will have a presentation from our platinum partner, EPAM company. Yeah, hello. Hello, Yulia.
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right, to be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Yeah, I'm glad to welcome the representative from EPAM, Yulia Trisko, Associate Learning and Development Specialist at EPAM. Yulia, what presentation do you have for us today?
Hello everyone, my name is Julia and I'm the project coordinator of Master's Degree Program in Software Engineering at EPAM, and today I'm excited to present the educational opportunities we offer on Master's Degree Program. So this is a unique educational product for experienced IT professionals who would like to succeed in their careers. And the presentation will cover the key points about Master's Degree Program in Software Engineering, its advantages and the reason why we are the best in what we are doing, the skills and qualification you must have to start on the program, and the ways to apply to the program. So our Master's Degree Program in Software Engineering is designed for senior level engineers and includes 2 years of training. Our students have 2 options of participation in the program. You can study on the program independently or in a partnership with 2 major Ukrainian universities, Kyiv-Mogilyansky Academy and State University of Telecommunications. After completing the program, you will get a master's degree diploma of higher education. Master's degree program offers 120 learning credits, more than 400 face-to-face workshops, 80 hours of online webinars, 5 compulsory and 1 elective modules, more than 100 experts, mentors, speakers, coaches, among the most experienced IT professionals from all over the world. More than 15 years of EPAM's experience in education and 27 years in software development. The program includes the following modules: Engineering Excellence, Solution Architect, Core and Advanced, Delivery Management, Big Data, DevOps and Cloud. And now, I would like to move on to the advantages of the program. I would like to highlight the curriculum driven by business needs, combined online-offline activities, blended format which includes self-study and working shoulder to shoulder with the mentors and your colleagues on webinars and workshops. Integration with the best educational practices in the world, best lecturers from business and science. And for 2 years, our program has been providing trainings for IT specialists forming IT professional community which connects best engineers from all over the world. You have the opportunity to develop your professional network, which also affects your professional career. Your mentors are the practitioners who can advise you on your career and will share their expertise. The participants of the first year have already stepped up their professional careers and received offers from the world's leading companies. At the moment, our program has 2 streams of students, and now we are recruiting the 3rd class stream. Today, there are no similar programs to build a career in solution architecture and delivery management. And the most important skills you need to succeed are 3 years plus of experience in IT development, working with one of the programming languages, Java, JavaScript, .NET, and others, basic business toolkit, English level B2 plus, soft skills like leadership, efficient business, customer-focused communication. And now let's watch a short introduction video about our program.
We training tens of thousands of people per year, and this year we also decided to bring some of the program externally. We're running graduated master program for software engineering.
It is a great honor and big responsibility to be the first, and we are working 24/7 for the result.
The next start date of Master's Degree Program in Software Engineering is September 1st, 2021. Please send your applications now and you will be contacted right away by our representative. You'll be advised the next steps and get the answers to all your questions. The estimated deadline is May 1st, 2021. Here you see the QR code to the program page. Please scan the QR code and register. Also, you can find the link to the MSDP page on your participant account of the conference. Throughout the program, we have received thousands of applications, but only the best candidates who have been qualified according to their professional level got the opportunity to study. Don't miss your chance to change your future, get new opportunities, and improve your career. Get unique knowledge from top managers and experienced leaders. Hurry up and register and get your seat on the program. The link to our program is also in chat. So learn, grow, be excellent with Master's Degree Program in Software Engineering at EPAM. So thank you for your attention.
Thank you, Yulia, for this presentation. Thank you for this exciting master degree program. It's really cool and interesting for growing their future architectures and engineering elite, as your video says. So thank you once again to EPAM for such a program. And dear participants, just will remind you that you can find the link to application form to this master degree program at the personal page under the EPAM section. Yeah, and just in a few minutes, we will start our last keynote of the Devoxx Ukraine from Chris Richardson. So stay with us and enjoy the last talk at Devoxx Ukraine. Okay, dear participants, welcome back, and I'm glad to invite to our virtual stage the last keynote speaker, Java champion, Java 1 rock star, Chris Richardson, connecting from sunny California.
And yeah, so it's a beautiful sunny day, and they just announced the results of the election, so I'm super happy. So yeah,
Good
great to
morning.
be here.
Good
Hi.
morning, Chris. Yeah, sorry for interrupting. You can start your talk now, so please, the mic is yours.
Okay, great. Yeah, so yeah, welcome to my talk on architecting for rapid, frequent, reliable, and sustainable software delivery. So in the talk, I'm going to explain why that's important. I'm going to explain what it means. I'm also going to explain what it means for us as software architects. Do we architect differently? Then I'm going to talk about the role that microservices, or specifically the microservice architecture, plays, and why it makes sense to use it sometimes. So before I talk about that, a little bit about me. I've been developing software for a long time. First job was like back in the mid 80s, building Lisp systems. Then over the years, ended up in Java, wrote the book Pojos in Action, created the original Cloud Foundry, which then got acquired by SpringSource. That's where the name of the current Cloud Foundry comes from. And then for the past 7 years, I've been pretty much focused on the microservice architecture, working with organizations around the world through consulting and training, to help them adopt microservices. I wrote the book Microservices Patterns. I have a startup called Eventuate, and also doing training and so on online in the age of COVID. And yeah, if you want to get discounts to either my book or my online training classes, please use these coupons, and you can go to adoptmicroservices.io. So, that's me. I basically spend my time doing microservices. So talk agenda is as follows. I'm going to begin by dissecting the phrase architecting for rapid, frequent, reliable, and sustainable delivery of software. Going to break that down, explain what it means, explain why it's important, and explain its impact on architecture. Then I'm going to look at two different architectural styles, namely the monolithic architecture, and why that is a perfectly good choice for many applications. Then I'm going to talk about the microservice architecture and explain why that's a good choice for some applications, not a good choice for others. And then I'm going to finish up by talking about a key microservice architecture topic, loose coupling. And as you're going to see, the concept of loose coupling is kind of plays a major role throughout this talk. So let's get going. So I'm going to first talk about this word architecting. So obviously that's about software architecture. And then, well, what is that? Well, this is kind of my favorite classic definition of architecture. It's a set of structures that you need to reason about a system. And it consists of software elements, right? The relationships between those software elements, and then the properties of those elements and the properties of those relations or relationships, which is a pretty abstract kind of description, right? And you could sort of boil it down into architecture as really three things, right? Elements, relations between them, and properties, which, ultimately is a bunch of boxes and lines, but there's sort of key concepts there. And one really important idea about architecture is that it's multidimensional. So if you think about a building, right, it could be, say, a house or a high-rise building, there's actually many different facets to the architecture. So there's the structural aspects. If it's a high-rise, that's the concrete and steel. So there's a whole group of engineers who look at it from that perspective. But then there's the electrical architecture, the plumbing, the mechanical, so on and so forth. So there's actually all these different perspectives that you can have on architecture. And each one of those perspectives is kind of a view, which itself is really a collection of elements, relations, and properties. And what those specific elements are and the specific relations depends very much on your perspective. So let's make this concrete. So, let's say we're all Java developers, right? So what does that mean? So it means that what we do is create Java classes, organize them into packages. And so from an architectural point of view, what matters there are the elements are the classes, the packages, the relationships are the arrangement of classes into those packages, and then also the dependencies between those packages. So that's sort of what I'm going to call the logical view of architecture. So that's good, and we can focus on that, and it's quite important. But then there's the deployment view of architecture, which actually is all concerned with taking our classes and packages and turning them into code, into something that is running in production. And there's a couple of concepts there. You have modules, which in Java would be jar files. And then there are components, which are a collection of modules that are executable, deployable units. And so there's this issue, it's like, what is the nature of that architecture, the deployment architecture, which actually includes the deployment pipeline, the automated process that takes our code, builds it, tests it, and then finally deploys it into production. And when we talk about monolithic architectures and microservice architectures, we're really looking at mostly the deployment side of it, which actually leaks back into how we do development. But that's sort of kind of a quick introduction to the sort of concepts of software architecture and how there are multiple perspectives or views on the architecture of the system. So why does this architecture thing matters? Well, if you break down the requirements for an application, there it's basically two categories. There are the functional requirements, the stories, the use cases, which, that's all sorts of business logic, right? And then there are the non-functional requirements or ilities or quality attributes, which are things like scalability, security, reliability. And then, some of those are sort of kind of runtime things, but then there's kind of development time things like maintainability, testability, and deployability. And it turns out that you can basically implement a given set of functional requirements with almost any architecture. I mean, that's not entirely true, but it's like to just implement some business logic. Doesn't matter what architecture you have, but architecture directly the architecture of the system determines how well it actually meets its quality attributes. It determines how scalable it is, how reliable it is, and so on. So, so architecture is how we achieve those the necessary quality attributes. So that comes back to the word architecting, right? Which is the process of defining the application's architecture in order to satisfy those desired quality attributes. And that's obviously something we do at the beginning of an application's lifetime. But it turns out that, over time, the ilities of the application, those non-functional requirements change, right? You might go from just having a few users to, say, in the case of Facebook, having 1 billion users. The application and the team that's developing it typically grows over time. So all of sort of the non-functional attributes of the application evolve, change, and you actually have to occasionally re-architect. You can actually outgrow your existing architecture, and you have to adapt a new one. So, who is doing this? Well, that's the job of the architect, right? Which is like a coveted job description. And so if you're an architect, your job is to define an architecture that meets the required quality attributes. But what I find with a lot of organizations is that the business only cares about the user visible feature or the user visible aspects of the software, features, and then some user visible quality attributes like scalability, performance, and reliability. There's a whole set of quality attributes that are often ignored, particularly ones that impact development, which is really the context of this talk. And architects often don't actually spend too much time doing architecture. They're typically designing big new features. And so what that means is that the quality attributes that aren't visible to the customer are usually neglected. And that's where organizations get into trouble. And let's kind of look at some of those sort of more development time quality attributes. So the next thing I want to talk about is what is really meant by rapid, frequent, and reliable software delivery. Why is this relevant? And what does that actually mean for the quality attributes of the application? So back in 2011, Mark Andreessen coined the phrase "software is eating the world." What that actually means, what he meant by that is increasingly products and services are powered by software. So it doesn't matter what business you're in, software is playing an increasingly important role. Whether that's, and it doesn't, obviously banking, which is a very sort of, that's very tech oriented to begin with. But even in businesses that are very much in the physical world, like let's just say an airline, right, or a mining company, software is increasingly important to the business. So that's one key thing. It's a key trend is software is becoming really important. And also, the world in which we operate, we live, and more specifically, the marketplaces within which businesses operate are just sort of increasingly unpredictable. There's this phrase, volatile, uncertain, complex, and ambiguous. And, and a sort of more, common example of that is competitors coming out of nowhere. Deregulation of banking allows for banks that results in banks that are hundreds of years old facing tech startups that are 2 years old, and that they risk losing market share, for example. And then COVID, who would have known, thought if you go back a year, who would have thought that we would have spent a big chunk of 2020 sheltered away and afraid for our lives most of the time, right? That's almost been the ultimate disruptor. If you look at, say, online grocery deliveries in the US, they've jumped forward 5 years as a result of COVID. So, it's just, who knows what's going to happen, which is kind of exciting and scary all at the same time. But, what does that mean? Well, it means that businesses must be nimble, agile, and be able to innovate faster, right? You can imagine COVID comes along, online grocery delivery, and suddenly the demand jumps forward 5 years in a matter of weeks, and businesses have to be able to quickly respond to those kinds of changes. And that's actually happened, I think, across multiple industries. Sort of online has suddenly taken a much more important role. And guess what? Well, that means for us in IT, we need to be able to deliver software much more rapidly, frequently, and reliably, so that we can, so that our businesses can compete much more effectively. So a good definition, a good sort of quantification of rapid, frequent, and reliable software delivery is captured by these 4 metrics, which come from this most excellent must-read book called Accelerate. And there's 2 metrics that are concerned with the velocity. Those are lead time. That's the time from a developer committing a change, doing a git commit and a git push, to that change being deployed into production. You want to, that's a key development metric, and you want that to be as short as possible. There's also the deployment frequency. How many deploys into production are you doing per day? So those are measuring your velocity. Then there's also some reliability metrics as well. So first one is change failure rate. What percentage of deployments cause an outage? Obviously, that needs to be really low. And then if there is some kind of outage, how quickly can you recover from it? And once again, that you should be able to recover extremely quickly. So, the Accelerate authors do this DevOps survey, and they find that high-performing organizations, developing software at a much faster rate, but at the same time doing it much more reliably. So they're pushing changes into production many times a day, and then the lead time is under an hour. And there's a crazy statistic about Amazon.com, who I think are doing at one point were doing 130,000 deploys per day, which was like one deploy every 0.6 seconds. So you have massive organization, but a good goal would be each developer commits every day, and that change gets pushed into production. And then these organizations are doing it in a much more reliable way as well. So it's sort of counterintuitive. You think, oh my God, this must be reliable, so we must do it really carefully and slowly and infrequently. And it turns out that it's backwards. If you want to deliver software reliably, then you should be just delivering a constant stream of small incremental updates to your production environment. And of course, it's flowing through an automated deployment pipeline that thoroughly tests it. But that's how you achieve success. And there's a strong correlation between how well you can deliver software and the performance of your business, which is another key finding by the authors of Accelerate. So how do we do this? Well, you have to use what I call the success triangle. In other words, it's a combination of three things. You need to have the right process, which is really DevOps, which embraces continuous delivery and development. And that's really defined by the DevOps handbook. Right? It's a set of principles and practices for delivering software rapidly, frequently, and reliably. You also need to have the right organizational structure, which is a network of small, as in let's just say 5 to 9 people, cross-functional, loosely coupled teams that are empowered to basically take requirements, possibly seek out requirements, and turn them into deployed code, or code that is running in production. So you need the right process, the right organization, and then you need the architecture that supports both of those things, that enables DevOps and enables the teams to be loosely coupled. So the Accelerate book had some super interesting findings about what it's sort of like to work in a high-performing organization. So, one point is that team members can complete their work without having to constantly meet with people from other teams. Interestingly, I've been to so many companies around the world, and one constant is there is never enough meeting rooms. And I would argue that that's probably because the way they're organized is that they're constantly having to coordinate and with one another, and it's very inefficient. But in high-performing organizations, it's almost like your daily stand-up and just informal conversations with your team members is sort of the primary communication mechanism. Another key finding is they can make large-scale changes to the design of the system without making other teams do a bunch of work for them, or without forcing other teams to do a bunch of work. Then the third point is they can do testing locally. So you sit on your laptop and you make changes and you test it, and at that point you can be confident that it's ready to go. Obviously it goes through a deployment pipeline, but you can test effectively locally. And then finally they find that you can deploy the application. A team can deploy their service without having to coordinate that deployment with other teams. So very different from sort of standard organizations. But this actually has implications for architecture. It actually means that you have to have a loosely coupled architecture. If you want to have a loosely coupled organization, you have to have a according to Conway's law, you need a loosely coupled architecture. The fact that you can make changes without impacting other people, that actually implies that you have a modular architecture. The fact that you can test locally implies that you have a testable architecture. And then the fact that you can deploy independently implies that you've got this architecture that are called deployable. So, once again, here's some key requirements that the architecture needs to satisfy. So that's for rapid, frequent, reliable delivery. Now let's look at what I mean by sustainable delivery, why that's important and what that implies for the architecture as well. So, if you're successful, applications and a successful application will live for decades, 10, 20 years even. But at the same time, the technology that you use to develop software changes, right? Technologies come and go, or even versions of technologies come and go, right? At any point in time, you look in the marketplace, there's a set of technologies that are important, and that slowly changes over time. Now, Java, 25 years old, right? So it's still important. That's a good thing. But which version of Java is important has changed throughout those years, right? And from a technology management point of view, you want to ensure that the importance of a technology inside your organization, the level of reliance that you have on it, is aligned with the importance of the technology in the marketplace, right? In other words, if you're relying on a technology that is no longer important, out of date, obsolete, you have a problem that represents some kind of technical debt. And so what that means is for these long-lived applications, we need to be able to incrementally upgrade the technology stack. Obviously, you can always do a complete rewrite, but those are actually incredibly expensive and risky. So you want to be able to incrementally switch out the technology that you're using in your application in order for it to have a long, healthy, sustainable life. And this is actually another form of modularity, right? Where, in a sense, normally we think about modularity as where the API encapsulates various design decisions. Well, here I'm sort of expanding that definition of modularity to include the API in encapsulating the technology choices that you've made in your application. And you could imagine that there's very few ways to achieve that. One obvious way, of course, is you hide something behind a REST API, right? And then doesn't matter what's behind it. And that kind of, to me, is like, this is hinting at the importance of the microservice architecture. But I'll get to that in a minute. So put all of this together, right? You need an architecture that's loosely coupled and modular, both in the regular way and also sort of in this way that encapsulates technology. And you could also call that evolvability or evolvable as well. Plus, there's a requirement around testability and deployability as well. So that's the architecture that we need for rapid, frequent, reliable delivery of software. So let's look at a couple of choices, right? If you were to go on Twitter today and say, ask a question, what architecture should I have for my application? You'd get answers like the monolith, microservices are a total mistake. And then there are other people that are going, well, microservices are the way to go. It's the future, right? And so, there's been some great tweets about very polarized discussions and some great tweets either way about that. But as you could imagine, I mean, from my perspective, the answer is very much, it depends. Depends very much, what on sort of fundamentally the size of your application. So let's look at the monolithic architecture, right? So that's an architectural style that structures an application as a single executable or deployable component, which in other words, what's getting deployed into production is either in a Java sense, a WAR file, or it's an executable jar, right? I mean, those are the common ones. And you can imagine at the start of the application, you just, make a directory, CD into it, and then you start typing away, right? And literally, I mean, I've worked at startups where pretty much that's how development began, right? So, an example application would sort of look like this, right? Bunch of very sort of modular packages and that get turned into modules, modular layered architecture. That all gets packaged up into a WAR file or an executable jar or something, and then it's talking to the database. So, and then there's a browser. The application's either generating HTML or it has a REST API or something like that, right? So anyway, that's sort of a typical monolithic architecture. And this is a perfectly good choice for a lot of applications, right? Because if you have, especially when they are small, because a small application is highly testable. You can test it locally on your laptop. The amount of time it takes to test is relatively short, right? Deploying means just pushing it into production. That's pretty straightforward. It tends to be easy to maintain, right? The code base is kind of small. And then if you design your package structure correctly, it's modular. And it's kind of sort of evolvable in the sense that, well, yeah, you can swap out the technology stack by doing a complete rewrite. But if the application is small, that's not impossible. But the problem that you have is, that's tiny application that maybe it had started off in life as a single, one directory. You just started with make dir, and you've got half a dozen developers. If you're successful, you're likely to end up over time with a large application, right? Many millions of lines of code. I've worked with clients that have had applications where the WAR file itself is measured in gigabytes, right? And then the number of developers you have working on it is measured in the hundreds or thousands. That's the sign of success. But once you get into, once your application reaches that scale, you have a whole bunch of issues, right? Even just committing changes into a single source code repository when you have a lot of developers is problematic, right? There's a contention for actually doing commits. Obviously you can no longer do teams can't deploy their work independently. Because everything is packaged together with every other team's module, and they all have to deploy together. If you've got a very large application, in order to reduce the execution time of the deployment pipeline, it needs to be parallelized. It needs to be running on a cluster of machines. So you've got this complex infrastructure for doing builds. And then ultimately, you run the risk that the actual act of updating production, which ends up, I feel like, can't really be parallelized, ends up being a bottleneck. So the rate of change, I think, ultimately will kind of just bottleneck at some point. Now, you could have a more complex architecture where you split it up into, each team has their own repository, and that actually parallelizes the build, and each build pipeline spits out a compiled module that then feeds into the application level deployment pipeline. but you still risk having a bottleneck there. So there's sort of some inherent issues around scalability at this point, sort of from a development perspective at this point. So you sort of end up with this graph where over time the size and the complexity of your application grows, but then sort of the kind of the desirable development time at soft quality attributes gets worse and worse over time, right? Testing is likely to take longer, deployment takes longer, so the sort of the rate of change kind of just plateaus. And this is a problem for the business, right? Because you really need to be going faster and faster, and there's a real risk of disruption as well. So you can kind of mitigate some of the problems of having a large monolith by throwing a bunch of technology off at it, but ultimately, I think it's quite difficult to do at large scale. Plus, there's this huge problem where many of the technology choices in your application are global, right? It's basically, ultimately, you've got, say, a giant executable jar file. Well, you have committed to using the same version of Java. Well, first off, you're committed to using Java. You're committed to using the same version of Java. And unless you start getting into the complexities of the Java module system, for the most part, you can only use a single version of any given library, third-party library. And so that actually makes it extremely difficult to make changes, to sort of to change your technology stack. And you basically end up being locked into the original technology choices that you made. And I think there's a lot of organizations who are sort of stuck in this situation. So, you end up in what I call monolithic hell. I mean, it's not inevitable, but there's a very high risk of that. So what can you do about it? Well, of course, obviously, the alternative architecture is the microservice architecture. So that's an architectural style that basically structures an application as a collection of services or components, right? So instead of effectively a single executable, a single deployable, you have many of them or multiple executables and deployables. And each one of them is highly maintainable, testable, has a minimal lead time. Each one is independently deployable by definition. And they're obviously loose, that they need to be loosely coupled. And then the last point is super important. Each service is owned by a small team. So if we were to look at the food to go application, it would consist of multiple services. Each one of them has its own database. They're communicating via a message broker. You can sort of functionally break up the web application into multiple web apps as well, each one implementing a particular part of the UI. You'd have an API gateway in front of it, exposing APIs to the outside world, right? So, instead of one thing, this architecture is broken down into a bunch of services, which actually hints at the complexity, right? Like there's a bunch, in the deployment perspective, there's many more moving parts, many more boxes and lines. So, what is a service? The whole point of a service is to expose an API. In a sense, the whole purpose of a team is basically to expose an API. The API implements operations, right? Things that clients can invoke. There's two types of operations: commands that mutate data, create order, cancel order. There's queries that retrieve data, like find order history. And these operations can be invoked either synchronously, which is sort of how we normally expect it, but importantly, they can be invoked asynchronously as well. Services also expose events, typically like order created, order canceled. So when key changes occur in the service, it's common for it to publish events. And then services can invoke operations implemented by other services and consume events emitted by other services. And the service also has its own database as well. And I'll talk about that in a little while. But the idea, though, is that the service database is an implementation detail of the service. Services typically implement business concepts. So a service implements a subdomain, or if you're familiar with DDD, or it would implement a business capability, which is a term from business architecture. So there would be order management, delivery management, accounting, so on and so forth. And another key issue is sort of like what's the granularity of services, and what's the size of a service as well. So given that the primary goal is to enable a team to be autonomous, so needs to be a loosely coupled architecture to support loosely coupled teams. Ideally, you just want to have one service per team, as few as possible. And also, given that the team is should be small, 5 to 9 people is a good size. That actually imposes an upper bound on the size of the size and complexity of the service as well. So that's sort of a rough sense. And interestingly, a bunch of organizations I visited, they actually tend to have like a service per developer, which arguably is far too fine-grained. It's just too much complexity for insufficient benefit. Having said that, it can be useful, it can be useful to split a service if it solves a tangible problem, right? So imagine, over time, the service grows and the team grows. Well, that would be a reason to split the service and split the team to keep the team the right size. If the deployment pipeline takes too long, well, you could split the service into 2 that can be developed and tested independently. Obviously, there's very little not so much benefit in splitting a service into 2, which then constantly are having to change in lockstep, right? That's a sign of tight coupling between those services. You might need to split to support polyglot development. So imagine your data analytics team has produced a fraud detection algorithm in Python and machine learning model, right? But the rest of you're using Java. That would be a reason to have a Python service. You might want to split for fault tolerance, like high parts of the application that need to be highly available, like the critical path for processing credit card authorizations might be separated from merchant account management, for example. So if I'm working on merchant account management, well, I don't want to impact the credit card authorization logic. You might also want to split for regulatory requirements as well, where if you have part of your application is subject to strict regulatory requirements like PCI or some sort of health care related requirements, well, you could split those off so that the development of the rest of the application is not impacted by those fairly burdensome regulations. So a whole bunch of kind of issues that can drive introducing more services, but you should only have services should exist for a good reason, not just because. So a bunch of benefits to this, right? It improves maintainability. I think each service is small and fits in the head of the developers who are working on it, unlike a massive monolith, right? Each service is small and easier to test and faster to test, so it improves testability. You can change each service's technology stack independently, and I'll talk about that in a minute. Each service, by definition, can be deployed independently, which means the teams don't have to coordinate. It can improve scaling as well, and it can improve availability and fault tolerance as well. If there's a failure in one service, it doesn't necessarily impact other services. But by far the biggest benefit of the microservice architecture is that it enables DevOps, it provides the testability and deployability that DevOps needs, and it provides the loose coupling that's vital to enable the teams to be loosely coupled as well. So you end up with a situation like this where each team is committing changes to their services code repository. There's an automated deployment type pipeline that's building and testing the service, and they're all working independently most of the time, unless they have to coordinate their work to agree on API definitions. But most of the time, these teams are working independently. And then I think a huge benefit, which is important for these long-lived applications, is that you can experiment safely with new technologies and incrementally evolve the technology stack, right? So imagine that you get all excited about Golang, right? You could go implement a service in Golang, even though the rest of your services are implemented in Java. You can safely experiment with that. But then, and if you like it, that's great, that experiment has succeeded and you've now figured out that there's a new technology that you wish to incorporate into your architecture. But on the other hand, you want to use, say, a more 21st century language. You might decide, well, yeah, we want to use Kotlin instead of Golang, right? And that's okay. You haven't invested much time in experimenting with Golang. And at some point, you could, when you're going to make major changes to that service, you could rewrite it completely in Kotlin, for example. So it lets you experiment and incrementally evolve your technology stack. And obviously, these services, even the Java-based services, they don't have to use the same version of Java, right? Each one can evolve at its own pace. They don't have to use the same versions of third-party libraries. So you avoid all of the issues that you can get into with a monolith, which basically requires you to use a single technology stack that cannot be evolved incrementally. But there are some significant drawbacks of this architecture. You're building a distributed system, so you've got all the complexity of distributed system development, inter-process communication, for example, right? Complexity around testing. On the one hand, testing individual services is easier, but testing that they work together involves adopting some new techniques like consumer-driven contract testing. And then from a deployment perspective, there's many more moving parts in production that need to be orchestrated and monitored and managed and so on. So it's sort of like kind of the sort of like for small applications, you should stick with a monolith. But once your application grows, the benefits start to outweigh this complexity. And then, there are some issues as well, like correctly identifying service boundaries. I mean, that's an interesting challenge. There's no mechanical process for that. Yet at the same time, figuring out what your service boundaries are is the most important decision that you can make. Choices around technology are very secondary. And then if you have a monolith, refactoring that into a microservice architecture can be painful and time consuming. So it's they're not easy to adopt. But on the other hand, if you've got a massive monolith, you're most likely in a world of pain anyway, and you have to embark on this refactoring effort. So it sort of boils down to, if you're developing a large, complex application and you need to deliver it rapidly, frequently, reliably, and sustainably, the microservice architecture is a good choice. But if not all of these things are true, then probably the monolithic architecture is a better choice. Okay, so I want to finish up by that's sort of a discussion of the two architectural patterns and why they're relevant and when you should choose one over the other. I want to finish up by talking about the architecting loosely coupled services, because this is key sort of requirement that often people get wrong. In fact, I mean, there's one blog post or one company, they built a tightly coupled set of services, and it was even worse than having a monolith. And they actually had to rewrite it back into a monolith, though they did get a conference talk out of it. So, but they sort of fundamentally, they ignored this point. So this all goes back to Conway's law, which is fantastic, right? I've been hearing of Conway's law for decades, and it turns out that he's on Twitter, which is so awesome. So basically what he said, paraphrasing, is that the organizational structure, or specifically the communication patterns in the organizational structure, who talks to who or who reports to who, mirrors the software architecture, and what that and vice versa. And what that actually means, that if you want to have loosely coupled teams, you got to have a loosely coupled architecture. And there's actually, which is interesting, right? So services almost often have to collaborate. So in my example, when in order to verify that an order can be created, the order service has to reserve credit, which requires checking with the customer service. So collaboration is, inevitable, which introduces a certain amount of coupling, but you want to do it in a way such that they are loosely coupled. Turns out that there's two types of coupling, at least two types. One is runtime coupling, which is where one service cannot respond to a request until the other service responds to it. And I'll talk about that in a minute. And then there's design time coupling, which is where at development time, when you change one service, you kind of have to change another service in lockstep. And a key thing to remember is, just because you have microservices, you are not guaranteed to have a loosely coupled architecture. You have independent deployment, which sort of feels like loose coupling, but you have to design your services to be loosely coupled. And loose and tight coupling is a problem because it requires coordination between the teams, meetings to discuss API changes, which slows down development. People at ThoughtWorks have found that decision-making across teams is 10 times slower than decision-making within teams, and it can slow down development. And in the worst case, you can end up with what's known as a distributed monolith, which is where multiple services are frequently changing in lockstep. So it's really important to prevent tight design time coupling. So there's a few things that you can do. So one is, this is an old concept of you apply the dry principle. Don't repeat yourself. So in other words, every concept should be represented in one place, and you translate that into the microservice. Every concept should be represented in just one service. If you have the implementation of a concept scattered across multiple services, whenever that concept, think business rule, changes, then all of those services have to change in lockstep. So that is a bad thing. A change should ideally only impact one service. You also want to design your services to look like icebergs. The saying goes that the visible part of an iceberg above the water is much smaller than what lies below. So you want to have services with relatively small APIs that are stable, that can encapsulate a much larger implementation, because what's hidden can be changed, right? And what's exposed in the API is much harder to change, because you're, if an API, worst case, if an API changes incompatibly, then that requires all of the clients of that API to be updated, which is, painful. So you want to design services with thin APIs that hide a lot of complexity. Great example of that is, say, like Twilio messaging, right? Like you want to send an SMS. It's like, well, it's roughly send message this from this number to this number, and here's the message, right? Incredibly simple API that encapsulates a massive amount of complexity. So, you know, it's a key principle. You want to avoid having putting business logic in shared libraries, because whenever that business logic changes, all of the services that use that library have to be updated, requires them to change in lockstep. Now, if you do this, this could lead to a conference talk, as did the company I mentioned, but it's best avoided. Now, you also want to avoid sharing of database tables. Database schemas are implementation details, right? And so, you know, if you give access to if you let other teams access your database, changing it is no longer straightforward. So it's best avoided. You should really encapsulate the database. So that's design time coupling, and, you know, a set of principles that can ensure that your services are loosely coupled and reduce the amount of coordination that's required amongst the teams. Now, I want to mention loose runtime coupling as well, even though that's sort of it's sort of related, but it's quite different. But this is another common anti-pattern that I've seen when I've worked with various organizations. So if you think about, let's, you know, think about, well, you know, we got a bunch of services. How are they going to communicate? And it's like, yes, well, they just use REST, right? So imagine like the order service handles a post request that creates an order by doing a put request to the customer service to reserve credit. Looks super simple, right? And then the response comes back. That enables the order service to create the order, and then it sends back a response to its client. Superficially, very simple, right? You know, it's mirroring the communication pattern inside a monolithic architecture, but you've just designed a system where the availability of the create order operation depends on both of those services being available at the same time, right? Both being up and both being able to respond have a response time that's within their SLA. And so its availability is really the product of the availability of those two services. Now, in this simple case, maybe it can work. I mean, there's some actually other interesting design issues that you get into, but you've reduced the availability of your system. So it's sort of like this distribution is free anti-pattern. And, you know, I remember one time I visited a client. They had this critical API endpoint that was integrating with a third party, and there was really strict SLA requirements, right? Like around availability and around response time. And by the time I talked with all of the teams that were involved in implementing the services that were invoked, became apparent that like 10 plus services were being invoked, which, you know, so they were risking, you know, not meeting their SLA because if any one of those services was down, right, they couldn't respond, or if any one of those services was exhibiting extremely high latency, they could not respond either. So it represented a major risk to the business. So you should be very wary of long chains of synchronous communication. So there's a really key concept, which is this idea of a self-contained service, which is a service that can handle a request without waiting for a response from another service, right? So the order customer example I had earlier, the order service was not self-contained, right? Because it had to interact with the customer service. So so it didn't fit this pattern. So one way of making it fit this pattern is to actually merge together the order service and customer services, right? That improves the availability of this critical operation, right? So that's good. But at the downside is that the team is much larger. Now, depends on the situation, this might be a worthwhile trade-off, or it might not. So, once again, it depends, right? But quite often, you can't, if you followed that path, you'd basically end up with a monolith. And we've agreed that in this situation, we want to use services, right? So you can adjust service boundaries, but ultimately you might have to have some kind of communication. And for there, it's actually best to have asynchronous communication. I highly recommend this book, Enterprise Integration Patterns. It's a great pattern language. So one way of implementing the order service using asynchronous communication that gives you high availability is as follows. So the post-order request kind of basically initiates the process of creating an order, and the order service responds immediately. And in the meantime, a bunch of events are exchanged. So the order service says, I've created this order. That event gets consumed by the customer service, which reserves credit, sends back an event to the order service, which can then change the status of the order to rejected or approved. And this specifically is a choreography-based saga. This is more available, right? The order service can respond to a create request without waiting for any other services. But you've got the downside is you've got the complexity of sagas. And another interesting thing is that it changes the meaning of the API. The response that comes back first cannot say whether the order was accepted or rejected based on whether there's credit available or not. So the client has to check back later to see whether its order has been approved or not, or maybe it could consume events somehow. So there's some super interesting trade-offs with this, right? But this is a very useful pattern to use. The other pattern that you could use, which I call, is command query responsibility segregation, which is basically a complicated way of saying, well, we're going to replicate data to the order service. Specifically, what happens in this design is the credit limit is replicated to the order service, and the order service is made responsible for tracking available credit. That responsibility has been taken away from the customer service. So that actually gives the order service the data that it needs in order to decide whether there's credit available. And we've made it self-contained, right? So it's more available, but the response does contain the outcome of the operation. But you've got the cost and the complexity of replicating data. So you sort of got these different sort of trade-offs, right? Between you can merge services together, right? Which means merging teams, which is problematic, but maybe a good idea sometimes. Or you keep them separate, and you either use sagas to maintain sort of data consistency across these services, or make them self-contained, or you can use replication. And each one of these approaches sort of has different trade-offs. Now, like for instance, you could replicate the credit limit to multiple services. That's okay, but only one service can be responsible for managing the available credit. So if there were multiple services that needed to maintain available credit, that would not work. And you'd have to keep that back in the customer service and use sagas. So anyway, so that's sort of it. So in summary, right, couple more slides. So there's some trends that are requiring IT to deliver software rapidly, frequently, and reliably, right? The fact that software is powering businesses, and the world, the marketplaces are unpredictable. You have to embrace DevOps. You have to embrace a network of loosely coupled teams as your organizational structure. And then another key trend is that software lives for a long time, so we need to be able to upgrade the technology stack. So that then leads to you need an architecture that's loosely coupled and modular and testable and deployable. Now, so, the monolithic architecture is a good choice for small applications that are developed by a small team. But once the application becomes large and you have a large team, often the microservice architecture is a better choice. And if you adopt the microservice architecture, you need to design your services to be loosely coupled, both from a runtime and design time perspective. So that's my talk. Thank you for listening, and I hope that you found it useful.
Thank you, Chris. Thank you so much for connecting today and presenting this talk and supporting Devoxx Ukraine. Dear participants, you can ask your questions. Thank you. You can ask your questions to Chris during Q&A Zoom room just now after this talk, and you can unmute, turn on your video, and have a discussion with Chris. Yeah, so thank you once again, and we hope to welcome you in Ukraine next year. Dear participants, Devoxx Ukraine is almost done, but don't hurry up turning off the streaming. We will have a closing ceremony soon, and at this ceremony we will announce the winners of all prize raffles from our partners you solved during these last 2 days. And of course, the best talks and the best speakers of Devoxx Ukraine online. Stay with us, and we will be back soon. Okay, dear participants, thank you for these 2 awesome days you stayed with us at Devoxx Ukraine online. We are very thankful to EPAM, our platinum partner and co-organizer of Devoxx Ukraine and the company who made this event happen.
Thank you very much, and we are very thankful to the FEST group who was also hosting this event and was organizing this event. Thank you very much.
Yeah, and of course we are also very thankful to the speakers who prepared their talks for the last several months, worked on them and joined this online broadcasting, online streaming, and was able to share their knowledge and competence. Thank you very much. Yeah, dear participants, stay with us, subscribe to our Facebook group, Twitter channel, and to our YouTube channel of Devoxx Ukraine. All videos from 2 days of the conference will be published at this YouTube channel within the next 2 weeks.
And we are waiting for your feedbacks. So if you were yesterday or you were today or you were both maybe days with us, you please scan this QR code that now you see on your screens and follow the link and please pass our little survey so we can get better and better each year.
Yeah, and if you enjoyed this conference today and yesterday, if you enjoyed Devoxx Ukraine for the last years, and if you want to be part of Devoxx Ukraine 2021, we have opened a pre-registration for the next year. You can fill in the form, just leave your email, and you will be the first one who will be notified when we start preparing Devoxx Ukraine 2021. We don't know the format yet, whether it will be online or offline, depending on the lockdown and quarantine, but we hope that we can meet you in person in a year, November 5 and 6 at Devoxx Ukraine 2021. Yes, and for those of you who have participated with our challenge and who have posted the photos how you watch Devoxx Ukraine online with hashtags Devoxx Ukraine and Java 25th anniversary. So if you see your photo at this slide, you are the lucky winners, and your photos were the best ones from all the posted in all social media. So we will contact you soon, and you will receive a prize from our gift partner, JetBrains. This is a 1-year free subscription to any product from their all-product pack. So stay with us. We will let you know, and we will send you the link to this free subscription. Yeah, we are also very thankful to our silver partners, companies who supported this event. It's DN Simple, iTerra, and Grid Dynamics. And if you have participated with a quiz from Grid Dynamics, here are the lucky winners of this quiz. There are more than 300 people participated, so the guys on the screen, you are the luckiest, you are the smartest, so you win prizes from Grid Dynamics. The company will contact you via the emails that you have specified, and they will send you your prizes. Okay, and now we would like to invite to our virtual stage our next partner, Sigma Software, who will also raffle some prizes for their activities they had during these 2 days. Kate,
Hi,
do you hear us?
Hello.
Yeah, I'm here. You're welcome. Happy to see you again. Guys, welcome to Sigma Software Prize Draw. This time it's happening online. We are really happy to support the Devoxx conference this year online. Previous year, we really happy to meet the Java community offline. And today, I want to say thank you for all of you who joined, who watched the speeches from our speakers, who participated in our giveaways, and who also checked their knowledge in Java history quiz. So it's time to announce the winners, and I will start from the Java history quiz. We have quite a lot of winners. the people who have the highest scores. Denis Бондаревский, Сергей Левицкий, Андрей Легидза, Евгений Скорый, Виктор Хаврилышев, Алексей Гнатюк, Алексей Янов, Леонид Остапенко, Дебакланч Дали, Игорь Гринев, Александр Калиничев, Варас Барбоса, Артем Козин, Александр Лукьянин, Тиаго Муси, Евген Воробьев, Нинель Чумак, Богдан Кубарь, Максим Тычина, Дмитрий Волошин, Вероника Стехненко, Alexander Stechnenko, Alex Kalka, Alexei Klitko. Guys, I'm really happy to congratulate you with the win. Sigma Software prepared some branded prizes for you, and we are going to contact you via email you specified in the registration form. So waiting for our email and congratulate you again. So let's move to the main prize from Sigma Software. It's Amazon Prime Year membership that includes thousands of video in Prime Video, 1 million free songs, free unlimited photo storage, instant access to email, ebooks, and free and convenient ways to get delivery from Amazon. So who is the lucky ones? Let's check. We have quite a lot of participants, so probably who is the lucky one? Ustinov. I don't know the name because they're all the last names. So we congratulate you and we'll contact you ASAP or via email and make this subscription for you. So thank you again and hope to meet you next time in offline format.
Thank you, Kate.
Thank you very much.
And thank you, Sigma Software, for support and for making this event happen today. So our partners, our speakers, our participants, you are the key of this event today. So thank you once again. See you next year.
Thank you. Bye.
Okay, and we are glad to invite to the stage our next partner, NX company. Hello.
Yeah. Hi. Hello, everyone. So, as it was mentioned, I'm from NX company. My name is Alona. First, thank you to the organizers for this amazing conference. And I would like to say a few words about NX. We would like to mention that we have more than 1,000 professionals and are actively growing and looking for more talented people to join our team, and we hire remotely. So do check out our NX Career website and our social media channels to find out about these opportunities. And now, let's move on to a fun part to find out who are the lucky winners of present from NX. So we will have 4 lucky winners. The main prize is this Xiaomi robot, and 3 other people will win each big box of branded goods from our company, including a branded water bottle and blanket and a lot of other stuff. So we have a list of people who wish to participate, and now using random org, let's find out our 4 winners. Yeah, let's randomize it. So it's hard to read for me, but I'm sure you see the names on the screen. So congratulations to the 4 first people. The first person wins our robot, and 3 other win our branded goods. So thank you. Yeah.
Thank you so much, NX. And the winners, you will be contacted by NX company and you will receive your prizes shortly. So yeah, we are thankful NX company for supporting our event, and we would like to invite to our online stage our next gold partner, Svitla Systems. Hello.
Hello, everyone. Nice
Hello.
to see you.
Nice to see you
My
too.
name is Diana. and I am community manager from Svetla Systems. And I am very happy and very excited to be here today because I'm going to announce the winners of our raffles. So we had two of them. The first one, participants just had to fill some information in our questionnaire. And the second one was quite harder because participants had to leave right answers in our Java quiz. So, among our presents, we have several thermocups, cups, backpacks, t-shirts, and also the main prize is AirPods Pro. We have 2 pairs of them. So, here are the winners. So, cups go to Власенко Ольга, Хуляренко Руслан, Бажанар Victor, Ткачук Lilia, and Andriy Melnik. Coffee to go cup go to Наконечна Мар'яна, Підгорний Павло, Максим Тичина, Ірина Довгун та Станіслав Римар. And banana bag go to Devoxx Юрій, Кузьменко Ігор, Олександр Даниленко, Дмитро Альцванович, Андрій Новак. And t-shirts go to Ткаченко Андрій, Колєсніков Валентин, Володимир Максименко, Сергій Хоменко, and Artem Kozin. So we have a lot of winners. And from our Java quiz, so the winners are Thermocup go to Alexander Yanov, Alexander Butrym, and Mikhail Gorbunov. Backpacks go to Ivan Boyarin, Vasil Serzhinsky, Alexei Klochko, and the main prize, AirPods Pro, go to Nikolai Ivanov and Andriy Sid. Congratulations, guys. And if you misheard something, you can find the list of winners on our Facebook page. So welcome and check if your name is on the list.
Thank you. Thank you,
Thank
Diana.
Thank you a lot. I want to thank all participants for joining and also you organizers because you do great things now. You help to develop this IT community and also you helped us to gain some new knowledge and experience. And I really hope that we will see within the next conference in person and offline next time.
Yeah, we hope for that too. Thank you, Svetla Systems, for supporting our event this year. And congratulations to the lucky winners.
It was a pleasure for us. Bye, guys.
Bye. Okay, we are moving further, but before we will invite our next gold partner, I would like to invite on this stage the head of Devoxx Ukraine Program Committee, the guy who worked hard with the speakers for the past year, and the guy who not only the guy, but the team who worked hard, and the guy who selected the talks. And he will announce the best speakers of Devoxx Ukraine 2020. Oleg, welcome on stage.
Thank you. Hello, everyone. Yeah, that's been like two amazing days, I would say. That was quite kind of tough, I would say, but I guess it's worth that. And everyone, I mean, I like all the talks, all the speakers, but we have like top 5 based on the participants' votes, and I will just announce right now. The first one, Guy Rose. Congratulations, Guy. Second one, Victor Renta. Third one, Brian Vermeer. Fourth one, Simon Ritter. And fifth place goes to Grace Jensen. Thanks a lot, guys. Again, I very much appreciate your conference attendance, and I very much hope that next year we will be able to organize Devoxx Ukraine probably offline and meet all of you in person. My pleasure. Thanks.
Thank you so much. Thank you, Oleg, and congratulations to the best speakers. Guys, we have prepared a small present for you from our Devoxx Ukraine team. And we will send you a branded hoodie of Devoxx Ukraine 2020. You know, it's a very, very limited edition. Only 5 of them this year. So you will be the lucky one to receive them. Thank you so much. And yeah, I would like to invite to our online stage our next gold partner, the company who supported Devoxx Ukraine this year and some of the years before, InfoPulse, and Alina, who will connect now to
Hi,
our
girls.
stage. Hello, Alina.
Hello. Hi. I would like to be here with you, but now I'm a little bit nervous because I feel myself like a Santa in a New Year night with a big bag of prizes, and I have only a few minutes, and already we have a list of participants who won our prizes. And I can read it. So, power bank go to Harbalukov Oleg. Wireless charging. Yeah, yeah. Wireless charging for
Power
Tim
bank!
Nikolai. Mini speaker Orlov Vladislav. Next mini speaker. Very interesting. Priya Vishnu. Mini speaker. Next one. Kadyrov Inam. Mini, mini speaker, Chancellor Mitya.
Bravo!
And I think that Semenenko Dima can give from us travel set.
Congratulations.
And next travel set go to Yerusalimentsev Dmitry.
Congratulations, Dima!
So next travel set go to Kapustnik Mikhail.
Woohoo!
And
Yeah, go!
last travel set go to Ivanov Yanislav. So next our prize go to Mažejka Povilas. It's a gym backpack. And next backpack goes to Jenkan Yan.
Woohoo!
So we have
Congratulations,
two umbrellas today. Yes, we have two umbrellas today, and these umbrellas will go to Linik Oleg and Pindral Marcin. So, and our beautiful plate go to Izotenko Volodymyr.
Woohoo! Congratulations.
Yep. But we have our main prize. It's Marshall Loader speaker, Stanmore Wi-Fi Black, and now we will see who will be the winner and who will be the lucker today.
We are intrigued.
Yep, I'm too. So, and our main prize go to Barma Dmitro.
Woo! Dmitro, yay!
So, thank you very much for this opportunity to be here in one of the biggest and main conference in Java world, Devoxx Ukraine. And I wish all participants prosperity and good luck in your doing. So, I will be glad to see you next year offline in one of the biggest and beautiful and superstar conference, Devoxx Ukraine.
Thank you, Alina.
Thank you very much for such warm words.
Thank you. We wish you were here, of course, with us, but this year is a bit different. But we are very thankful to InfoPulse company for supporting our event this year. Yeah, and as the next gold partner we want to invite to this stage is Lunatech company, and we will connect Antoine. Antoine, are you with us? Hello. We don't hear you, Antoine.
Can you speak up? We will reconnect.
Yeah, Antoine will reconnect. So while he's reconnecting, I would like you, if you have joined the closing ceremony not from the very beginning, I would like just to remind that all the videos of the talks, they will be published within the next 2 weeks on our Devoxx Ukraine YouTube channel. So you can subscribe to the channel. There will be a separate playlist for this year, and you will see all the videos of the talks you have missed.
And also, we will send you a letter with a feedback form on Monday. And please go by the link and submit the feedback form. This is very, very important for us because we want to make our event better and better each year. So please put your thoughts into the feedback form.
Yeah, and as it was mentioned on the opening ceremony, if you have any crazy ideas, what we can do next year, just feel free to put it in the form, and we will be glad to hear your feedback and to see your opinion on the conference. Yeah, and while Anton is still reconnected, we have 1 more minute. We have opened a pre-registration for the next year, Devoxx Ukraine 2021. The link will be sent to you together with the feedback form in an email. So if you liked these 2 days of the conference and you want to be part of the next year conference, just feel free to fill the form, leave your email, and we will contact you once we start preparation. So Antoine, you are back with us. Hello.
Do you Hello, do you hear me?
Yes, we hear you well.
Fantastic. I'm so happy.
So, yeah, we are so happy you're with us, and thank you to Lunatech company for supporting our event. So what prizes you would like to raffle for our participants?
The prize is a Lightband Reactive certification.
That's
wow.
Cool.
Yeah, there is 2 of them. So I have the name of the winner.
Yeah, we are waiting. We are looking forward to hear.
Yes, but later. First, I want to thanks to all the participants and the organizers. I hope that all of you guys enjoy this edition. Apparently, yes, because there's more than 200 attendees participated to our raffle. So we will send you an email very soon to give you the vouchers. Lunatech was very proud to participate to this Devoxx Ukraine edition. Do not hesitate to contact us if you want to have any further information about the company. And long life to Devoxx.
Thank you very much.
Thank you. Thank you for these warm words.
Then, yes, I will check the name of the winner because it's...
We are waiting for it.
So, big suspense. So the winner, correct me if I'm wrong.
Okay, go ahead.
Ilor Kisilevich.
Kisilevich. Ilya Kisilevich.
Ilor Kisilevich and Stanislav Rimar.
Stanislav Rimar. Very nice, very nice.
Yeah, guys, Dmitro and, Ilya and Stanislav. Congratulations, and you will be contacted by Lunatech company and maybe by Antoine in person, and you will receive your prizes. So congratulations once again.
Yes, the 2 names of the winners will be on our Devoxx page.
Yes. Okay. So thank you
very
once
much.
again. Yeah, thank you for supporting our event. We are very grateful to you and hope to see you next year, of course.
For sure, in real life.
Yes, in real life. Welcome to Ukraine.
Thank you. Okay, and I would like to invite to this stage, online stage, our next partner, gold partner, Luxoft company, and Olesya, who will connect today. Hello.
Hello.
Hi guys. Can you hear me?
Yes, we hear you.
Great. I'm very happy that my connection went through. And first of all, I would like to thank to the organizers of Devoxx 2020 for putting up such a wonderful event, 2-day online event, which actually turned global. This is an amazing thing you've done. Congratulations to you.
Thank you very much. Your
Thank you.
words are very important to us.
And the second, you're very welcome. And the secondly, I would like to also thank the participants of the conference because none of this would have made sense if it all wasn't for them.
Yes, that's true. That's true.
They're the
And
best, and I think they're
yes,
the best.
I mean, they've made, even though we didn't see each other, right? But I could felt this vibe and the communication, the conversations, and the questions that were put to the speakers. People really made this conference, alive as it could be digitally.
Yeah, as much as we could do, it's alive.
Yeah,
Yeah.
yeah. Well, it seems like we are forced today live in this like semi-real or digital. This is a new reality, right? So,
Yeah, that's true.
but and the third, my thank third, in a third turn, yes. But last but not least, I would like to thank the speakers because they were up for the event. They never resigned and were there, to deliver their best knowledge and share their experience. Great job to everyone.
Thank you. Thank
you.
So I'm basically done with all my thanks. And have to say that we were very happy to be a part of this event. And we hope that next year we will be joining all of you somewhere in the event hall where we can, shake hands and smile at each other and just have a good time together. And to wrap up this amazing experience of 2-day conference, I would like to share my screen and finish up our friendly giveaway. I want to remind to our participants that we had quite a few entertainments during the Devoxx. So there was a galactic IT quiz for the developers where they could test their knowledge and answer the questions on technology, and whoever was the fastest wins the prize. The names of these winners you can find in our Telegram channel. The link to it is in the partnership section. So if you are interested in who won, please go ahead and check it out. And we will contact all the winners via email, but still you can find your names if you want in our Telegram channel. And that was the first thing, yes, Galactic IT Quiz. The second thing, we had our Locks of Friendly giveaway where we are awarding people with something to remember us by. These are super chargers for the gadgets, whichever gadgets you have. And the second thing is the backpacks. And the main prize of our giveaway is a bicycle, which I am about to find out who's the winner of it. So if you can see my screen, I'm using random.org, the very common tool for picking the winners. Let the destiny decide. And here are the topic in this window. There are over 6,000 names of the participants who agreed to participate in our friendly giveaway. And I will just, with one easy movement, I am pressing the randomize button, and whoever is the number one after randomizing this list will win the bicycle. So, da-da-da-dam, I'm done talking. And back to randomizing. Довженко Dmitro, congratulations.
Oh, congratulations!
Congratulations, Metro. That's an amazing gift for our quarantine times?
Yeah, well, maybe it's still autumn, so while it's not
Yeah.
raining, you can go ahead and enjoy the ride on a bicycle.
Yes.
Otherwise, it will wait for the springtime, for happy times to come, hopefully without coronavirus.
Yeah, we all
And
hope
so,
for this.
yeah. So congratulations to Dmitro. Once again, my name is Lesya. I'm representing Luxoft company. We are very happy to meet you all. We have plenty of vacancies in Java. So people who are listening to me now, please don't hesitate to go and check them out. If we are speaking about Java, right? So we will be waiting for you at any time, and we are really eager to open the doors to the new career opportunities to all of you. So thank you very much.
Thank
Thank
you.
you. Thank you, Leslie, and thank you, Luxoft
Bye-bye.
company, for supporting our event this year. Okay, and we have just two partners left, and the prizes are getting bigger and bigger. So I would like to invite our next partner, Playtika company, and its representative, Vice President, Nir Pinhasov.
Hi, how are you guys?
Hello. Hello.
I'm speaking all the way from Israel, so I hope that you are all good there in Ukraine.
How is the weather in Israel?
Oh, it's beginning to be winter, very, very cold, around 20 degrees, very, very cold for us.
Poor you.
So, first of all, great conference. I think taking into consideration all the complicated times that we have right now, it seems like you nailed it. And I want to thank personally for the speakers from Playtika on this conference and the overall speakers. It was very interesting, and thank you for organizing that. And we're very proud to be also participating in those. I will share a bit about Playtika and then about the winner. Okay, so for those of you who don't know, Playtika is a leading game and entertainment company. Our mission is to create infinite way of playing. We are based in Israel, the headquarters in Israel, but we are big believers of Eastern Europe, and most of our development is here in Ukraine, Belarus, Bucharest, Dnipro, Vinica. We are very proud of all the departments that we have. I'm personally managing the shared services, R&D, and data development of Playtika. And I want to tell you that we have fascinating time in Playtika and a lot of vacancies and a lot of opportunities. So I encourage you guys to join, okay? So we are waiting. Today we are building like a platform that is basically being injected to all Playtika games. This is something that we are doing mostly in Kiev, and it's amazing times to join. With no further ado, I would like to announce the winner. The prize is huge. I want to tell you.
Oh yes, it is. It is.
It's a MacBook Pro. Okay,
Wow.
and yes, the winner of this MacBook Pro is Maxim Tichina.
Woohoo! Maxim, congratulations.
Yeah, that's an amazing prize from Playtika, and you are the lucky one. Thank you. So
Yes,
thank you,
Maxim,
Playtika.
join us, Maxim.
With a MacBook, join with a MacBook.
Thank you for everything, and good luck.
Thank you, Nils.
Thanks.
Thank you, Playtika, for supporting our event this year. So, we are almost done, dear participants. We have the last partner, our platinum partner, EPAM company, who we invite on the stage Katerina from EPAM, who will do the final raffle.
Hello, teams. Yes, so great to have all of you at Devoxx Ukraine, and not only despite the circumstances, but mostly thanks to the team, the great teams who ran this online event for thousands of participants, scaling the conference on the global level. This is really exciting to see how the conference grows from year to year. So thank you, guys. Also, big thanks to our speakers, because thanks to you, this conference is being expected each year, and you bring the value. So thank you. And as I'm here to give away some presents, let me proceed with this. So let me start with announcing the winners of our online bot challenge that we ran for the 2 days of the conference. So we have 7 leaders who scored the most of the points, and the 3 leaders, the first 3 leaders, are going to receive the hoodies. They are Tanya Gavrilishina, Alexander Mularevich, Viktor Gavrilishin. Also, Sergey Zdorenko and Denis Kuzmenko are going to receive wireless charging organizers, and we have 2 more wireless charging power banks, and they go to Alexander Vovk and Alexander Reshetnik. Thank you guys for participating. Hope you enjoyed the game, and thanks to our EPAM teams actually who prepared this game for you. So thank you. And now I think we shall proceed with the raffle. So we have 5 kinds of the presents, and we're going to hit the button each time we determine the winners. And let's proceed. Let's start with the 3 more hoodies. We have them for the winners of the raffle, and let's see who they are going to be.
Yeah, just a small technical.
Yeah, we have a technical little issue, but we will fix it in a few seconds. You will see now on the screen.
Okay, we are ready.
So the 3 winners who are going to receive branded hoodies go to... No?
Still some technical issues.
It happens.
Let's try one more time.
It happens like every time to us during the raffle at Devoxx. It's okay, we're used to it. Just.
But you see that this is a live session. It's not pre-recorded. We are live here, and you see how it's going.
Without it, I think I wouldn't be able to feel the atmosphere of the conference.
That is true. But we will do this. Yeah. Come on, Random Org.
I'm not sure, probably because a lot of names, but haven't tested it. It should work.
And what will be the price?
Okay, let me list while we're trying to fix the issue. Let me fix the prices. So, we have 3 hoodies. We have 3 wireless charging organizers. We have 3 wireless power banks. We also have 3 discount certificates for EPAM's master's degree program in software engineering. These 3 certificates give you discount to the program that starts next year. The duration of the program is 2 years. It consists of several modules on delivery management, solution architecture, engineering excellence, DevOps cloud, and big data. So this is going to be a huge contribution to somebody's professional profiles. And also we have 3 Amazon certificates for $300, $200, and $100. And we are going to raffle those really soon.
Like very exciting presents, especially the certificates to Amazon. Like this is the biggest prize, I think. So, Kate, while we're waiting, let's talk a bit. We have a time. So, what did you enjoy the most during the conference?
Well, I really enjoyed that this year. As I said, I'm trying to accept this not like the circumstances that made us go online, but as a huge opportunity to make the conference global. and the target that we set for ourselves that seem even unrealistic to ourselves, I believe, that we managed to achieve it, and this is really, I don't know, this is exciting achievement, and I'm really proud of our team.
Yeah, that is true. We had participants from like very interesting countries, from Nigeria, from Trinidad and Tobago, from Lithuania, from everywhere, I think, any country in the world. So this is very exciting. I hope that next year we will have an opportunity to meet those guys in person here in Ukraine.
Yeah, me too.
Okay, so how are the things going with the random? Okay, we're still fixing, so I will remind you a few things about the conference. So the next dates of the conference will be 5th and 6th of November 2021. So we will share with you link for the pre-registration. Please register if you want to be the first who will get the news from us on the next edition. And also on Monday, we will share with you our feedback form. So please go to the feedback form and put your thoughts here, like was saying, crazy ideas, some feedbacks, some just ideas that you think we can improve in our organization or in our content of the conference. Please share within your feedback form. We will be waiting for your answers. And also, please subscribe to our channels. We have a Twitter, we have a Facebook page, we have Instagram page, and the most important part, the YouTube channel, all the talks that we were managed to record during 2 days of the conference, you will see them on our YouTube channel, Devoxx Ukraine. So please, please, please subscribe. And now I think we can go back to the random org.
Let's try. So the hoodies, 3 hoodies. Will we see the names? Yay!
Yay!
Come closer. So, Pindua Daria from Odessa, Shamarin Alexei from Kharkiv, and Porubai Artyom from Kharkiv. So, congratulations, guys! You're going to receive Devoxx branded hoodies by EPAM. Let us proceed with the wireless charging organizers. We have also 3 of them.
And we are waiting once again for the next round. You see that by the end of the day we are like our devices are getting get tired a little bit, so it needed to reload, but still we are waiting. And as a reminder, I want to say once again, then please subscribe to our channels, to YouTube channel, to Twitter channel, to the Facebook and to Instagram. And on the YouTube, you will get all the talks that we got during the 2 days.
Okay, the next 3 presents. Ozan Beyza, Ankara. Sorry, just sorry if I misspell because I can't see well. Can you guys help?
Yeah, it
thanks.
is.
Thanks. Antipolas Andrius from Kaunas and Nevinska Yulia from Kiev. Okay, so I suppose, guys, to reduce the number of attempts, the next, let me read the next 3 names and what we have. We have power banks. Okay, so Janiga Dominik from Zhdansk, Krole Gregos from Krakow, and Linik Alexei from Kharkiv. They are going to receive power banks. Okay, and if we can hit the button one more time, let's see who are going to receive the master's degree program discount certificates. And starting from the from the first name, the person who are going to receive 50% discount for this program, and the next two 25% discount. So Gutseliak Vasil from Ivano-Frankivsk, you are going to receive the 50% discount, and Roman Artyom from Odessa, and Wisnitsky Thomas from Lviv. Guys, you are going to receive this discount, and believe me, this is a really great opportunity for you. And what is great, you are in Ukraine, but even if we would have the winners from another countries, there would be not a problem, because this is actually possible online, but still, you're from Ukraine, so you are going to join the program without problems. So we will get in touch with you to provide you more details. And so we have the 3 more certificates on Amazon. Let us see who are the winners. So 300 Amazon certificate goes to Rana Puya from Herndon. $200 certificate goes to Mizoglat Henrik from Budapest, and 100 certificate goes to Baratula Vanaya from Mumbai. Wow, really great list of countries and the winners. I'm really glad that we're able to, to award so many people from all over the world today. So thank you once again, guys. And one more thing, I would like to encourage you to also register for one more exciting conference that is going to be held for 5 days from EPAM. This conference is organized by EPAM. It starts on November 30. And this is going to be 5 days full of talks, like more than 100 talks from experts from EPAM in different technologies. So join, it's also free, it's online. So the link is still in your cabinet, so you have a chance to register for it. Don't miss the chance. Thank you once again.
Thank you very much.
Again.
See you next year.
Thank you.
Thank you.
Thank you, Katerina, and thanks to EPAM, our platinum partner at this event. So the raffle was very intriguing, yeah?
Yeah,
we were very
is.
excited to see the winners.
Yeah, but you know, it also proves that we have a lot of participants from other countries.
Yeah, so the results are also very, very surprising. So, dear participants, Devoxx Ukraine is officially over. I would like to take this chance and thanks once again to our participants, speakers, partners, and of course to the organizational team who worked on creating this event for you for the last several months. It's a FAST Group team, EPAM team, and Devoxx team, of course, and our technical staff who spent 2 days at this studio and venue together with us. So about 40 people worked on creating this event. So thank you so much, and I welcome you to join Devoxx Ukraine next year.
Yeah, it was amazing 2 days. I will miss those 2 days actually. It was unforgettable experience, first one, and we were the only from the Devoxx family who were doing Devoxx online this year. So I will look forward to the next edition, but I hope it will be offline in Ukraine.
I hope for it too. So thank you.
Thank
Devoxx
you.
Ukraine is over.
See you next year.